Hi, welcome to this Rhino for Architects course. Before we begin, I want to explain what this course is all about, what kind of prior knowledge you're expected to have to be able to take it, and why did I create it in the first place. So I guess we can start with the why. In short, BIM software such as Revit or Archicad is freaking expensive. It's expensive not just for freelancers but also for small companies. So my hope is to create a viable alternative for small-scale residential or commercial building design and documentation that is only based in Rhino and some free add-ons. I should note that there is a paid-for add-on called Visual Arc or RQ, which does bring BIM functionality to Rhino, but since it's not something that I would consider to be cheap, I will be skipping it in this course. Which I guess brings us to the aim of the course. What I want to do is to create a template and a workflow for the most economically viable or friendly, I should say friendly approach that can be used to train yourself or your staff so that you're not forced into using expensive software that have carved out monopolies for themselves. Clearly, this will not be ideal as Rhino is quite a general CAD software, so expect this workflow to break down on large-scale developments. But for smaller scale stuff such as residential or commercial buildings, this will be more than enough. If you are completely new to Rhino, please consider my Rhino for Beginners course before taking this one. I will assume that you've used Rhino and at least understand the absolute basics of Grasshopper. If you do not want to create your own templates, blocks, and scripts, please note that everything that I'll be creating or using in this course is available for both YouTube members as well as Patreon supporters. I will leave the links in the video description below. And with that being said, I guess it's time to just jump right into it. Alright, so let's begin. Actually, before we begin, I want to note that this whole course is divided up into chapters, and if you just hover your mouse over the timeline in the bottom, you can select any chapter that you want to jump to. And in this chapter, I'm going to talk about data inputs, right, into Rhino. So there are, I consider to be 4 types of data that you get before you even begin the design process of any project, and I'll try to cover all 4 of them. It's photo, laser scan, photogrammetry, as well as topography studies, right? So for this course, I have chosen a partial reconstruction project of an old house located in Vilnius, Lithuania, old watermill actually, because I feel like this will give us the highest range of, first of all, the input data, and second of all, different design decisions that we will need to make along the way. I will be able to showcase the most. So in terms of photo data, getting it into Rhino is really easy. You just drag and drop it in, right? So for example, if I select this image and I drag and drop it, right? Here it asks me what this image should be read as, and if you only want it to be an image in the viewport, you just choose picture, hit OK, and it's going to ask you to draw a rectangle in which the picture is going to be made. So I can actually predetermine the size of it, right? Something like that. Rotate, there we go, our picture. And the way this works is basically this is being treated as a surface with an image attached to it. So technically speaking, if I have a circle here and I trim with the circle, I can actually make a hole in the picture. Might be useful to some. Okay, and that's basically it. Actually, let's go through the pictures because I'm using this as an opportunity to introduce you to the project. Old watermill in Vilnius, or close to Vilnius, in rural Vilnius in Lithuania. Really run down, 200 years old, stone base, or basement / foundation. You have the logs here, and you have self-supporting roof that is only supported on the perimeter of the house. And basically the client only has this side, the left-hand side of the house, and the right-hand side of the house belongs to another person, right? So renovation is a little bit tricky. There are cracks in the foundation, and there are certain like weird temporary construction holding up the some of the areas in the interior, right? This is the basement floor. So with that being said, photo, really easy. Then we actually jump into immediately for a house that is really difficult, really complex in its shape, in the way of how it sags down and so on, old stuff. You do scanning, either laser scanning or photogrammetry. I will jump to those in just a second, but first of all, I want to show you the topography. Topography usually comes in as DWG file, sometimes PDF that you need to digitize, but in this case it is DWG. And I'll just delete the image here. And you also, all you need to do is just drag and drop it in. So DWG, drag and drop. And instead of opening the file, I'll choose to import the file, not insert. Insert works by creating a block. Importing is better. Hit OK. And here it basically asks me, the most important bit is it asks me what are the units. And I don't know, right? Because that just comes from municipality. I kind of do. Usually it's in meters, but for now, let's just say that my model is in millimeters. These units are in millimeters. I just hit OK, I agree to it, and it imports, right? I can see a bunch of layers created. I zoom out. I don't zoom out. I Control A, ZS, hit enter. Control A selects everything. ZS zooms selected, and enter actually locks in, what am I saying? Enter just applies the zoom selected tool. Okay. Anyway, so with that done, now I can see by just having my mouse here in the top view, I can see that the coordinates are out of whack. And they're not really out of whack. They are anchored to the, I believe it's the Vilnius post office being the 000 coordinate. It's something like that, or the municipality's building. So this is like the correct position away from the municipality in X, Y direction. I don't really care about that. I don't need it. So I'm just going to select the whole thing. Actually, let's type in show just in case. No, nothing was hidden. That's good. Control A, select the whole thing. And I will just hit M to move, enter, and just move it. Let's say, sure, this corner is going to be our new 000. So I just type in 0, hit enter, ZS, enter, to zoom selected again. So zoom selected always is a very useful thing to jump between things that are off screen, right? As long as you have them selected, and in this case, Control A does it. Okay, so now I have this positioned. Time to measure if the scale is correct. Distance from here to here. Actually, while we're at it, I know that there's different regulations for different countries, but in Lithuania, I know for a fact that between these coordinate markers here, here, and here, there should be one more. Nope. Okay, between these coordinate markers, we usually have 50 meters, right? So if I measure the distance between this coordinate marker and this, it's 50 millimeters, meaning that everything is, I should have imported it as if it was in meters. Very easy to fix. You just type in units, enter. And here, model units, instead of millimeters, you say that you're going to be using meters, right? Hit OK. Basically, it asks, would you like to scale everything or not? No, because this is correct. It's just the units are incorrect. So hit OK. And now if I measure the distance again between this and this, now we are in meters. Okay, so that's good. Basically, I now have the whole site plan imported, or topography imported with the surrounding sites. You can delete those, you can keep them. The way of how I clean this up is usually I just extract what is necessary. So, of course, the most necessary bits are the landscape altitude markings, right? As well as the ISO curves. And I will talk much more about them in the next chapter, where we are going to be building up the landscape. In this chapter is much more of a cleanup. Notice how in the layers, tab, there's so many layers that are created. Usually that's the case. Usually the geometry that you get from the municipality is very dirty. So to fix this, we first of all type in purge, enter, and we choose to purge everything, right? Hit OK. And then if I look at what happened, it tells me 450 unused block definitions were purged, 437 empty layers, 104 unused line types, and one material or two materials were purged, right? So already we have cleaned up quite a bit, right, of the layers. Now the further cleaning is going to happen at later stages, but basically what I will want to extract is going to be the border of the site, the border of the building, of course the border of the neighboring buildings, perhaps these ones as well later for rendering purposes, and the ISO curves as well as, oh sorry, that's the border as well, the ISO curves as well as this electricity line. Every time when you see B here, that's volts, right? That means that this is an electricity line and there is a pole here that's running through it, right? That is also important stuff. All of this will be extracted in the deal with the landscape chapter. I don't know the name of it yet. Okay, so that's how you import the municipality's drawings and generally how you operate with them, how you position them correctly. And honestly, the last step would be to create a new layer, call it topo import. Just get all of those layers in, except the default one, of course, and move them into topo import layer, like so, just so that we can open it and close it. There are people who enjoy using blocks for topography. If I type in block manager, can you see it? Let's make me smaller. I'm not that interesting. Put me here. There's the block manager, and this is like all the different types of blocks that are being used here. We will be removing them because we don't want to litter too much our block definitions here with unnecessary stuff that is really not that important for small scale development. So, but that is going to be later again. I'm just kind of pointing out different key things that we will deal with in the landscape chapter. Okay, now on to the fun stuff. This is 2D, that's done. We have our site plan. Now on to laser scanning and photogrammetry. So in terms of photogrammetry, usually you don't really need to change anything. By the way, for photogrammetry, I will have a separate course where I will teach you how to do it. If you don't know what photogrammetry is, it's basically taking a bunch of pictures of the building, just going around it, and then recreating the 3D model of the building through software such as Reality Capture, right? In this case, my photogrammetry 3D model, I'll already have done it. It's reduced to 2 million polygons. And if I just drag it in here, import it as a file, bam, here it is. And then if I zoom, look at it, of course, change this to shaded view. There it is. So when you import a photogrammetry model, right, the way it works, first of all, usually you will have a lot of separate meshes, right? That is a problem. Or not really a problem, but that's something to be mindful of. What I like to do is just select everything and join it all up. Oh, sorry, my bad. Actually, the colors work, but the texture will break if we do this, I believe. Let's just check. I'm learning something. Yep, the texture breaks if we try to join it all up. So let me just Ctrl-Z it and keep this separate. And the reason why it's breaking is because every mesh here has its own material assigned to it automatically. So if I go to the Materials tab, by the way, if you don't see these tabs, you can always click on this little gear icon here. is it? Yeah. Gear icon, new toolbar. Nope. Oh, sorry. You right click. You don't click on the gear icon anymore. You just right click and then you can choose which tabs you want to see. So I have my display, actually help doesn't matter, my layers tab, materials tab, notifications doesn't matter, properties tab in the top portion, and in the bottom portion I have my block definitions, my named views, my snapshots, speckle, speckle mapper, and sun controls. Right? Back to the photogrammetry. So you can see here 1, 2, 3, 4, 5, 6, 7 different materials that are already automatically created. And here we have 7 different meshes. Usually when you export stuff from photogrammetry software, you do that in FBX format or OBJ format. And both of those do associate material with the geometry, right? So you don't even need to create your own geometry. If I look at the size of it, the model itself is 141 megabytes, while the texture, actually the FBX was only 63 megabytes. And the textures, all of the textures are 38 megabytes, which is really, really decent. If you want to see the photogrammetry images that I took, these are the images. You basically just go around with the camera, you scan the building, and it just recreates the 3D model. So I'm going to have a course about it a little bit later on. If you're watching this 2 months after the release of this course, probably already have uploaded it. Anyway, so we have ourselves the photogrammetry model. This is good and nice. The problem is that the scale is incorrect. And there are a few ways of how you can fix it. First is just by simply going back and measuring, a certain dimension. Preferably, the longer dimension it is from here, let's say to here, the better, the more accurate you're going to be. But if you can't go back, if you can't do it, for example, now I'm in Sweden and this is in Lithuania, then the best way is to cross-reference with other material, such as the site plan or laser scan, because laser scanning does have, laser scanning does have scale associated with it, so it's correct in its scale. Before we move on to laser scanning, I just want to clean this up a little bit. So what I'm going to do is go to my layers tab here, and I'm going to create a new layer and call it photogrammetry. Select my geometries and change object layer and hide. We want to, all of the data that we import, we want to keep it separated, keep it clean as possible. Okay, next, laser scanning. So in terms of laser scan data, it's either these kind of expensive $10,000 machines or an iPhone, the newest iPhone. Both do a similar thing. Basically pushes out a laser beam, calculates how long it took for the laser to come back, gives you a point, away from the laser beam. Of course, the more expensive ones are more accurate. This has been done by a professional company, and it is exported as E57 format. Sometimes, and E57 is the format that Rhino can actually use. Actually, let's start with this. So if I just drag and drop this in, as per usual, import, okay. Rhino will be able to open this as a point cloud. Please note that the point cloud is indeed 700 megabytes, so it's not lightweight at all, but it imports quite nicely, right? And the benefit of a point cloud is that you get stuff on the inside. This photogrammetry model is hollow on the inside because there's not enough light, right? Photogrammetry requires light. Laser scanning produces its own light. Let me hide the topography input. So Here we have much more data, but this is not geometry. That's the first problem, right? Since this is not geometry, modeling on top of it is a little bit annoying, a little bit hard. Second thing is sometimes when you do scanning, laser scanning, you don't get E54. Is it E54? 1 second. 57, E57 format. You get .las format. Rhino cannot read .las format, so the best way to do it is to convert it. How do you convert it? Glad you asked. There's free software called Cloud Compare. Bam. This one right here. If you just Google Cloud Compare, you'll get to this website. You click on download, and don't download the alpha version. Just download the regular one, and it's a weird user interface, but if you hover your mouse, then you can choose either download the installer or just a zipped version, archived version. Just download the installer, install it. It works on literally anything, even a potato. So let me just open it up. The way of how you operate with the software is very simple. There's two things that you do. Thing number one is converting a point cloud from one format to the other. You again drag and drop in, laser scan, drag and drop in, boop. Wait for it to read. 30 million points, by the way. Right? Can take a look at it, and this is, you can see here .laz format, and to just export it, you file, I believe it's save. Yeah, and then here you just choose E57 and it just saves it. Super simple. If you want to convert this into a mesh, it's not that simple, but still pretty easy with the same software, by the way. You use the same software. So you go to, first of all, if you just try to convert this, I believe it's going to scream at you. Let's see if it does. If you go to plugin, Poisson reconstruction, that is grayed out. Let's select it first, then go plugins, Poisson reconstruction. Cloud must have normals. It doesn't like it that there are no directions, like it doesn't understand what's inside, what's outside in this point cloud. So this is like one of the biggest issues with constructing a mesh from this. But fortunately, we can go to tools. Is it tools? No, sorry, edit, normals, compute. I would suggest just using the default values, hit OK. So this took like 20 minutes or so. And now when we have the normals here, calculated, I can actually click here, go to plugins and use default values for Poisson reconstruction. I will not be doing that right now because I want to do a few more things in Rhino and then run this when I'll have a break. I know that this will take a few hours to calculate, so 30 million points. What can you do? Before I actually run it, I'll go to Rhino here, and the first thing that I want to do is properly align the scale of these. And it's quite simple. Simple really. I know for a fact that the laser scan is correct in its size. It's accurate to the centimeter, I believe, but still much more accurate than the photogrammetry. So I'm going to group up the photogrammetry model and I'll start positioning it, right? So first things first, let's check the clipping plane. Use the clipping plane to check how it looks like on the inside. The black points really don't help, do they, for the inside? That's annoying, but I can really see that there is geometry in here. It's just that it's painted black. It is what it is. So now to actually position the building, all I need to do is, first of all, let's get rid of that clipping plane for now. Rotate it properly. Move it in place. So you first align it in top view, and then you start aligning it vertically, right? This change to shaded. By the way, for shaded view, I have mesh wires turned off. You can do that by going to display, mesh wires, and have this unticked. That helps out quite a bit. Then in the top view, I make sure that shaded is turned on, and I make sure that the altitude for this is correct, like so. And slowly you're starting to shape it, right? Slowly you're starting to position it in a way which would align. So here, the scale of the photogrammetry model, I might have scaled it already, oops, but it seems to be fine. But I would kind of go through this, like in a half an hour, I would go through this little by little and make small adjustments, small rotations, and so on for the two models to see them align as well as possible, right? So for example, the point cloud that I have here seems to be a little bit off. And the new trick with clipping plane is if I go to the settings of it, I can choose depth to be predetermined, so custom depth, and I can say 1 meter, oops, not 11, 1 meter, and only work with a fraction of the two models, right? So here clearly this needs to be positioned, and at this point I can see very clearly that the building here is a photogrammetry building is bigger than the laser scan, right? Because it just goes out of bounds in all places. So I'm just going to scale it down without numbers, without anything, holding down the shift key. Of course, you need to hold down the shift key so that it scales uniformly, something like that. And basically this is going to be half an hour type of a thing of me just adjusting it and trying to fit it as well as I possibly can, changing the position of the clipping plane, trying to position it here properly so that it aligns, and so on. I will not bore you with this, we skip ahead. While I will be doing this, I will be also running plugins, Poisson Reconstruction, this one, so you will see the 3D model that is generated from the point cloud after our little break. I'll tell you how long it took. 4 hours, almost 5. But now we have some material to work with. Step 1, points, right? I recolored them because the black color was really not working for me. Now at least if I use a clipping plane, recoloring is also done in the Cloud Compare. Very simple, definitely not a Cloud Compare tutorial, so I'm not going to be showing it. But now, you can clearly see what's going on. Well, by clearly, I mean you can kind of see what's going on in the interior, right? So that's my points. Second, the photogrammetry, I guess, aligned with the points to the best of my abilities, right? On all sides, everything seems to be aligning properly. Third one, the 5-hour meshing that Cloud Compare did of the point cloud. Don't be scared of it. Bam. That's how it looks like. And I trimmed it off a little bit so that it's not too much. But this is how it looks like, right? You can see some mistakes, and the roof only scanned from the inside, not from the outside, and so on. This is mostly an interior scan, not an exterior scan. So if I look at it together with the points, you can clearly see that the scan does follow the points quite closely. If I use clipping plane, the mesh follows the points quite closely. This is, by the way, a very, very large mesh. Oh, come on. Okay, so the clipping plane really likes to fill in the space. To not have it do that, you go to the settings, to the display settings on the right-hand side, scroll until you see at the bottom, clipping plane sections, show fills. You tick mark that to not show fills. And now you can easily see what's going on and what kind of a situation we have in the interior. Let me hide the points. Bam. Right? So this is like the second floor. Yucky. And the first floor is even yuckier. I do remember that this whole area was full of junk. Of course, this surface does not exist in reality. This is an error, a mistake of scanning, or meshing, I should say. There's like some old window there. But all of this is quite clean and quite informative. So this is going to be sufficient to actually build out the interior of the whole building. And then if I look at the basement, remember that area where I showed the weird columns that are barely holding something that is crumbling? This is that area, right? If we look at it from this side, that's the scan of this area, and it seems like it's all that it's doing is it's holding this this single column that poor thing needs to hold this beam on which the whole second floor rests. Structurally, Jesus Christ. This is really needs a reconstruction. So this is the data that we have, right? We have the mesh, we have the photogrammetry that kind of aligns with the mesh, a little bit misalignments here and there, but besides that, I mean, pretty damn close. And then we have our point cloud. With these three, it's going to be sufficient for me to rebuild not just the building itself, but also this is going to help a lot with the surrounding data, with the surroundings. And lastly, the trees as well as electricity poles. That is going to be quite important when we will be deciding on how to extend this or expand this and so on. Okay, so with that being said, we are kind of done with the inputs. Well, I guess the last bit to do is actually to work with the topography import and align it properly to the house. And the way you do it is you just right click on topo. Oh, actually, which one do we use? I guess we can use the photogrammetry model. We will align it to the photogrammetry model, I guess. Because there's definitely a clean, well, define clean, but clean-ish corner here to which we can say with vertex snapping turned on that the topography will be oriented along this point or on this point. So then I just simply right click, topo import my layer. I select sublayer objects. I have already pre-aligned this to be running along the y-axis, right? While this is not. So actually, apologies for jumping around, but it would be a pretty good thing to just, in this layer, in the top view, just somewhere draw a circle and mark yourselves a north arrow. So from center upwards, that's going to be north. Later, for alignment purposes, this is going to be quite useful. And with that done, we just right click, select sublayer objects, rotate. This needs to be vertical. Or aligned, sorry, it needs to be aligned with the y-axis. For some reason, this is crooked. One thing that I should note is that these measurements that you usually get from the municipality are not that accurate, right? So this is going to be, I mean, I take these measurements, the official ones, with a grain of salt compared to the 3D scan data, right? Because 3D scan data is objective, while this is, can have human error and whatnot. And basically from that point then, I just simply move it to this point here, like that. Seems to be hugging it quite well though. That's good. And then I can, honestly, either move this up or move this down. In this case, I will be moving this slightly above the house, just so that the next steps that I'm going to be working on, the house will not get in the way. I can always easily move this down, right? And with that being said, we're kind of done with this at this step. We have all of the data imported into our Rhino model, and from here on out, we can move forward. So next chapter is going to be creating the damn landscape. All right, chapter 2, landscape making. Before we begin, I want to say that if you are a Patreon supporter or a YouTube member, you do get access to the 3D models as well as the scripts or the blocks or the templates that I am making in this course. And the way they are going to be organized is going to be after every chapter. So now we're at chapter 2. So I'm working with chapters 1 3D model. After every chapter, I am saving the model of that chapter so that you can continue on working on the next chapter. I hope it makes sense. And of course, this does not mean that if you don't have the models, you can't follow along. You can. The way of how I construct this course is that anyone can follow along with your own files, because I'm going to try and keep this as general as possible. So it's not going to be super specific to the exact 3D model. Hope that makes sense. With that being said, we can begin. So there are two things that we need to kind of look into. Thing number one is what kind of a DWG file did we get from the municipality? Did we import from the municipality? And second thing is everything here, right? Or is there stuff that is way out in the distance somewhere in this import? So I'm going to, first of all, let's see that what we see is everything that we have. I'll type in show, first of all. Show makes sure that everything is shown. And then I'll type in, or not type in, just hotkey, Control A. Select everything, sell all, and then ZS, enter, zoom selected, enter. And I can actually see that there are these contour lines floating above my landscape. Not my landscape, but my DWG file. And this is usually the case. If you have contour lines in the material that you import from the government's websites, or whatever, from government's measurements, usually the contour lines are already placed in the correct altitude. By correct altitude, I mean above sea level, right? So if this altitude right here is sea level, this is how far up the actual landscape is above the sea level, right? So that measurement is already there, baked into the alignment of the curves. Besides that, this is a little bit less accurate way of how to build out the landscape, like from these contour lines, clearly, because the step size is usually 0.5 meter, compared to using the altitude points, landscape height points, right? These guys right here. And I'll come back to them in just a second. Right now, the building is a little bit in the way, so I'm going to hide the scans layer. And we're just going to look at what we're dealing with. So first of all, let's go to the top view so that it's not annoying with the perspective. It's not twisted. And just look at the types of geometries that we have. We have a hatch, which is just depicts that all of these guys are, or all of this area is grass. It's just grass. It's dirt and grass. Easy. We have, of course, bushes. We have trees. We have, I guess these are called like anchoring marks. So the whole city of Vilnius is divided into these 50 by 50 meter squares, right? And this is just the way of how you can position yourself quite easily within the city. But we don't really care about those. We have outlines of the buildings. We have, the red line is a power line, 400 volts power line that goes through the site. We have site boundaries. What else do we have? Of course, altitude points, already mentioned it. And also we have the river, right? The blue is the river, and there's a bridge here. And a bunch of surrounding sites that we don't really care too much about at this stage. Also here, this demarcation is a fence of the neighbor. So as I said, the building has two owners. One owner owns this side of the building, this portion, and the current owner, the client, owns this side, right? So there is a little fence where, you know, this guy has fenced off this area. Oh, and there's a well here. We don't really care about the well as well because it's on the neighbor's side. What we care about is the altitude points, and we care about the, where's the we're in the top view. We care about the contour lines. Those are the two ways of how you build out the landscape. Let's get them in a separate layer. So I'm under the landscape layer, I'm going to create a new sublayer and call it GH_input. GH stands for grasshopper. We're going to be using grasshopper for this. Inside of GH input layer, we're going to create a sublayer called, well, let's do a simple one, boundaries. Boundaries. There are two boundaries. One boundary is of the site itself, this one. And the second boundary is the boundary for where the measurements were actually made. So the cutoff boundary for the measurements. We take both of them and we right click on the boundaries layer and we copy objects to layer, not change, but copy. The reason why we copy is because we want to keep the original, right? We don't want to mess with the original. Apologies. Next. Sorry, God damn it. Next step is to get the contour lines in, right? So I'm going to make a new layer, or sorry, new sublayer inside of Grasshopper input. I'm going to call it contours. Contours, that's easy. And the way you select the contours is quite straightforward because they're high up, right? So just in the front view, select all of them, right click, change object, copy objects to layer, and we have our contours now copied into this new layer. Then one more, one more sublayer, call it, I guess, points. Those are not going to be points, those are going to be like text plus blocks, like these two, but we're going to get them in there anyway. Before we actually, into the points layer anyway, before we actually do this, we need to investigate what kind of a geometry this is, because I have a hunch. I don't have a hunch, I know. This is a text, that's easy, that's good, that's what we want. This is not a text, this is a block instance. Block instances are kind of annoying to deal with. We could technically begin working with blocks early on, but for this stage, I would suggest not doing that. So what we do is we select one of these guys and we explode them to see what actually it consists of. And the block instance consists of a hatch as well as a boundary curve. And I have no idea which layer they are in, right? Because it became black, so that clearly they're not in the same layer as the text. So now, what we need to do is we need to figure out. The way you figure it out is by using a command called select layer, clicking on select and choosing we only care about the curve, choosing the curve, right? It doesn't tell me why. Oh, it does. It's under topo import 0 layer. That's the layer that we will want. Right, and if I hit OK, that's the only thing that gets selected. Okay, fine. We now know where the layer is. We need to kind of remember it. Second thing is to actually get all of these guys, all of these blocks, right? So the way of how I do this is I select one of them. I type in block manager, and I pray. Yeah, it seems like this is a block named 21. Can you see it? Right above my, right there. It's a block named 2131. Your block definition might open up in a new window, that's fine as well. And there are 101 blocks in here, I think. No, object count is only 2. God damn it. No, never mind. Object count is not 2. Objects that exist inside of the block are 2. The hatch and the curve, and actually there's 101 blocks. So by right-clicking then on it, select instances, I can select all of the blocks here, and I can just explode them, right? And then I get my 202 objects. Half of them are hatches and half of them are curves. That's good. That's what we want. Sorry for the confusion. Then we need to get all of the curves and hatches together with the text into our points layer. right? So the way we do it is cell layer, and let's get a text first. Select the text. Let's click on select the text. Okay, the correct layer is selected. Hit OK. We have all of the text in here. And in this case, the points, they are too messy, so I'm not going to be making copies of them because that's too much. I'm just going to right click and choose change object layer. There we go. Let me make this layer red so that you can see better, right? So now all of the text is there. Next step is to get these guys in. Cell layer, select, click on the curve or the hatch, doesn't matter. It selects the layer 0, hit OK. Selects all of these points here, and I just right click, change object layer to here. Great. That's kind of all we need. So now I can hide the topo import original layer, and now this is the data which we will be using to construct our landscape, right? So back in here, there we go. Where do we begin? I guess we can begin with the easier one. We can begin with the contour lines, right? Because the contour lines and creating a landscape from contour lines is really straightforward in Grasshopper. Technically, you could do this manually by, lofting this in patches and so on. But as you can see, the contour lines are a little bit messed up because there's, for instance, a staircase here and so on, which is not great, right? Manual work in this case is a little bit rough. So we will be using Grasshopper, which is a scripting tool inside of Rhino. Don't be scared of it. If you want to learn more of Grasshopper, I have a course, a 12-hour course. I'll leave a link to it in the video description below. And the course, you type in Grasshopper in the command line and then it loads Grasshopper. Forgot to mention that. The course is aimed at, giving you complete foundational knowledge so that you can make your own scripts in Grasshopper. But this is not going to be, the case here. What we're going to be using Grasshopper in this case is just to optimize the workflows and not make any fancy stuff. So I'm going to keep it. Some stuff that I will do, if you are familiar with Grasshopper, some stuff that I will do is going to look a little bit weird. And why did he do it this way? You could kind of script it in a little bit more easy way or more shorter way. The reason why I'm going to be doing all of these things is because I want the scripts to be as simple as possible, right? So with that being said, we can begin. So step one is getting these curves. Oh, and all of these scripts that I do will be available for you, as long as you're a Patreon supporter. We need to get these curves into Grasshopper, right? We need to reference them in and then operate with them within this scripting interface of Grasshopper. Actually, let's minimize it for a little bit, like Grasshopper tab. And let's investigate why the hell are these curves orange while the contours layer is black. And if I change the contours layer, that's blue. And if I hide the contours layer, the curves hide. So they are in the layer. So why are they orange? Well, clearly the color of them is overridden. So I select all of the contours. I go to the I go to their properties. I go to the layer. The display color tab, and I just choose by layer, another blue. Ooh, ugly blue, very ugly blue. Let's make them green. There we go. To reference them in, there's two ways of how you can do it. I'm going to do it in a much, it's a little bit more difficult, but it is a better way. So bear with me. What we want to do is we want to reference all of the objects that belong to this particular contours layer, right? And we will be doing this throughout this whole course. So this is going to be very repeatable, let's say. So, and if you can't find your Grasshopper tab, just type in Grasshopper again and it's going to pop right back in. And you click off the first time running Grasshopper prompt. Back to referencing. So this needs to be referenced here so that we can operate with it, make changes. And the first thing that we do is we double click in the Grasshopper tab and we type in query model objects, and choose node that pops up here. What this will give you, and it will take a little bit of time because this is freaking annoying that it needs to query then our scans as well. It's a not very well optimized tool. Bear with me. Bear with it, first of all. It takes a little bit of time, but while this is kind of lagging for all of us, I'm just gonna talk. What this does, this node does, it fetches geometry from any specific layer that you give it. And let's make things a little bit easier for us. Let's go to display in the top of Grasshopper tab and choose draw full names, so that we get something like this. And I will also use bifocals. You don't need to use bifocals. Don't worry about bifocals. Basically, it just gives you the name here. Then we want to reference everything inside of this contours layer, right? So this is the layer input. The way we do it is we create a panel. You can either click on this orange guy here, or you can double click, type in panel, or the shortcut for it is double click anywhere and type in // 3 ways. I'll just type in panel. Let's keep it consistent. And then connect that to the layer input by just dragging over a wire. Then inside of the panel, we want to make a reference to this. It's quite simple. You double click on the panel and you type in, okay, inside of the landscape layer, there's a Grasshopper input layer. Inside of that, there's the contours layer, right? The syntax is this: landscape. I don't know how do you call this in English. The 2 dots. 2 dots twice. You know, if that makes sense. How do you call it? Okay. Where's my... How do you call this symbol? Colon. Okay, colon. You use double colon. Landscape colon colon. Grasshopper GH input. GH underscore input. Colon colon contours. Also don't do this. Don't hit enter. If you hit enter, this is gonna start freaking out, right? Because you're making a second line. So if you hit it enter backspace, make sure that it's one line and just click outside of the panel. With that done, we have ourselves a referenced geometry. So to make sure that everything works, you can click on this, you can hide the contours layer, and then you can see that this geometry is now referenced. And now we have our objects in here. And you can see if I hover my mouse over it, it says a bunch of model curves, right? A bunch of curves in here. That's great. We want to then get a bunch of points on these curves. So I'm going to use divide curve, I guess. Sorry, not divide curve. Let's do divide length. Divide length. Asks me to give it a curve. We give it a curve. Asks me to give it a length. And here we need to decide how often are points placed along this curve, or any curve, right? So I'm going to say every 20 centimeters. So we are in meters, we're working in meters. So I just double click and type in 0.2. Click. Gives me this number slider. It's quite useful as well. I'm gonna show you why. We connect that to the length. And now that's too many points. That's way too many points. This is every 20 centimeters. It's way too many. So if I increase this, I can drag the slider. This is now a point placed every meter. This seems to be a little bit more reasonable. Still a lot, but will do. This will do, right? So 0.2 was a mistake. If you want even more, you can do 1.2, let's say. Connect that instead of the original one, you know, and control it like so. But one seemed to be okay. I'm going to keep it. From all of these points that we have, we want to then construct a mesh. We want to create a mesh geometry. And basically, the problem is now that every single point is not just placed in like a big, or all of the points are not placed into one big list. They're actually placed in separate lists that correspond to separate curves, so that a point knows which curve it was extracted from. That will mess up our mesh, because it's going to make a mesh for every curve. That's not how it works. So we want to clean this up. The way you clean this up is by using flatten tree tool. Connect points to the tree input, and then you get all of them. They don't care anymore. All of them are in the same list. And at that point, we can use a command called Delaunay or Delaunay. I still don't know how to pronounce it. Delaunay mesh. Not edges, mesh. Connect points to the mesh input, or to the points input, and voila, it gives us a landscape. Not great, but it's gonna be great once we're finished with it. If you want to see this a little bit more clearly, also let's select everything else. Click the scroll wheel and choose this guy on the 2 o'clock disable preview, so that only the mesh is shown. You know, this is what you usually get from freaking, I'm gonna get there, ArchiCAD or any BIM software, right? This kind of Delaunay mesh. So we have successfully created a script that replicates ArchiCAD or BIM software making from contours. Let's keep going. So this mesh is, to actually display it properly, you can use custom preview node, connect mesh to the geometry input, hide it there, and go to like Arctic view or something, you know, where it kind of, it's shiny and nice and shows you the landscape. Low resolution, not so nice, jagged and so on, and also it's a mesh, so it's kind of hard to work with. Let's make it better. First thing is to get, notice that actually in the top view, it's going to be easier to notice. Notice that the mesh does not reach the edges of the measurements that were made. It kind of reaches the edges it should. Hello? Am I blind? There we go. It reaches the edges of the inner side, almost, but it doesn't reach the edges of the measurements that were made. You can always add in more points to the geometry, to this Delaunay mesh input right here, by taking the side contour and basically placing points around here, creating, I'll show you. We will not be doing it for this tutorial, but or this course, but I'll show you how it works. So I make a bunch of points. And by a bunch, I mean like 2, 3, 4, cell PT, that's faster. How many? 8 points. I move them to the, since there's no measurements here, I'm doing this by eye, right? So I'm moving them to the kind of correct position here. And I'm going to be, what the hell is this point doing there? Oh, yeah, it's that one. Okay. And I will be just getting them into the Delaunay mesh calculation. So actually this one is unnecessary. Select all of these points, right click on the point input. The point node is this point, this black hexagon. It's like a container node. So select all of these points that we have moved, right click on them, set multiple points. Now they are referenced, and holding down the shift key, you can connect your added endpoints to the Delaunay mesh so that it kind of uses them as well. And then by simply moving them around, or by around I mean up and down, you can create a proper positioning of them. Really not necessary to do so. But if you want to, you can, right? So that's like an alternative. I will not be using it for this particular example. I'll be using it for the more detailed altitude points example. Okay, let's continue. So now with this Delaunay mesh done, we want to clean it up a little bit, make it smoother, make it nicer. The way you do it is by remeshing it using quad remesh. Asks for geometry, that's our mesh. Asks if there are any guides, like guiding curves or not. There are none. Oh, and I have hidden the Delaunay mesh by right-clicking on it and choosing preview, or clicking the scroll wheel and choosing the blindfolded guy icon. There are no guides for the curves as to how the geometry should flow, but for the settings, I will be changing the settings a little bit, just so that I can show you. So settings, quad remesh settings. Connect that. Don't be scared of the big node, that's fine. The only thing that we care about is target count. Target count is how many polygons will it create. So in this case, default is 1000. I can say 500. If I want to have less, less resolution, I can say 5000. If I want to have more resolution, up to you. I will keep this at 2500, something like that. For this kind of site, it should be sufficient. It's not accurate at all, so like the contour lines are not accurate at all, so it doesn't really require high resolution. So now we have a mesh, and then from the mesh, we want to have a surface. We want to create a surface, right? So I'm going to convert, or is it convert? No, it's NURBS. Mesh to SUBD. We will be using SUBD geometry, or SUBD from mesh. We will be using SUBD geometry as an between a mesh and the NURBS. Mesh goes into mesh. That's easy. We don't need to do anything with this. Hide the quad remesh. Now you will see, don't do this, but I will show you. This is the SUBD version, and this is the mesh version. Chick, 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 polygons, whoop, curve. It smooths everything out. It makes sure that the continuity of the geometry is like it's continuous. It's more organic, right? So we have ourselves SUBD, and then SUBD to, or is it SUBD to? No, NURBS. Okay, we go to Surface tab here in the top. We go to SUBD tab, and we find that there is no. Am I losing my mind? I could swear that there was surface from SUBD. Okay, NURBS, SUBD, SUBD from mesh, subdivide fuse, mesh from SUBD. What if we just say brep? 1 second, please hold. Yeah, okay, that just works, I guess. But it then makes a ugly brep. Okay, never mind. This is where we stop, and we actually get this back into our Rhino model, right? Because the next stage is going to be for this SUBD to be converted into NURBS, but we do that manually. I could swear that there was a tool that does not. Anyway, right-click, bake. Right-click on the SUBD from mesh node. Right-click, bake, and then we need to bake it out. Okay. Cancel, sorry. Before we bake it out, we need to create a layer to which we will be baking. So we don't use Grasshopper input. In the landscape layer, big layer, we create another sublayer called 3D Geo, or yeah, we can just call it 3D, that's fine, 3D. And inside of it, I'm going to create a sublayer called From Contours and make this beautiful green color. There we go. Landscape 3D from contours. There's going to be another one from altitude points or from points, something like that. But now this one, right click, bake, from contours. You don't need to group it or anything else. That's everything here is fine. Hit OK. And now if you hide the SUBD from mesh, now we have ourselves the SUBD geometry here. Those of you who work with SUBD know how it operates. Those of you who don't, basically SUBD is in between a mesh and the NURBS geometry, so it has characteristics of both. With SUBD you can Control-Shift select an object and you can drag, you can manipulate it this way. Of course we don't do that with landscape. This is too uncontrolled, too organic. It's like very, very funky to work with. So instead we want this to be NURBS. I select this object, type in two NURBS, 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 For the objects, delete input objects. In this case, yep. So options, delete input objects. Yes, and for sub D options, keep it default. Trust me. Keep it default. No need to change anything there. Hit enter. Voila. We have ourselves a NURBS surface now, right? So to actually make it into a solid, if you want to make it into a solid for some reason, you can duplicate border of it, dupe border. Holding the Alt key, you can drag down the, not the surface, my bad. Drag down the curve of duplicated border. Use the scale along the Z-axis of the gimbal to make it flat. So you scale it to 0. It becomes flat. Maybe it's a little bit too thick of a boy here. And then you can select these two guys, these two curves, loft between them to create a ribbon running around, join them up. And then the bottom is flat, so you can cap it. The moment you cap it, this is a closed poly surface. You can CNC mill it out, you can 3D print it, you can do whatever you want with your new landscape. Congratulations, you have managed to make a landscape in Rhino. And of course, since this is a NURBS poly surface, you can easily, let's say this is your building. I know we have a building already, but I'm just going to show you with the box. Boolean difference. So as you're CNC milling out the pocket, of course the pocket should be bigger because CNC mills have fillets as the, the radius of the drill bit. Doesn't matter. But basically you can manipulate, you can do Boolean operations with this landscape, which is very nice. Very nice. So for this, we are kind of done, except for the one last bit. The last bit is called positioning the landscape, right? Because now it's floating way too high. So I will turn on the scans layer and move this down. This is not going to be, there's no way for it to be accurate because the scans layer is not geo-referenced, right? 1 second, rendered is gonna look nicer. This model is not geo-referenced. Neither are the point cloud scan, neither is this. Neither one of these models are geo-referenced, meaning that they don't know at which altitude they're at. But even if we have a 1 centimeter error, I don't think that's going to be that big of a deal, right? So what I do now is I just position the landscape. Let's go back to shaded view. I'm doing my best with the clipping planes and so on. I will be doing my best to position the landscape so that it's not sticking too far out from where the control points are, or sorry, point cloud is. And we can do it with the clipping plane. If I go to the settings, custom depth, 1 meter, so that it's not too much. You can clearly see how much information is missing. So this whole dip here is missing. And the altitude should be a little bit, something like that. There's a little bit of a hill here. So that seems fine now. And then there's the whole building. And then here, this is way off. Well, is it? It's not that it's way off, it's just an error, right? An error that you get with that little data compared to how many measurement points laser scanning does. So stuff from municipality that you get is never going to be accurate. Neither the contour lines nor the altitude points are not going to be accurate. It is what it is. But it's better than nothing. But the best way to do it is by actually scanning the landscape with a laser scanner. With that being said, this is now positioned properly and chapter 2's first part is complete. I can hide it. On to the second part. So let's go back to Grasshopper. Let's turn off the scans and let's turn off the, actually nothing else. Yeah, that's good. Second part, we have ourselves these picket points. And one thing that I'm going to do that I think is important is I'm going to remove the redundant altitude points from this. And before I do that, I also don't really care about hatches in this case. So I'm going to type in cell hatch, delete, get rid of the hatches. So for instance here, right, 4 points, and with one of them, this one surely is not necessary, right? So I'm just going to get rid of it. Like, because it's just going to, like, these kind of points that are overlapping and are in between are just going to confuse the software. And you don't really need to take too much effort in this, but the more you do this, the better. Like, all of that is clean. Maybe these are very close, and the difference between them is, actually, that's pretty big. Why the hell is that difference so big? Is there a step here? There is, yeah, there was a step. It doesn't matter. Don't care about the step. Don't care about the step. There's just like a step downwards there. That is going to be filled up either way. And these two guys, 17 centimeter difference, don't care. Oh, that's very overlapping. Don't care. All of that is good. And that's it, right? So usually I cut out these kind of things from the video, but here I just wanted to show you that it's actually not a lot of work to clean up, these kind of sites. And with that being said, this one also needs to go. Okay, great. Now on to making a landscape from this. A few problems. Well, okay, before we do that, clean up here so that we know what script does what. This script from contours makes a landscape. I will select the whole thing, click the scroll wheel, click on the little group icon here, right click the group, and let's do this properly. Select everything, click the scroll wheel, group icon is at 12 o'clock, the green fidget spinner, click outside, right click the group, not a node, but anywhere on the group, and call it land reference layer arrow. We reference the layer. Take contours. We take the contours. Build mesh. Build sub-D. Definitely a good idea always to do this. And then you can also do scribble, double click, and just write it contours to 3D. Landscape contours to 3D. And just add to group. There we go. So now we have this block. You can use it for whatever project you want, as long as that your contours live in this kind of a layer structure, right? So keep in mind, the layer structures are basically a template that you use for every project from now on, and you need to just kind of use a specific template so that everything works seamlessly. I suggest using mine, because you're learning on it, so might as well. All right, also, before I forget, let's save the Grasshopper file. It does not save with the Rhino file. Grasshopper files are separate entities, separate files that can be opened with any Rhino model and used on any Rhino model. So if there is another Rhino project that you're working on and it has this layer sequence or whatever, a contours layer living in the Grasshopper input layer, living in the landscape layer, this Grasshopper script is going to fetch geometries from there. So you're doing a tool, you're making a tool rather than you're only working on this particular model. I think that's very important to note. So I'll file, save document, desktop, where's our Rhino for Architects, and I'll call this landscape. Just landscape, save, that's done. Okay. Step 2, not step 2, part 2 of chapter 2. Points. Problem with points is they are flat. They're horizontal. There's no height to them. Contours already have been moved up for us. Points have not. That sucks. That sucks because that means there's going to be more work to be done. It's okay. We can do it. We need to get these guys in, first of all, into our Grasshopper script, Grasshopper file. So I double click and we use exactly the same thing as what we used before. Actually, let's be lazy. Let's select these two nodes, Shift key to select two, Control C, Control V, copy paste, drag them over. No need to, do this all over again. And then these guys live in a layer called points. So instead of contours here, I will double click and type in points. No enter, click outside. Okay. If I look at the output that I'm getting, there's going to be a slight problem. Don't do this, no need to do this, but this is just for me to show you. Model text entry, wrote in Times New Roman, all of that is good, entity. Those are the numbers, that's fine, with the font of Times New Roman font. But here we have ourselves some model curves. So everything is kind of jumbled together into one input, which clearly it's the case because everything is in one layer, right? So we need to kind of separate them out. And the way we separate them out, now I pray, I think I know, if I dash, or just panel, sorry. If I create a panel, and here for the name, do I just type in text? I think I just type in text. Connect that to the name. I'm sad, I'm freaking sad. Text, curve. Okay. Now you can see me struggle. What if we matching method, regular wildcards equals a piece of text equals the characters combined in this parameter. Ew. So we used to be able to, with this geometry pipeline. The reason why I'm struggling with this is there's another node that is not native to Grasshopper that you can't really use by yourself. Well, you can download an add-on, but I don't want you to. That's called geometry pipeline, and the geometry pipeline enables you to reference a specific type of geometry, not just the layer, which worked great. In this case, it only references the layer, or maybe an optional group name filter. What if this is curve? Nope. Okay, that's fine. The way we are going to do this, is by fixing it in Rhino. So points here are only going to be the circles, and text is going to be a new layer. Call it text, and then cell text in Rhino, and just change it to that layer. That's easy. Sorry, 1 minute wasted with this, but now we have text and points separated. Which means we can do, from now on, points are only going to be here, and then I can just select this, copy paste, double click, change this to text, and now this is going to be only text. So only text, only points. Easy as that. Okay, a little bit yucky, but it is what it is. For now, let's work with the text. I basically want to get these numbers in, right, to actually read these numbers. So out of the objects, I'm going to extract text entity. Panel, by the way, is a very useful tool. If I just / or type in panel, I can read what any output is. And in this case, I already showed you this, but these are like model text entities. And I can connect them to text entity input here. And then the outputs that I'm getting are the entity itself. So it kind of just keeps repeating the same thing. The plane, basically, where is it located? The text, the number that I want, and the style, right? The style is like, is it Times New Roman or is it something else? Okay. I guess we can kind of start working with those numbers, right? Start working with the altitudes. So the first step is to get these circles and move them up, or rather get the center points of the circles. We don't care about the circles, we only care about the center points. So to get the center points of the circles, you can just, for example, measure their area. Area gives a centroid. Boop. Centroid is a point right here. Easy. Then to make sure that everything is nice and neat and tidy, I really like using clean tree, and connect that to the centroid input. So centroid goes into tree and it just cleans up the data. Don't worry about it. I'll use the same thing for here. Clean tree for the text. Boop. Removes nulls, removes invalid objects. So if I'm expecting a text, but it gives me a mesh, it's going to be removed. And if there's any empty stuff, that's going to be removed as well. Okay, that's done. Then I want to also, if there are any points here, anywhere, that are right on top of each other, if there are any circles that were right on top of each other, I want to remove them. So I'm going to use remove duplicate PTS, remove duplicate points. Bam. Tolerance 0.01, that's fine. That's like 1 centimeter. So if any 2 points are closer to each other than 1 centimeter, one of them is going to be removed. Okay, and I think at this point we can, okay, let's just build a mesh and then I'm going to show you how to actually then optimize and make it foolproof. So let's, from the text, let's measure the distance. Sorry. Should we? Yeah, we should. Let's measure the distance between these points and the origin points of the text and make sure that, you know, which point is connected to which text object. So I'm going to use distance tool right there. And I'm just going to connect the points to the A input. These guys connect to the A input. And the planes, because plane is a point that has like an orientation, right? So planes connect to the B input. And what I get from that is a bunch of distances. But there is one more thing that I need to do that basically is going to be trust me bro and don't worry about it. There is a graph. I need to separate all of these points into their own little branch, data branch, before the measurement is made. So I'm going to connect the unique points to the graphed tree and that goes into A. You can see the dashed line. Don't worry about it. It's fine. Not a problematic thing at all. Right. And with that done, I get for every point, I can actually show you the measurements that are being made visually. Don't follow along with this. This is just for me to show. Line between the graphed tree and the plane. Pop. Every point measures every distance to every text object. So every single point measures the distance to every single text object. Because of that, there's a lot of distances that are being measured, right? But the reason why we're doing it is because then I can sort the distances, sort, list. I can sort the distances, and together with them, I can sort the text objects, you know, the clean tree, the values here, and I can extract the ones that are shortest. So for every point, I can get the shortest one. Hopefully that makes sense. All right. So basically, okay, I explained this one more time. Very simple, very short. Let's see this guy. This is going to be a good example. This point measures distance to here. It measures its distance to this text, to this text, to this text, to that. Like to every text, it measures the distance. And then with the sort, I say, yo, only give me, or rather sort the whole list of distances that you've got from the shortest to the longest, right? And if I actually look at the distances that I'm getting, you'll see that the numbers in meters is like the closest one is 0.3, so it's 30 centimeters away, then it's 6 meters away, 7 meters away, and so on, right? And then what I want to do is, together with how it sorts these distances, sort the texts as well. So now I know that the shortest one to that particular point is 146.33, and I want to get that. To get it, I just use list item, connect that to the list item list input, and that's it. That's done. Now we get, I can show you, 14633 for the first point, 14675 for the second point. So basically every point gets their own little value. Okay, we're getting there. We're getting there. So we get ourselves our points. Visually, keep showing people what we're doing visually. All of the points are here, right? And the distances of how far they need to be moved up are here. We will be using a move tool. Move. We'll use the graph input as geometry, like that. And the distance is going to be moved along the z-axis upwards, right? So we'll be use z, unit z, upwards, double click z, enter. The distances go into the factor and then extracted distances. And then those go into motion. And then you pray, zoom out, there we go. To check, to do like a foolproof check, you can always turn on the contour layer and make sure that it's kind of in the same position. And it seems like it is. They're a little bit higher up, lower down here, and so on, but they're generally in the same position. And this is just more information, more resolution. Can you use them together with the contour lines? Yes, you can, but you shouldn't. Because sometimes the mismatch between the measurements really messes things up, and then you're basically layering the error of the altitude point measurements together with the error of the contour line measurements, and you end up getting like a really weird, some weird issues. So while you can, you shouldn't. But either way, we get ourselves the points here, and then now we want them to be in one list, so we use flatten. Oh, that's the wrong one. Flatten tree. Bam. Now they're in one list. And from here on out, it's exactly the same procedure, right? We're basically here, right? Where we flatten the tree. So we can just Control-C, Control-V, copy paste, yoink. And just connect flatten tree to the Delaunay mesh. Look at the sub-D that we get from the mesh, and that's the geometry that we are getting, right? Easy. Well, how do I say? Easy to replicate, probably hard to completely understand, but hey, that's what I'm here for. And as long as you do step by step, you will have the same tool. Okay, in this case, I really want to get those corner points in here, in this, I'm gonna scream. I want to get these corner points that I showed you in the first version into the landscape. And the way of how we are going to do it is we're going to imagine. We're going to imagine our own points on these corners. So I just take this. I mean, it's kind of fun if I just take this node, and I just make sure the center point is turned on, and I just make a copy of it. Look, so in perspective, I'm going to be moving it to this corner right here. Look at how the top, in the top, the actual landscape behaves. Pop, enter. Immediately reaches the corner, right? And then I'm going to just keep making copies of that. The way I kind of want to do it is, give me a second. I want to find the closest picket points, or I keep saying picket points, the closest altitude points to any corner, and I just want to make a duplicate of them because I don't have information on the exact altitude of these corners. So I'm just going to kind of be duplicating the existing information, like so. And I don't know if this is a good way of doing this, but since we are not really going to be designing here, but I still want to fill the whole landscape, I think that's, or not the whole boundary, I think it's the correct way to do this. At least the most accurate. Okay. That this is going up, this is going down. I'm gonna choose the one that's actually, since this is going up and this one is going up and this one is going down, I assume that this is gonna be going up as well. Oop, like that. Is it this corner? Oh, this is quite far from anything. If this is 146.3, 146.6, oh, this is only 30 centimeter difference. I'm gonna use the 0.3 for this. The snapping is very annoying. I'm gonna turn off everything except the center snapping and the end snapping so that they can connect to the endpoints. Like that. This corner doesn't matter because it's going to bridge the gap here. So I'm gonna say, yeah, the lower one. It's pretty flat, so it's not gonna be that big of an issue. And now if I look at the landscape, why is this red? Why is this orange? Why is this freaking out? Why is this freaking out? This shouldn't be freaking out. Grasshopper input points, that's failing. Okay. Disable, enable. So if it's going to be crashy, or if it doesn't like the real-time thing, you can just disable a node, and disable is like select the node, click the scroll wheel and choose the at 3 o'clock, there's the disable button. And then the enable button, it forces recalculation and now it's fine again. And we have ourselves the landscape. It's a little bit bigger. The landscape is a little bit bigger. So I'm going to use, instead of 2500, I'm going to use 3000. You know, just give it a little bit more crisp. We can do 5000 actually. Yeah, 5000. That's good. So that's that. You think we're done, but we're not. And we're not done for one simple reason. The reason being, this landscape that we have here is not really sufficient in terms of the resolution that is needed, at least from my point of view, because we have the laser scan, right? We have the laser scanned environment right around the building, and I want to add in that resolution to the landscape as well. Chapter 2, part 3. We're going to be adding in more stuff to this. First things first, we want to take this landscape and move it down. The way you move it down is by using the move tool. The motion vector is going to be Z, but it is going to be negative. And by how much? Well, 146, let's say. I don't know, I'm guessing. And do this 146.000. When you do it like that, it gives you more resolution on the slider. Okay. So now the landscape has been moved there, right? And what we are going to be doing is turning on the point scan. Not the photogrammetry, don't care about the photogrammetry. We're going to turn on the point scan, and we're going to keep moving this down until it aligns perfectly with the point cloud, with the point scan. So, a little bit slow. 165. Nope, 163. Yeah, that's kind of close. And then we do clipping plane. You know, the typical altitude alignment. And this doesn't seem that bad, honestly. Yep. Actually. Damn, okay. Nailed it. Nailed it the first to drink. Got too excited. Got too excited. Right, nailed it. Kinda. Now we can start seeing some problems. Problem number 1 is this bush right here. Too much stuff. Grasshopper input. I turned that layer off. There's a bush here, right? Let's move it. Move the landscape here. That clearly has been measured by the municipality as landscape. This kind of crap is why we do proper scanning. So all of these picket points here, it's just garbage, right? Just shit. So we're going to remove them. Of course, we need to remove these two, I guess. Let's take a look. It's this one, right? Oh yeah, and even the contour lines here are also respecting this bush as a measurement. So we know now from the laser scan that this is incorrect. So I'm just going to be delete. Hello, why is it still there? Delete. Okay, log the scan. Hide the contour lines. Select the thing, delete. Delete. How many? Cell dupe. No duplicates found. I don't know what happened. It might be because this was referencing and Rhino was not happy with us deleting stuff that has been referenced, so maybe that's why. But either way, after deleting that object, you can see that now the landscape actually doesn't sag up. It actually now sags down too much, right? So there's another problem. Anyway, we could keep going around this and then fixing this kind of stuff, but instead what I want to do is give it more information, more resolution around the actual landscape. And the way I do it is by giving it more points. So we create a new input. It's not going to be, well, it is going to be grasshopper input. So I'm going to create a new layer here and call it points laser scan. And clearly we can't use that many points. That would be crazy. No, we will just be using manually placed points by ourselves. That goes into grasshopper input. Bam, like that. So that's points laser scan. I give them also like reddish tint because all of our points and text are reddish. So I'm going to give it like gold. Let's go for gold for these guys. Make it my active layer and create some points here. That doesn't, oh yeah, and make sure that point snap is turned on. Point snap, that's turned on. And then one, and maybe here. Basically, I want to go around. Oh, immediately messed it up. You can see here, immediately messed it up. I basically want to go around the perimeter of the building and give it accurate points on the landscape. I think I did a little bit too much here, so let's hide a lot of things so that it's only the grasshopper surface as well as the point cloud. If you don't have a laser scan of the building, clearly you can't do this step, so you can just skip ahead to the next chapter. But if you do, and you should, at this day and age, it's so easy. Either iPhone or photogrammetry scan that has correct size. I have a photogrammetry scan course soon on the channel as well. But basically with the clipping plane, I love to use clipping plane to reduce the complexity of the scene and to actually see what the hell is going on by using custom depth and doing like every 1 meter or 2 meters. Let's do 2 meters in this case. Bam. And just adding some points here. Bam. That's correct. That's good. Definitely need a point there, a point there, point there, and a point there. Okay. Then take the clipping plane, -2, point, actually a hill, that while here it shows up as a, you know, going down like that. Then of course we ignore the building. We don't put points inside of the building. And that -2, and so on, right? This is kind of boring, so I'm going to skip ahead. All right, we're back. These are the points. Let's hide the scan. These are the points that I have created. You can see that some of them are below the landscape, so they will change the landscape's positioning that way. Others are way above. Why is this so high up? Oh, I just did a thing that the the geodesic measurement people did. I put a point on a bush. Delete. Okay. Besides that, everything seems to be kinda okay, nothing out of the ordinary. So we need to get these points into our Grasshopper script for our landscape, right? So I'm just thinking, give me a second, thinking. So now we know the altitude at which these points should be moved, this landscape should be moved, but the problem is that we need to add in these points into, before the mesh is even created, right? And the issue is that the mesh is created high up, and then it's moved down as a sub-D geometry, right? And then we have the points. So the points need to be added in here, you know, during this period, which means that the existing points that are used to create the mesh that are high up need to be moved down here. Thankfully, we already know that it's in my case, it's 163 meters, right, of altitude. So I'm just going to take these guys and just take this move tool and just move it over to the flattened tree and put here. Do we clean this up somehow? Let's clean this up this way. There we go. It's more compact. So so these points goes into the geometry input here and are moved down, and then will be paired with all of these points here, right? That's the idea, and that's the concept. And then that feeds into the Delaunay mesh, right? So before, right now we're not really doing anything spectacular. We just, instead of moving the sub-D, we just moved the points and then constructed the sub-D, you know, lower below. We haven't added in the new points yet. To add new points, we yoink query model objects together with the layer thing here. I'll just position it there, and we reference the correct layer, and the layer name is points underscore laser scan. No enter, just click outside. So now we have all of the points from here referenced in, and then I will just one second, thinking, please hold. Thinking, please hold. Oh, it's not here. I'm stupid. It's here, isn't it? There we go. So the moved points needs to be added in together with the new points that I have created. So I'm going to use merge tool, data 1, data 2, connect to the points input. Annoying. Merge tool sometimes does that. It creates a data tree. Right click, flatten, or node flatten tree. If that happens, not a problem. And now voila. And by voila, I mean the new data, all of these new points are now influencing the landscape, right? So I can take this guy, for instance, and just whoop. Oh, it's auto-saving. You know. So I can adjust the landscape with these guys. Don't do that. Don't do that. You want a correct landscape. You want the points to be in the correct position. Don't start modeling like so. But now we have a tool, a very flexible tool, that can do that can take your altitude points. It can read the text that is closest to the altitude points, create a landscape to there, then manually, like this area here, I will actually, for you, color this red or something, or purple, right? Find correct height of the landscape in brackets manually, right? So this is the manual stuff that you need to do, where you position the landscape. And besides that, everything else is kind of straightforward. Yeah. So everything else is automated, right? So group this, right click, call this, basically every time we create a group, we describe what it does. So take altitude points, grab closest text to them, move points according to text up, make mesh, or no, add in manually placed points, make mesh, make subd. Okay. Explains what this does. Also, copy paste. This is going to be called landscape altitude points plus manually placed points to 3D. With that being said, if this was for some reason not used, disconnected. What? wait, please hold. That's crazy. Okay, that needs to be connected. Sorry about that. That was a weird thing to do. Let's see if this does not reference anything. This still works, yeah. So if this query model objects does not reference anything, if you haven't added in any manual points, this will still work with just the points from the municipality. Great. Back to relay. Okay. Second script, done. At this point, you probably are a little bit concerned that there's going to be a lot of Grasshopper coding. There's not. This was the heaviest part of Grasshopper in the whole course. A lot of it is going to be just Rhino. But the landscape creation does require Grasshopper. Unfortunate. Well, who cares? It's just a tool, right? Save that. Oh yeah, don't forget to right click and bake. And before you bake, you do in the landscape 3D new layer, boop, call it from points. Make it beautiful dark green. Right click, bake into that layer from points. Okay, we have ourselves the landscape. Hide that and Control S to save the Grasshopper file, close it. Now this bad boy right here needs to... Let's actually hide Grasshopper input layer. We don't care about it anymore. This guy, you can already see much more resolution, much more information going on here. Needs to be NURBS, polysurface. So NURBS, two NURBS. Delete input objects. Yes, I don't care about the subd. I only care about the NURBS. And now this is a surface. Well, is it a single surface? 1 second, please hold. Display settings, show edges, so seams, isocurves. This is indeed a single surface. I'm quite surprised. Usually it does not produce a single surface. Usually it is still kind of sliced up into a few larger surfaces, but this is a single surface. With that done, where is it? Photogrammetry, there we go. We can look at how the photogrammetry lines up with this. Seems to be lining up quite well. There are some islands here that are sticking out a bit, and this seems to be a little bit too high. But other than that, everything else seems to be a-okay. This is a little bit too high as well, but that seems to be fine. You can make some adjustments later, but for what we're going to be doing with this, you don't really need to make adjustments, because the next step is going to be actually modeling out the landscape, and I'll show you a few techniques and tips and tricks of how to do it properly. For now, we do have ourselves a very clean landscape model that is highly accurate compared to, I mean, we have added in so much more information compared to what we get from the municipality, and that can be used for CNC milling, laser cutting, you know, anything, because it is a surface. With blabbing out of the way, we move on to chapter 3, landscape editing or manipulation or design, landscape design, I guess. So we will be working around the building before we move into the building. I'll see you there. I'll see you in chapter 3. All right, chapter 3, the landscape design. In this chapter, I'm going to show you my strategies and my methodology of how I create landscape, surrounding landscape, or recreate surrounding landscape around any building, how I connect it to the existing topography and so on. At proposal phase, not design development phase, but proposal phase. The reason being is the design development phase is pretty straightforward, because you mostly work in 2 dimensions, like in 2D drawings, while in 3D, while you work in 3D at the proposal phase. So that's where I'm going to put more effort in showcasing and teaching you. 2D is very much straightforward. There are a few things that I have already modeled out. Don't worry. They are not that important. I guess the staircase is, but I guess I should change this to shaded view so that you see better. The green is the existing bridge that I got from, 1 second, please hold. Topo import, there we go. This one right here, from the 2D drawing from the municipality, I got this bridge. Then I actually measured the width here and compared it to the width that I have measured on site, and the widths don't match up. Thus, my bridge in the 3D model is clearly wider than the bridge shown here. It is what it is. Besides that, the bridge itself does not influence that much the design of the building, so as long as something's there, that's fine. What does influence, well, maybe not the building, but the landscape design around the building, are these staircases here. And there is a story. So the municipality drawing, if I look at it in the top view, does show us the staircase outline right here. Will Arctic View show it better? Yeah, Arctic View shows it better. So there is a staircase outline here, but you can see that they don't match up. They don't match up with the staircase that I have modeled. And the reason for them not matching up is because while this is a good way of indicating that there is going to be a staircase, I never trust these drawings, so these documents, so I follow the point cloud of the 3D scan. And then if I take these stairs, hide them, you can see clearly that the staircase has been modeled on top of the point cloud, right? So that it follows as close as possible. There are a few not errors, but like the point cloud is not that accurate, but this is definitely much better than trying to follow the municipality's outline, right? In creating the landscape design drawings later on. Anyway, so those are the 2 main things that were added. Oh, third one is the perimeter of the building. 1 second, please hold. Perspective, Arctic View. Let's hide the points, and actually, let's hide the topo import. The foundation around the building has been modeled out, just boxes, nothing more, just regular boxes placed in their own little layer that's under, I created an existing layer, and sublayer is foundation here, right? So if I select the objects, you can see it's just the perimeter of the building that was modeled out, because I need to know the edge at which the landscape touches the building, right? Or where the building kind of touches the landscape, and then I can manipulate that edge. I can kind of redesign that edge. So that's one thing. Second thing is here, if we take a look at it here, there's a lot of accumulated, well, it's not dirt, but it's like material, landscape material that's accumulated, and also in the point cloud, you can also see it. It's just there, which goes over the foundation layer, which means that here to get like a proper seam, I needed to model out 2 logs. And a bonus of it is if I hide this and I change this to rendered view, zoom in. Bonus of this is that now I know the exact kind of step size, the measurement for these logs that were used, right? Because all of these logs are the same, and all I needed to do was just kind of copy it, I guess, or yeah, reuse the same number. You'll see slight misaligning here. I will talk more about the misalignments and so on, and how much error can you let the building have as you're remodeling during the next step of the actual building remodeling. Right now, it's still landscaping. Okay, so those are the things that I have. Besides them, the bridge, I continued the pathway here. Let's change to shaded view so that you can see better. Just slabs, just regular slabs that kind of follow the landscape. If I show selected, you can see that the slabs are kind of above, slightly, you know, following the landscape, and then they're flattening out because this part is already being designed by me. Because this slab right here is a parking spot for 2 cars, right? So I need to somehow get the people in here. So it's a parking area for 2 cars. And that is actually the strategy, right? The strategy is that you first create slabs for activities and you place them in the landscape. And then once they are placed, you connect those slabs and those activities with other entities, using the landscape not as a medium which you manipulate and which you mess around with, but just as a guide for the altitude of those platforms or terraces or whatever, right, of the surfaces. So that's the strategy, is actually taking the landscape and locking it, and then modeling stuff on top of the landscape just to, you know, make this whole thing work. So, for example, step 1, I will turn off the photogrammetry layer. Don't need to see it now. Just work here. Under the existing layer, I will not be creating anything new, but under proposal layer, which I also have created. So there's now existing structure and proposed additions to the structure, except the staircase. The staircase should be in the existing, but it is what it is. That's fine, because the landscape lives in the proposal layer. And then under geometry, I have my concrete slab, which is colored in this purple color. So everything that is gonna be added in here will be a concrete slab. So for example, I can just do a quick block out in the shaded view, just a box, and I can just model out some sort of a quick little, well, let's do a pathway. Actually, let's do a pathway here that also connects to the terrace that will lead us into the building. So you come in, you park your car, and then you want the terrace to keep going along the perimeter of the building so that you can go into the building, or you can take the stairs down. That's the stuff that I'm going to be designing, right? So first step is actually to remember what's the thickness of the slab that I'm using for this. Distance 0.125, 12.5 centimeters or 125 millimeters. It's a little bit thin, ain't gonna lie, but for now let's keep it at 12.5 centimeters. Should be okay. I'm going to create a rectangle or a box in the correct concrete slab layer and just give it whatever 1 meter by 1 meter by 0.125 millimeters thickness. Move it and connect it to the slab right here. Something as simple as this, right? Now I just want this to be properly scaled, so I'm just going to give it scale 1D along this direction. How long should the pathway be until you kind of step over into the terrace? let's say 2 meters. So 2, enter. So now you arrive and you have a little pathway, and then you can step onto the terrace that has the same altitude as the door. Question: how high will the door be, the door entrance? Well, considering that you can't mess around with these slabs here, then you will definitely need at least 1 log thickness for the floor slab plus the heat insulation and so on. So the door will most likely rest on top of this first log, not the second log, but the first log. Actually, I want to think about it a bit more. Yeah, it should be the first log, right? So I'm going to just make a copy of the slab right here. And for now, unlock and hide the landscape because it's a little bit in the way, a little bit annoying. And I'm going to move M, enter, V, enter, so vertically. From this point right here, I'm going to move it to be completely aligned with the top of this first log, right? Because I assume that that's going to be my floor altitude, and considering that the floor also will have a finish and there's going to be a step and so on, there should be enough so that the water doesn't go in, right? So that's that. Then using Ctrl-Shift and clicking on one of the sides of the geometry, I'm just going to move it until it snaps to the edge. If it doesn't, then I need to make sure that near snapping is turned on, and it still doesn't snap. Then I cry, why don't you snap? Hello? Gumball, right click. Yeah, instead of smooth dragging, we need to have snappy dragging for this to work. We constantly change between smooth dragging and snappy dragging so that our gumball can snap to things or not snap to things. So with that done, now our slab is actually snapping, and I can see the first problem. The first problem is called the logs are crooked. The logs are crooked because it's an old building. The slab can't be straight. It needs to be kind of chiseled to be along, or molded to be running along the logs properly. So for now, we can disrespect the log altogether, and we will just use Boolean difference to trim out this, the slab. With that being said, the other side, the opposite side, here we do want to reach with the slab these 2 slabs here. So I'm just going to select this and drag it over until it snaps to this edge. Then on the opposite side, right here, I'm going to extend this terrace until it reaches the edge of our parking lot, right? Because the reason why the parking lot is placed here is because there is a like this is the edge between the neighbor and our client, right? So we can't extend this further. There's going to be most likely a fence that is going to be created here. Then the question is, how much do we extend on this side, right? And the way of how we can kind of have an idea is by going to our scans, turning on photogrammetry, and looking at where the entrance is, right? So this is the entrance area. So we kind of want to extend at least a meter over the entrance area so that you can place some stuff or a flower pot or whatever, you know, in this area before you enter. So I'm not going to be accurate about it at all because I'm sure that there's going to be misalignments and so on. So for now, I'm just kind of snapping it to the edge here. Actually, I should snap it to the edge of the log right here, and then just giving it -1 meter, so 1 more meter in this offset. Clearly the outside bathroom, this is toilet, the outside toilet, as well as this extension to the building will be demolished. They are unnecessary. The building itself is big enough. Oh yeah, and this actually showcase this quite well, especially if I were to change this to rendered view. You can even see from the planks you know, where the neighbors are and where our clients are, right? So that's the limit along which fence will be made. Okay, with that done, I can hide photogrammetry. We have ourselves our first little step, and we have ourselves a terrace, and the terrace is going into the landscape, and actually it's going into the landscape in a little bit of an awkward way. Oh, sorry, not the landscape, sorry. Into the house. It's going in a little bit of an awkward way, because I, being an idiot that I am, I managed to trim. Is it trim? Chamfer, sorry. I managed to chamfer the logs so that they look nicer. Yeah. There's a way of how to mitigate this, and we do that by Control-Shift clicking on the side of the log with which we will want to trim, holding Alt key and just moving it up like that. As long as you hold the Alt key, it just copies that surface that you have Control-Shift selected. Then I will just scale it vertically like that, so that it becomes almost like a wall, and then we'll give it thickness. After I've done that, let's go to shade it. I can now select this object, and then I can use Boolean difference. Before I do, I know for a fact that there's no way that there's gonna be concrete that directly touches the wood during the construction process. So I'm going to preemptively give it 0.01 meters or 10 centimeters. Actually, let's give it 2 centimeters. Sorry, not. I wanted to give it 1 centimeter, but I decided to give it 2 centimeters of a gap, so that you could insert an in between, probably a rubber gasket, right, to stop the rot and whatnot. Do they add rubber? I don't know. Boolean difference, but I think it's a good thing to have, like that kind of a gap. And clearly, I mean, now our terrace just sits like there would be dirt added in here. That doesn't work, so I'll just use scale 1D and just scale it until it reaches, until it reaches the top edge of the foundation, so that it sits well on the foundation. Notice how I'm completely ignoring the landscape so far, and that is because all I care about is connecting this with our entrance, right? So now as you arrive, you're able to enter. Further steps include me creating more slabs. Do we do one more? We can do one more, I guess. So for example here, right? I can just take the surface, and I can, holding the Alt key, I can extrude it. But before I extrude it, notice how my gumball is misaligned. I want it to be aligned with the surface so that the next slab that I extrude is actually following the direction of the staircase. So I'm going to right click on gumball again, align to object. Then Alt key, holding Alt key, click on the little circle here, whoop, and you just successfully extruded a brand new slab. For this slab, I wonder, so you arrive, you use the staircase, you go up. The question is how far do you want to keep walking in this direction? I would say probably 2.5 meters, something like that, 2.2, 2.4 meters. Yeah, let's try doing 2.2. Scale 1D. Let's do 2.4. 2.4 meters. And then give it scale 1D again. Let's give it 0.125 meter thickness. And this is still a concrete slab. Change object layer. There we go. For now, I don't care about the height of it, because I will need to terrace these down so that the difference in height here is eaten up. Then let's do, how many steps do we do? Let's do 2 steps. So here, this is going to be pretty straightforward. Copy. Pop. Like that. Scale 1D. From here to here to here. And just move it down. MV. Something like this. There should be an overlap between these two. Which actually makes it a little bit tricky. So for now, I'm actually going to have this in line with the same height, and then we will manage the thicknesses later down the line. Okay, and now we need one more step right here to eat up that altitude, right? So that step is actually something that we could design in 2D, like so. But should I show you? I mean, it's still the same platform. I'll show you how I plan it out. So I just take this rectangle, I rotate it. It doesn't really matter. I just need it to be like a slab, like that. I have it rotated like that. Move, enter, V, enter, and I just have it snapped to the top here. And now I can clearly see what is the, actually copy vertical. By copying this, I can clearly see how much of a distance do I need to go through, right? In these like 1, 2, 3 steps, in 3 steps. So if I measure the distance between top here and top here, it's 0.44 millimeters, or 0.44 meters, 440 millimeters. If I use calculator, 440 divided by 3, 146. So let's say we just do 100 and we can do 150 mil steps. That sounds reasonable. So this step right here, actually how big of steps do we have here? Distance, yeah, that's also 0.15 meters. That works. So this one goes up 0.15 like that. This one goes down minus 0.15. And does this one also need to go down? Minus 0.15. Oh, and then they are aligned. My bad. Apologies. I calculated wrong. 440 divided by 4 is 110. So it actually 110. Oops. 0.110. There we go. And then these two go down minus 0.110. And then this one goes down minus 0.110. Okay. Consistent step size from here to here. A little bit awkward in this place because this is 15 centimeters and this is 10 centimeters or 11 centimeters. This might be what we consider a neck breaker. You know, when you do one inconsistent step at the end, we might need to address this and fix this up, but that's for future. I really don't want to spend too much time fixing problems right now. We're still designing. Okay, so with this kind of terracing done, I can clearly see that this now actually needs more thickness, so more concrete here. This can have less thickness, but let's keep it the way it is. And basically, we just have ourselves a little bit of a strategy going on. Let's take a look at the landscape. Clearly, we will need to be digging out quite a bit of landscape here for all of this to work out. That's not a problem. I'm sure we will manage. Okay, so now the way we should do it is that I stop explaining the block out version. I will block everything out and then I'll show you the blocked out landscaping around and explain the next steps afterwards. So pausing the video now. Whew. Okay, there we go. So explanation, I guess, of what I've done. This is still quite the same. I have evened out the step size here to 15, and then instead of basically ate up that difference by making an awkward step here. I do think that this is not a problem considering how small this is. But worst case scenario, we can always simply raise this up like so. So that there is a little bit of a tilt here. I have added in a small detail, nothing fancy, just a small detail here, because there is going to be like a full reconstruction of a roof, of course, and the roof, I don't really want to have any gutters on the roof. I want the water to flow from the roof straight down onto the ground, and the way it should flow is onto this ground gutter, right? That is just indented into the ground. For now, it's diagrammatic. It's nothing special. Then there is a small pathway. So if you're arriving, not by car, if you're just kind of arriving here, there's a small pathway in here with a little bit of an area for, I don't know, grass, gravel, whatever. I guess it's gonna be. Actually, I'm being stupid. Yeah, it's gravel because every material is color coded. So the purple color is gravel, as you can see here. It's important to do so because later down the line we will be adding in hatches and so on and styles of representation for different types of objects. So everything that is gravel needs to be in the gravel layer. Besides that, a few metal, how do you call it? Railings. This is not a railing, this is a railing, right? But the same idea is like it keeps the dirt away, while this keeps the human away from falling to their deaths. And then as we go down, actually let me turn on the landscape for this. Pop. As we go down, there's a river here, don't forget, right? And that river floods. So this area right here is going to be flood proof. It's raised and it's going to be like a terrace, all year terrace, while this area here can flood with a little bit of a border, so that if there's just a little bit of flooding, it's fine, but most of it can flood. And just a pathway here. Again, very simple. I'm just doing platforms and I'm connecting them with platforms, right? I think that's the best way to do it. Honestly, like you don't do soft forming of the you can do soft forming of the landscape, but it's much nicer to do it diagrammatically, like so, and work with the layers and whatnot. And then once the time for construction happens, then you make sure that the expertise of the builder, and the builder is, or landscaping guy, is able to either do a soft curve or a sharp curve. I say that and I don't believe it, honestly. Everything should be controlled in the drawing. In this case, I do want everything to be straight lines. Anyway, now on to actually working with the dirt, right? So the landscape itself, making sure that that dirt is fixed, it's cleaned up. The way we do this is quite straightforward. We need to start trimming. And the way we trim is, again, very straightforward. First of all, we create a rectangle around our whole foundation, building foundation. We go to the top view and we type in trim. And we just click on the rectangle. Click inside of the rectangle. So it trims out the landscape here. That's step one. Step two is to get rid of all of the stuff that's intersecting with our geometries, and that can be a little bit problematic. In this case, it's not going to be, because again, everything has a pretty simple outline, right? So for instance, here I can just draw. Why is center snap turned on? Okay, I can just draw a straight line from here to here to here. Intersection snap. Hello. There we go. And then connect it to here, like that. And I have my one edge that is going to be used for trimming. And in doing so, I'm just kind of slowly creating a whole perimeter with which I'm going to trim out the landscape inside. So loop edge is also quite useful to just grab the edges of the geometry that you need. By the way, it doesn't need to be in the same height. We will fix that. So I'm just kind of going around along the perimeter here. Don't care about the bridge. We'll just take that edge there, there. Okay. This is gonna be tricky. This will need to be cleaned up, but that's fine. So we go along there. Also some cleaning up, just some 2D work that we'll need to do. Not a problem. Okay, like that. Bam, bam, bam. kind of boring, isn't it? To watch. I might speed this up. Okay, I have selected the whole perimeter. So basically the island is gonna look like so of trimming, meaning that we're gonna lose this, we're gonna lose that, and that's okay with me. Once we have all of this selected, we just hit enter and we have successfully duplicated a bunch of edges, right? And then there's a few that we have drawn here. I'm just gonna borrow them real quick. Oh, it's only one. Move vertical as well to a higher altitude so that we can operate with them a little bit easier. First step, select all of them, scale them down along the z-axis to 0 so that they're flattened. Second step is actually select the curves and isolate them. Zoom selected, or let's go to the top view, that's going to be nicer, and just clean up the perimeter so that's actually a freaking perimeter. So trimming, getting rid of that, that's clean, that's not clean, we'll need to look at what the hell that is, that's also not clean, that's good. Okay, so there are a few issues. Fillet with radius of 0, we'll fix that. Is that okay? Yeah, that seems to be okay. That's good. That's not good. Fillet 0. Okay, this one. The hell is going on here? Show selected. Oh, it's just the railing. So the railing goes up until here. What about here? Yep, that's the same situation. So cell CRV, cell curves, cell CRV to select curves. Isolate again, and now we know that this needs to be pop connected like that, and this needs to be pop connected like that with some trimming involved. Oh yeah, and I guess I just trim. Okay, with this done, I join everything up, joined into 2 open curves, so that means I made a mistake somewhere. Right here, I forgot. Okay, trim, join. Now 1 open curve, it's open. Clearly, close curve, makes a segment, one segment. Show selected, get the landscape in here, select the curve, trim out the landscape, delete the curve, don't need it anymore. That's ugly. That part is ugly. We could just extend the curve and get rid of that, should we? Kind of want to. I don't know, I'll decide later. For now, it doesn't really matter, that part. Show selected, pop, show all of them. And now you can see, that all of this fits and sits quite well in the landscape. And I have kind of moved around clearly, moved around the borders, the edges, so that they are indeed above the landscape, so that they're sitting nicely. Let me just see if there are any problems along the perimeter. Doesn't seem like there are. Oh, one thing. Here, if you are using the old version of the landscape, you'll notice that it's much higher. And that's because I was lacking resolution in this area. If your landscape here is still kind of messed up, what you can do is you can build your own by just simply going to the top view, dragging out 2 curves like so, these 2 guys, trim, trimming an opening here, and then saying, well, actually my landscape is going to be anchored, let's say to this point, or I want a middle point. To the middle point here, it's gonna reach until here. Should it? Not really. 1 second, please hold. Because that edge there is a little bit yucky. No, we can just do it this way. So it reaches until the intersection point here, like that. And then I will draw an edge here from this point to the intersection point here. And the tool that we're going to use is going to be called sweep to rails. Select first rail, that's the long curve that we've drawn. Select second rail, that's the landscape edge that we have drawn. And then we select our first cross section, and then we select our last cross section. Hit enter. And it basically creates a blend, a landscape blend between the two, which will kind of work. It won't be perfect. There are ways of how to make it perfect with the ISO curves, extracting ISO curves, but I don't think it's necessary for this level of detail. Hit OK. And you got yourself a pretty good patch that you can join back in. And now this is clean, right? So basically that. Guess what we're gonna be doing for, all of these openings between the platforms and the landscape. It's basically dirt, right, that we are removing, and like these islands, we can shape them any way we want, right? So which one do we? Yeah, I guess we can do this one, because this one is going to be so easy, so straightforward. I can just take this edge, or maybe this edge. Yeah, I can just take this edge and just extrude it until it hits the foundation, right? And I will make sure that this is set to be gravel. Change object layer. That's gravel. That's gravel now. Then I take this edge, and I'm being kind of lazy because you should actually draw it like that, and then extract here. That's also gravel. Join these two up. See if you can merge. No, you can't merge them for some reason. Oh yeah, because this is going down a little bit. That's fine. If you want these two to be, if you want to be able to merge these two into one shape, for some reason, you can always scale to 0 to flatten them out. Dupe border, or not edge, dupe border to get their perimeter. Now the perimeter is flat, and just use planar surface. And now it's a single surface that should be repositioned. Don't forget about that. Boop. Like so. So all of that seems to be neat and tidy. Now we will have a little bit of work to do to jump around here, or we can ignore this, portion of the foundation and just work with this line here, line segment here, from here to here. There we go. And honestly, like midpoint, I guess, midpoint segment here, from here to here. Loft. And I know that this is like the altitude change here is too drastic to try and keep this flat, so this is gonna stay angled. Change object layer, and that's our gravel. Same thing here, but in this case here, I kind of want to, how do I call this? 1 second, thinking. In this case, I want to keep a little bit of the original landscape because I'm sure we won't be completely digging out this area. So I'm going to do one quick little thing. Let's just see if this will work. That's a no, is it? Unless I explode. Boop. Yep, that will work. Okay, so what I've just done was, let's undo explode. First of all, this whole landscape is made out of separate patches. It's a poly surface, but if I explode it, you can see that there's 1, 2, 3, 4, 5 patches. And the benefits of using a surface is that it remembers that it was trimmed, right? So this patch, for instance, like it remembers how it used to be before it was trimmed, and you can see that if I press F10, you can see that the control points are still there. It's just, a boundary representation that has been changed, or boundary definition that has been changed. So I'm going to just dupe border, get that curve out, because I'll need the curve, and I will actually lock the curve so that it's not in the way, and I'll use untrim just for this particular area, right? Then I'll show selected, and I'll get myself. That's gonna be fine. Then I use this, I guess, that retaining wall, and this as a, how do you call it? A thing that I trim with. I will create, I'm basically trying to extract this part of the landscape, right? I'm going to create a bunch of lines here, like that, that needs to go up until here, and then actually this is going to be awkward because it needs to go and hit this part. So I'm going to use perpendicular snap. Oh, and it's not perpendicular, god damn it. Okay, fine. So we go until here. A little bit yucky, but that will do. Like that, hit that, and we end kind of here. Okay. So I know this is getting convoluted, but trust me. Cell curve. I'm basically getting this whole perimeter in a kind of dirty way, but with enough information, right? So I select all of the curves. I will move them up. And I didn't select the boundary curve here because that is locked. Move them up. And we do the same thing. We scale them down to 0 and we clean them up, right? So now this is going to be a little bit annoying. Hide. Okay. ZS. Top view. ZS. Okay, so that is clean. That's good. That is not clean. Fillet. Boop, boop. That's good now. That is good. That needs to be connected. And that needs to be connected with a fillet. There we go. Boop. Select the curves, join the curves, unlock the landscape that I just locked, and we will use split instead of trim. So I'll use split, select object to split, I select the landscape, enter, select custom objects, I select curve, enter. And now I have that little patch that I care about. I don't care about any other patches in this landscape, so I'll unlock, not undo, redo. I'll unlock the outer curve here, like so. I'll use it to trim back the landscape as I've done before. Don't need a curve anymore. Cell SRF, join. Show. Oh yeah, and this can be either joined or not joined to the landscape. It doesn't matter. Can be a separate entity. Let's join it. Why not? So now I have successfully reclaimed the original landscape here. And honestly, like looking at it, it's not much that I need to change. Maybe even out this area a little bit. But other than that, nothing much. If I, by the way, select this part and I hit F10, you can see that I still get, let's isolate and show you. F10, come on. There we go. I still get the control points of literally everything. That's annoying. That's annoying to me to deal with. So what we're going to do is, first of all, we will use shrink trimmed surface. I don't know what shrink trimmed surface to edge means. So for now, I'm just going to shrink trimmed surface, hit F10. And now we can see that only the control points that we have here are used. I'm just going to experiment. Shrink trim surface to edge, F10. Oh, it kind of tries to follow along the... Yucky. It tried to follow along the edge. I don't know. I don't know what that was, but... Oh, actually, it didn't. Apologies. I don't know. I don't know how that tool works. Doesn't matter. And for this landscape, there's still, if I press F10, there's still too many control points for me to control it, properly in a soft way. So I'm just going to rebuild it with, it's 23 by 17. I'm just going to give it 10 by 8. Maximum deviation, I will calculate it. And it tells me that by reducing the resolution this way, I'm basically getting an error of 1.1 centimeters in altitude, right? Which to me is absolutely okay. Could even do less, but let's not. So now with 10 by 7, this amount of control points is reasonable for me to shape this patch. I show F10, I grab some control points here. These guys. Back to shaded. And then, for example, here I just kind of Oh, yeah. One thing, gumball, smooth dragging, turn it on. Like that. So that this is a little bit more evened out. And then here, that is dipping down too much, wireframe, grab that control point. Oh yeah, and you can clearly see that now the control points are following the normals. I don't want that, so align to world or align to C-plane. That's annoying to me. That's very much annoying to me, because I need to choose then which one do I respect in terms of the altitude. Is it the slab or is it the foundation block? I guess I'll do the foundation block like that. So I'm letting it dip down, and for the slab it will just need to be a little gap here. That clearly will not be the case. There's going to be dirt here, but should be fine. Alternatively, we can always give it a little bit more of a concrete foot here. Scale 1D, 0.125, 0.2, and that's going to be part of the concrete slab, right? So that it anchors down there. Basically, foundation for our foundation. Probably it would be just a perimeter thing rather than that, but it's fine. Okay, so that's how you manipulate soft body in terms of landscape, with least amount of error. That's how you control the landscape, how you design for it, and generally, I think that's kind of it. As long as you're not trying to just take the original landscape and move the points around and somehow change it, and you're working methodically by just simply adding in, or not adding in, sorry, removing or separating every part into smaller groups and working with them and reconnecting them. That's the way of how you should approach it, or how you should go about it. There's one more thing that I just want to showcase before we continue. And I'll showcase it by just making a copy of this, exploding this, and saying that, okay, what if, what if you just want to join in your landscape, what if you want to do quick and dirty way, right? So let me just quickly trim these guys. I actually don't even need that perimeter to show this. Let's say you have your building. Let's make it a little bit more difficult. If you just want the landscape to meet the building exactly where you want it to meet the building. Boolean union. Scale 1D, 0.25. That's your floor slab, right? Problem. Oh, actually, big problem. Hill too big. That's your landscape. Still, problem, because if I move it in, okay. If I move it in, some parts of the slab are way too low, other parts of the slab are a little bit too high. Actually, could be higher. I'm just struggling with this example, aren't I? I'm just trying to find a challenging position for the landscape. But the problem is that this part is so flat, which is okay. I guess I can do it this way. Okay, some parts below the landscape, other parts above the landscape, not good, problematic, right? The way you do it is you grab the outline of your floor slab, right? You do border. You get the curve, you offset it, and I like to give it like a pretty sufficient offset. Well, it depends on how big your site is. In this case, I'm going to give it like 5 meters or so of an offset, right? And I'm going to move that offset above. And in places where it really will need to eat up a lot of height, I will actually select this and gumball, align to object, and I'll move it even further out because I know that there's going to be a large gradient here, right? Besides that, 5 meters usually, at least in countries as flat as Lithuania, works pretty well. Then I take this and I round it off. So I use fillet corners, set the radius, and I set the radius to, I guess we can do like 3 meter fillets. Let's do more for this. You go by the feel with this one. Actually, that part is going to be problematic, so I will need to fix that part before. This hiccup here is no bueno, so I need to select that control point and delete it. This hiccup here will probably work fine. Okay, again, we try this fillet corners. We use 4. Yeah, 4 seems to be okay. And then with it, I'm just going to trim top view. I trim out the landscape, right? So I make some breathing room for me, right? Then I will dupe border again, lock the floor slab, and I'll just move the border down to whatever. This is basically the altitude to which you want to lock down your landscape to. And this is the current condition, and this is the gap which is going to be used to get those gradients in. Dupe border, get that curve in, and get this curve in. So you might think, oh, I just loft, don't I? But it's a little bit yucky, isn't it? So instead of lofting, let's isolate this, unlock that slab, hide it. So all we need to do is somehow create like a proper clean loft between these. And the way of how I like to do it is by using sweep 2. That's, as you probably can tell, is my favorite go-to tool for this. So I'm just going to basically create a line segment wherever, from here to here. A single, oops, my bad, from here to here. A single line segment that is, oh my god, from here to here. Is it straight? Yeah, it looks straight. That's fine. Usually you have it perpendicular, snapped. And then I will use not loft, but sweep 2. First rail, second rail, edge in between, enter. And already it gives me a little bit cleaner sweep, but there are still issues. You know, it still twists awkwardly. So this is where we can use add / functionality, where I can specify that, well, from this point to this point, I want the edges to flow like that. From this point to, I guess, this point, I want them to flow like that. But then from this point to this point, I want them to flow like that. And this is no bueno. This can't work simply because when you are doing, you can't have two sweeps, or not sweeps, two of these cuts starting from the same point, right? So I need to undo that. So instead, what I do is add a point there, and actually let me undo twice so that I can add 1 point here and add 1 point here, like that. And that kind of cleans it up. It's still a little bit ugly here, but that's much, much better. So here, exactly the same situation. I just add a point here, add point here, fixes it, point, fixes it. This is going to be a little bit tricky. So this should probably go somewhere here. Actually, that already sorts everything out there. This straight to here, this straight to here, and then corner gets filleted out, and last corner here. Without explaining it, it's actually not, it doesn't take that long, right? And you end up getting, okay, you end up getting this kind of a landscape looking thing. I can then show selected, join it in to the existing landscape, and then show selected again. Look at the floor slab, Arctic view. There's a shading issue right here. That's fine. If you don't want that shading issue to happen, you can always delete that part, and you can sweep to first rail, second rail, first edge, second edge. Give it a little bit of that. Join that one in, and that seems to be fixing it. If, by the way, you see in the Arctic view, especially if you see this, that means that Rhino is struggling to display the geometry for you. You can always select this shape, go to its properties, and under render mesh settings, custom mesh, adjust, go to, you don't do simple controls, you do detailed controls, and you say maximum edge length should be, let's say, 1 meter. Preview, right? It just forces the geometry to have at least 1 meter resolution, right? And in places where it needs to have higher, it's gonna have higher. Once you hit OK, the shading is fixed, right? Then if you don't, for example, if I do EMAP now with arches, you will notice, is there rendered view? No. Yeah, sure. Actually, rendered view, and let's not look at the edge lines. So I'll go to display mode, surface. What the hell, surface edge? Oh, these are curves. Okay. Cell CRV, delete. Okay. You'll see that there is no continuity here between these two. Like this is all discontinuous. That's because we just basically used a fancy loft. If you want it to be a little bit smoother, to go around a little bit smoother, you can always fillet edge, enter, give it next radius of, let's say, 2 meters, double click on the edge so that the whole perimeter is selected, hit enter, and then pray. Usually it breaks, sometimes it works. It's very hard to understand when it breaks and when it works. It seems like in this case it's breaking, so whatever. We don't care. I could show you one last bit of how to really make it smooth. I guess I will. If you want this new landscape to be fully smooth, then let me make a copy of this. You do quad remesh basically. So you select this whole shape, right? The landscape, the new landscape, and you use quad remesh. You say that it should be converted to sub-D. The sub-D should have creases turned on. The preview should be turned on. Delete input objects, because I made a copy, should be turned on. Height input objects turned on. And you'll see that now, sub-D corners, my bad. Sub-D creases as well as sub-D corners needs to be turned on. Now this whole thing is moving out, but you're losing resolution doing so. Target quad count 2000 is too small for this. I will use something closer to 8000. Bam. Still seems to be working fine. Starts breaking down here a little bit. Let me just check if it's breaking here. No, it's not breaking here. So this area got a little bit messed up, but I'm sure we will be able to fix it. So I just hit OK. I get my sub-D, I hit F10, get that control point, drag it over here, get that control point. Oh, it's fine, the way it is. Ask questions about why the hell is this relaxing in this kind of awkward way. So start moving some control points around. This is the reason why I didn't want to really show you this, because why are you doing this? Anyway, that's fine. To NURBS. This might actually take a long time. NURB surfaces will be packed into 59 larger surfaces. Let me escape out of that. Keep it as sub-D for now, because NURBS will just take a long time. But if I do EMAP on this version of it now, you'll see that while you can kind of still see a area where it changes direction abruptly, it's much smoother, it's much more organic, right? So if you want, for some reason, if you want it to be smooth for rendering or whatever, then that's how you connect the landscape. If you want it to just be connected in a technical way, with clear offsets, and where's the original, where's the intervention and so on, then you do it this way. But if you want to do it properly, actually designed, then you do it this way. And that is landscaping. That's landscaping in a nutshell. One last bit is talking about the layer system, because layers are very important for now. Sorry. For now, my layer system is, wait, why is 3D turned on? Oh, it doesn't matter. My layer system is as such. I have the default layer in which I do a bunch of dirty work. Besides doing dirty work in the default layer, I don't use it for anything else. I have my scans layer where all of my 3 different instances or objects live. And by the way, the objects are currently being instanced rather than placed. I'll explain that part in the next chapter. So my Rhino file is 29 megabytes rather than 1,000. Then we have our landscape layer. Landscape layer and proposal landscape layer are 2 different things. I should probably rename this, but I can't because my Grasshopper inputs are already locked to the Grasshopper script. So it is what it is. The landscape layer has 3D version of it, which is basically what we've done, during the chapter 2 from points as well as from contours, these 2 versions. So I keep keeping them. All of the Grasshopper inputs are here, and topo input from the topography study is here as well. Not study, municipality. Then we have existing layer. That's it should go up, I guess, which only has currently the foundation as well as the facade. I'm breaking the rule for the existing layer by not incorporating neither the bridge nor the stairs, and that is simply because proposal layer has a landscape sublayer in it, and I don't want to keep copying, having like 3 different landscape layers everywhere, and then I need to figure out what is what, right? So all of the stuff here in 3D lives in this landscape layer, where basically I have my proposed ground, dirt, right? Then I have my bridge, I have my concrete slabs. This is the bulk of it, of the design. I have my gravel. This is replacement, mostly replacement of where I trim out the ground, but I kind of still want to keep the ground the way it is, but a little bit nicer. Then I just call it gravel, except for the road, I guess. I have my border only for the road, because that's going to be cheap. And I have my stairs, right? Again, talked about the stairs already. Those are existing. And I have my railings, which are going to be expensive and most likely made in metal, right? So those are in their own layer. When you're creating these layers, think about how you will want to hatch them later on when you generate drawings from them. And everything that shares the same hatch, you can place them in the same layer if you want to. And that concludes our chapter 4 on landscaping. We move on to chapter 5 on actually building out this this building from the point cloud data, as well as beginning of detailing, thinking about how you can make some additional structures in the car park and whatnot. So that is going to be, we're in chapter 3, that's going to be chapter 4. I'll see you there. All right, chapter 4. In this chapter, is it chapter 4? I guess it is. In this chapter, I'm going to show you how I reconstruct the existing structure of the building from data such as point clouds, mesh scans, or photogrammetry scans, right? And before we begin, just one thing to note is I have added in these patches around the landscape. It's nothing fancy, it's just getting the edge of the landscape and just extruding it outwards. This is going to come in handy later once we actually start rendering. It's not going to be part of this course. I am working on additional courses that deal with rendering. Keep an eye out for that. But, just adding in additional landscape patches is always handy. Besides that, it's exactly what we had once we finished chapter 3, right, of our course. So for this chapter, I'm going to only work with the building, right? And I already have a little bit of foundation, and I will not be showing you everything, because this will take definitely like 10 hours or so to model the whole thing, from the point cloud data, but I'm going to show you the principles. And if you are not doing restoration renovation project, but you're just modeling from scratch, this chapter should be easily replaced by you just modeling out, block out a basic shape of your building, planning it out, and just doing a quick and dirty model. In my case, I can't do quick and dirty. I'm going to do a precise model, but I will not care so much about the layers, the layer system, right? So let me show you a few tricks, a few things of how I operate with point clouds. First one being is if I have only the exterior and just the photogrammetry scan, I always check the rendered version of it, because there's a lot of information that's baked into textures that I can actually measure and model out according to the texture rather than the geometry itself. In this case, the size of the logs, right? Another thing is just going around and looking at any information baked into the texture of any retaining walls that would be locked inside of the building. So in this case, right here, there might be a retaining wall, and I can double check that by just creating a clipping plane. Let me just draw it right here. Give it a second. It's a large mesh, so cutting into it takes a while. There we go. And you will see that this is empty, right? The inside of the photogrammetry model is empty, and of course it is. The only inside scan that I have is a point cloud data that we meshed during our chapter 1. And yet again, I have moved the clipping plane, so now we have to wait. If I turn on the point cloud data, then I can clearly see some more, information about the interior. And also, if I zoom in here, I can see that these logs that are intersecting are actually aligned with this wall that goes from one edge to the other edge of the building, right? So from here to here. So then I know for a fact that this is also a heavy-duty log retaining wall that is interlocked, and that fixes our structural perimeter around. So there are most likely no more retaining walls inside of the building. Perhaps this one, we don't know. But definitely the perimeter itself is holding up the whole roof, right? Because we can't observe any columns or any proper columns inside. So that's one thing. Then to actually model out the logs, there are different ways of how you can do it. The way of how I like to do it is just to draw a curve along the point cloud, and for that I will need to have my clipping plane here, go to its properties and choose custom depth for clipping. Give it some time. Photogrammetry is really not that lightweight. And then for the depth, I will give it not 1 meter, but like 0.2 meters. Ideally, you would do these kind of cross sections through the whole building at different heights, but in this case, I'm just going to be kind of lazy about it. Then the question is, do we follow the photogrammetry model or do we follow the point cloud model? Because the exterior, I'm sure, will be quite misaligned. And for the exterior, like to try and follow the exterior walls to rebuild them, I strongly suggest following the photogrammetry model, because that's already you know, the mesh is already there and it's a little bit more clean. So I'm going to go to the properties tab and turn off the, oops, not the scans, just the points sub tab or sub layer. Then taking the clipping plane, it's getting annoying. I wonder if we change the preview to shade it. Maybe that's going to be faster. Then I will just move the clipping plane. Oh yeah, it seems to be much faster now. I'll move the clipping plane so that it's kind of close to where we have our foundation. And that's going to be the first time when we actually draw manually a curve through here. And the way I like to do this is, like for these kind of buildings, is if I just grab a polyline, just from here to here, just single line segment, and I look, then I can see the curvature, right? I can see the curvature and how much the whole wall is curving away from the polyline. And maybe in the top view it's going to be even more evident. Where's our clipping plane? Don't forget to turn on clipping in the top view. Tick mark that. So now this is going to be much more evident. If I hide the foundation and I look at the line here, you can see that it's bulging out here and it's bulging in here and so on. So we don't want to have too much of a resolution, but we want to have some. So I'm going to rebuild this curve and I'm just going to give it point count. I'm just going to give it 5 points, something like that. Maybe let's do 6 points, right? Hit OK, hit F10. And then you don't snap, so you shouldn't be snapping to the mesh, but you should be getting those control points, like on the curve, and you should be moving them until they reach the mesh. So you want to kind of, architect view, you want to have them follow along, like that. Oh, that's my bad, sorry. Anything that kind of grabs, you just lock in place so that it's not in the way. Move that. There we go. That's a point. Move that. Like errors that are sub 1 centimeter are not a problem at all. Move that. One thing that I will need to check, definitely I'll need to double check, is if the, yeah, that seems okay. One thing that I need to double check is that the curve that I have, it's a NURBS curve rather than a polyline, right? Because I drew it as a polyline at the first, so I'm going to rebuild it again. And yeah, degree is set to 1, so it is a polyline. I will just ramp up the degree to 3 so that it's more smooth. Still seems to be holding the curvature pretty well. I'm just gonna really quickly go through the control points, see if I need to adjust them. Seems like I do in some cases. Yep. So that was my bad, not doing it earlier. And I'm also going to extend the curve a little bit further out. We will trim it to size later, here as well. This gets locked, that's annoying. And we extend, okay. So we have a cross section of the bottom of the wall. Then I just simply select the curve. I select the clipping plane and, I select the clipping plane and I need to move it up. And before I do so, I'll turn off the custom depth so I can see everything below. This like 20 centimeter depth, because I will need to be able to grab the curve, and then I will just simply move the clipping plane until the top of the something close to here. There we go. I was looking at this edge here and I was waiting until it becomes clean. Something like that. Then I take the curve and I move, enter V, enter, and I just simply move it to be at the same height, right, at the top. And here clearly both ends of the curves are not long enough, so the trimming is going to be off, but that's fine. We will fix this a little bit later. So we have that, and then I just need to correct it, right? So back to the top view we go. just get that as close as possible. I'm just basically just working with the, actually we need to make sure that we're working with the top one, so I'm going to, oh, did I mess up? Oh, I messed up. I accidentally moved the curve rather than copying it. Apologies for that, so just give me a sec. There we go. Actually, while we're here, I might as well just move this point out a little bit more and then just have a copy of it. Alt key, copy upwards, M, enter, V, enter, move to the correct altitude. Okay, back to adjustments we go. So this one we are working with, this one, the bottom one should be locked. We'll work a lot with locking things. And then here I simply F10, get the control points of the curve, and just make sure that the curve kind of follows along the mesh. It's not going to be a clean mesh simply because we're so close to the roof, but I can clearly see some instances where the curvature should be adjusted. And since I'm adjusting mostly towards the right, I can also tell that this is slightly separating, but honestly, I mean, this is really vertical from what you would expect from a 200-year-old house. Like, it's very well aligned. And that part most likely just, yeah, that part just goes here. So this is a little bit crooked. Okay. So that's two curves, the top one and the bottom one. And now I'm just going to take this top curve, copy it to wherever, the middle portion, to get the curvature. M, enter, V, enter the clipping plane. Get it to the same level as the curve that we have copied. Give it some time. There we go. And then in top view, you guessed it, adjustments. So that's all good. That seems okay. This is bowing out, so this point needs to be moved in a bit. Let's see. This point moved in a bit. That's all good. Let's grab this one. Actually, this one is aligned, so that's fine. This one is not. Move in. Yeah, that's the curve. That's good. And that's basically it. Okay, good. Now, clipping plane is unnecessary, so I'm just going to select it, wherever it is, delete it. I'm going to grab those three curves, unlock. Yeah, all of these three are locked, and now the landscape is, the photogrammetry model is also locked. So let me just hide the scan for a bit. Show the foundation. And all I need to do then is just simply loft between these three. Before I do so, I'll make sure that the bottom curve sits on top of the foundation. So M, enter, V, enter. Like that. And the top curve is slightly above where the roof line is, right? Because we managed to map out this cross section, but we are not reaching the top. So I just need to make sure that it's gonna be above the roof, like so. As close as possible, by the way, to the roof. Okay. With that done, we loft. 1, 2, 3. With the loft done, we can see, I mean, very soft curvature, but the curvature is there, right? So if you need to build out heat insulation or whatever, right, next to the logs, the gap here is going to be pretty small, while here it's going to kind of be increasing, right? So that's important. That's important information to have when you're designing, and we're going to talk about that information later in our chapter 5, I guess. So for now, I have this kind of divisions, and then to actually get the correct cadence, is it, or rhythm of the logs, to divide them up correctly and to get the proper thickness. Is it thickness? 1 second. Height, proper height of the log. All you need to do is just simply measure the photogrammetry scan, right? All of the log thicknesses here were the same, right? were the same. So you just measure a few of them out and you just do, where is it rendered to? And you just do an average, right? You just do an average, then you look at the rhythm that you have here, and according to that rhythm, you just divide up this surface. I already have the logs measured here. So if I just create a bounding box for this, measure the distance from this point to this point, I know that is 0.225 meters. So 22.5 centimeters. So what I'm going to do with this one is divide it up every 225 centimeters, right? So I'm just going to use contour on the base, from the base of it. I don't trust the anchoring here, so I'm going to go to the front view and just do a contour definitely upwards, right? And then I'm going to say 225, enter. Oh, sorry, my bad. Control Z, contour again. We're not in millimeters, we're in meters, so 0.225. Does the contours for us, so then I just can select this shape, split with the curves, cell CRV. You can run commands while a cutting command is running, selection commands. So I just cell CRV selects all of the curves in the scene, hit enter, and now we have ourselves separated out entities, right? And the top one is ugly. Cell CRV again, delete. Select all of these bad boys here. There we go. And extrude them inwards by minus 225, 0.225, my bad. Because those logs are definitely square, right, in their profile. And then what I've done in here that I would not suggest you do early on is I applied chamfer. A chamfer on all edges of the log so that I get this shadow seam. While here you can't see the seam, you can only see it in the shaded view. So if you want that seam, if you want that chamfer, you can just select those logs in here. Make sure, by the way, that they are in the correct layer. So let's go to existing, logs facade, change object layer. There we go. Isolate them, and then just select everything. Not the bevel, chamfer. Chamfer edges, chamfer edge. And I believe I used like 1 centimeter or 2 centimeters. So let's try 0.02 for all of them. You just select all of the edges and apply 0.02 chamfer. Seems to be okay. And we don't do fillets, instead we do chamfers, simply because fillets become too heavy for the computer to handle. See, this seems to be okay, right? We have ourselves a log wall, right? And I'm chamfering way too early because we still need to do the whole perimeter and so on, and only then do we chamfer. But that's the principle. And also, actually, let me undo the chamfer. And also the very important part is scans. In this case, the length of the logs ends here, but also it ends with this facade here, right? So to actually trim them, we need to create a surface here, right, for this front facade, and use that surface to trim off the log ends here, and same thing for the back. You can notice how tedious this is going to get, how slow this is going to get. I am not going to show you that whole process. It's just a modeling exercise, very simple modeling exercise, but as a how do you call it? I just wanted to note it, and then I'm going to do it in a time lapse later down the line. Okay, so that's one thing. I am deleting these. I'm just going to do a time lapse of the whole thing once I explain the logic. So that's one thing, the facade and the logs, right? Then a more interesting thing, in my opinion, is rebuilding the inner structure, which is a little bit more difficult because you need to work with point clouds or the laser scans of sorry, not the laser scans, but the meshed version of the point clouds. You can work with either one, that doesn't matter, but I prefer to start working with point clouds and then go on to work with laser scans. Okay, if I do clipping plane, and clipping plane is your friend, of course. And I just take it and let me just make it bigger so that I easily can select it from any angle. Oop, my bad. moved it accidentally or rotated it accidentally. And let's say I want to build up these beams here, right? These beams that are in the basement floor here, these seem to be quite crooked, quite aggressive, and quite hard to build. I can do so by following their cross sections. Most of this work is going to be following the cross sections. So if I just get the contours in here, or not contours, clipping plane in here, move it in until I can see the first cross sections of the beams. Let me turn on the meshed version. Yeah, much cleaner to see here. There we go. So this is the first time that here it just kind of messes up and you really can't tell what the hell is going on, simply because this is actually, wait, give me a second, just looking. Yeah, this is too messy, right? So this is where the information begins for these beams. And then I can just create a rectangle or some form, some shape that would fit with these beams. And to do so, I will be using a custom C-plane, because I want, as I draw the rectangle, I want it to be drawn, you know, I'm trying to show it with a hand, on this surface of the clipping plane. So I can just do C-plane, enter. And then it asks me for C-plane origin. And in this case, I'm going to say, give me C-plane by object. By object, and my object is the clipping plane. I think I clicked on the mesh and now it's going to scream at me. Not sure if that worked. I did set the clipping, the C-plane. Oh, one way to find out. Rectangle. Nope. C-plane is still crappy. So the object-based C-plane didn't work. That's weird. 1 second. I'll try one more time. If it doesn't work, I'll show you an alternative. Not clipping plane, C-plane. Construction plane, it's called. C-plane. Object. Okay. And now? That's very strange that it does that. Yeah. Okay, so what it does take the C-plane, but it just moves to the center of the clipping plane. I assume that it's going to inherit the orientation of the clipping plane as well. Don't you worry, that's fine. What we can do is we can just create a rectangle, 3-point rectangle, start it from here, draw it up and to the side, hello. Let's do it here, to the side, like so. That's now our rectangle. That is directly, modeled on the clipping plane, and then definitely C-plane. There's no reason for the C-plane to freak out. So object, poop, there we go. Now it's aligned properly with the C-plane, right? So now the Z-axis is away from where the C-plane is clipping. That's just going to be quite useful. Right. So now to actually model out some of these beams, let's do one beam, right? Let's say this guy right here. I'm going to just create a rectangle, and before I do so, let me just make a new layer, call it blue, make it blue, so that I can see better what I'm modeling, right? Blue layer. So I'm making a rectangle, and I'm just going to make an approximate rectangle such as this, and I'll measure the distances of it. 0.2 meters here, 0.2 meters here. So that seems to be, I believe it. So it's scale 1D. This was very close to 0.2. I'm just going to make sure that it is 0.2 meters. So 20 by 20 centimeters. That is going to be the cross section of the beam, and that is what we're going to be using. So we're not respecting the, how do you say, the miniature curvature of the beam itself. We're just respecting the along its length, how much will it curve. Doesn't seem like it's going to curve a lot, but we'll see. And then in terms of resolution, it's a good idea to do this every like 2 meters or so. So I'm just going to move, actually I'm just going to copy this rectangle forward by 2 meters. Then I'm going to take the clipping plane, move it by 2 meters, right? Investigate. And clearly you can see that, the beam is moving. Like that. We reposition. We make another copy. 2 meters. Something like that. We move this by 2 meters. Oh, the beam is even more, like going to the right. And also going up a little bit. Interesting. So something like that, right? Then, I'm not sure if there's anything going on here. We'll see. We'll see if the beam continues. So first of all, I'm just going to, wait, it's this guy right here, right? So I'm just going to move the clipping plane. Yep, it does continue. I believe it was this beam, right? Let's just check. Yes. Like that. So I'm not respecting the 2 meter rule anymore. I'm just going to find a clean version of this and just draw a rectangle, 0.2, 0.2, and position it appropriately. There we go. Because I know that the size of the beam definitely shouldn't be changing. Only the cross section of the beam. Only the beam, the position of the cross section, right? Because they're all crooked now. And I end here, right? So it's this beam, it goes here. And this is like the final, well, whatchamacallit. This is still where it's rectangular and it just kind of gets rounded off there. So I'm just going to use this. If you work with points, that's what you need to deal with, right? You can kind of see it, but it's really hard to see it. You can get away by getting the clipping plane, getting a custom depth for the clipping plane, and just choosing 0.1 or something. I mean, with that, you can get a sense of the beam, but it's so much easier if you do the chapter 1 thing where you actually mesh it, right? I forgot which one it was. My bad. Move it back. 1 second. Did I accidentally rotate this one? Oh no. Control Z. Oh, that was drag. Okay. We turn off custom depth. Accidentally click twice. We again accidentally click twice. We move this cross section to find which beam we're actually rebuilding. You would be making all of these rectangles in a row, right, for every beam and just lofting them layer all together. So here, that seems like a good cross section. Draw a rectangle, 0.2 by 0.2. Position, align with the bottom. And this time I'm going to be cheeky and I'm going to align it with here as well, because I'm sure that that's where the beams are kind of going. So I'm just going to align it to most likely somewhere here. Okay, that's it. Clipping plane not needed. We'll make a new one later. Just get the laser scan out of here. Get these cross sections, loft through them. Make sure that the loft is aligned properly. So click on the arrow so that it wraps properly. Enter. Okay. Actually, one thing that I probably have missed. 1 second. I might have missed is the opposite side. Come on, opposite side. The cross section there, where the beam actually goes, right? So if I look at it, it probably rests on this. Wait, where is it? There we go. There's our beams. So it probably rests on this kind of weird concoction of a like these not slabs, logs that are added up into a slab. So I'll just make sure that this beam is long enough so that it goes over the cross section of these. And actually, to definitely check if your alignment is correct, you just move that one in there. Where was it? My bad. I'll find it. Yeah, there it is. So that's the beam. Cut, cut, cut until we find it. There we go. And if that log is here and it's 0.225, most likely the beam will be going up until here, something like that. Okay, so now we know for a fact that beams end here, beams end, where are they? Hello? Lock that. Oh, they're crooked, right? So you can see that the beam just kind of goes beyond the clipping plane on the side. There we go. They end here, right? So now we can actually build one. Loft. And of course here I'm kind of explaining, so it takes a long time, but honestly, just modeling this is not that bad. Delete the cross sections, cap. We have ourselves our first structural element. Just a few to go. It's most of working with it is exactly the same, right? You just kind of keep going through the laser scan data and you just slowly build it in cross sections. I will not be explaining all of it, because it's just the same thing over and over again. I will be showing a time lapse of it and then explaining a few things after the time lapse. Let me think. If there is anything else that I want to say before the time lapse, I'll delete the beam as well. Show foundation. Show. Oh yeah. If you want to keep the clipping plane, if you want to change between different sections and different clipping planes, you can create a new tab here. Oh, sorry, right click on the tab here, and you can choose on the side of the tab, sorry, and you can choose clipping planes, named C planes, this one, tick mark that. And then here you can add this, that's not clipping plane, that's construction plane. You can add that construction plane into this list by just saying from river vertical. Oh, actually I should rename this to renamed from river vertical, right? And then I can just double click on the world top to reset it back to normal, or front or right, or so this is a shortcut that's faster to jump between. Okay, now with this done, modeling. In terms of the block out, in terms of the modeling, if you don't do if you're not doing a reconstruction, renovation, if there's no exiting data, the starting data for the building, you should just simply model out the sketch, the proposal phase model, and it can be, again, in messed up layers, that's fine. We will be placing them in separate correct layers later down the line, right, in the next chapter. So this is where you do block out. The way of how I suggest you do a block out is with most, or not most, all of your geometries. There is one caveat. All of your geometries that you model with need to be closed shapes or single surface shapes. So I'll show you this with the landscape version, right? So under proposal, under landscape, let me just get rid of surrounding and waterline. Those two are annoying. This is a single surface object, right? Which means that if you cut through it, you get a single line. And you can control the thickness of the line. And that's usually how we deal with landscape, right? It's just one really thick line. Everything here, for example, these slabs, they are closed shapes, which means that when you cut through them, they produce closed curves, closed loops, which means they can be hatched. More importantly, they can be hatched automatically. This is what we're going to do in future chapters. So if you are modeling something, make sure that it's a closed shape if you want to later have it hatched in the final output in the 2D drawings. If you don't care about it being hatched or not, doesn't matter, right? So for example, even this railing is going to be a closed shape. Besides that, the way of how you model, absolutely up to you. If you don't know how to model a house, I suggest my beginner course. I'll leave a link to it in the video description below. And besides that, now I think it's time for for a time lapse. At the end of it, I'm going to tell you how long it took, and also I'm going to put a bar right here, like an orange bar, that will go so that as you're skipping ahead, you will see how long it's remaining, how long the time lapse will last for. It's gonna probably be like 5-10 minutes or so. I'm gonna play it 24 times the normal speed. Okay, so time lapse time. Alright, there we go. So it took me 10 hours to do the whole thing in total. So 1 workday, 1.5 workdays, depending on your workday. And generally speaking, the building is in a good shape, but everything is crooked and the front area is messed up. Now we can actually see how messed up it is. The roof is slightly slanting on the neighbor's side. We don't care about that. The client does want to reconstruct the whole roof, so it doesn't really matter if it's slanting or not. The whole roof will be removed. And generally speaking, I'll of course guide you through the building as it is, but strategy-wise, I didn't model anything that is unnecessary for me to model in terms of creating a design proposal, right? That's the premise. So any trash that was inside of the building, exit that, I'll show you points. Okay. There's a bunch of trash in here, right? So any kind of a trash there, like an old old window and so on. None of that was modeled. The only things that I really cared about are the existing structure, the current structure, as well as the existing room divisions, room separators, and the altitudes of the slabs, of where the slabs are, and the thickness of the roof, and so on, right? Thicknesses of the roof. Another thing is this electricity pole with high voltage lines that are running through this. At this point, I'm sure that this will need to be moved, somehow repositioned, because it's just going to be way too much in the way, right? So this electricity pole will have to go. Besides that, let me show you what we have. So everything that is definitely going to go, I didn't model properly. I just modeled it, just exterior shell of it. So in this case, the outer bathroom, it's not going to be there, right, in the final design. So it's just a box that approximates the size of the bathroom. The whole neighbor's side is just some height that. It's just some blocks, not even cut out here, nothing, because don't really care. The outer portion of this is accurate. This is exactly how the neighbor photogrammetry, it wraps around the, well, almost. It wraps around the photogrammetry geometry quite well, right? But the inside is not modeled. Then the window cutouts, where the cutouts are for the windows, have been modeled. That is very necessary because this is like a load-bearing structure, right? So that means that the windows are messing it up. And we need to know, for example, if this window, cuts into all of these logs right here, most likely we can just keep extending the window below, right, down, because most of the loads are just from the roof downwards, right? So it's taken care of by zoom in by this log. Basically, the transfer from these two beams, or how are they called? They're not called beams, rafters. From these two rafters goes to this log, this log, this log, and this log, and then gets kind of transferred over to the sides here, right? So which tells me that we can just keep extending the window. And the reason why I'm talking about extending the window is because clearly this is a very dark building, very large surface area, very small windows. Same situation here. One thing that's quite interesting is that this whole area here, if I look at photogrammetry model, are just boards, and those boards are not structural at all. So this can be just removed without sacrificing any structural rigidity whatsoever if I hide the photogrammetry model. And then it opens up, what I actually want to show you. So the roof surfaces are simple, nothing fancy about that. And then we have our structure. So the rafters are actually very straight, but very thin, because it's a barn style thing, right? The chimney, the clients won't want a chimney, so that's going to be removed, but still need to know where it is to be able to remove it. And let me actually do a clipping plane for this. Do we have any? No, I'm going to make a new one, clipping plane. So if we look at the beams from here, and actually from the top view, so make sure that it cuts in the top, like that. You can see that it's, it's fine, but they are really crooked. They're really messed up, right? But there's almost, the benefit of doing it this way is you also can see the sag of the beams, and there is very little sag. If I do that, and I just look at them here, they're not sagging much. Well, this one is sagging a little bit, but besides that, they're not sagging much. There's also round beams in the top, and the kind of supporting structure in the top, with some cross bracing that are quite interesting, and we will want to keep them. But besides that, it's all probably will be replaced by new cleaner beams. And the star of the show, right? Findings here. This is a single beam that is being held by a single column that does not even align with those kind of logs in the bottom, right? That are being held up by these metal poles, right? I don't know what's going on here, but clearly all of this, including probably the floor beams, will be removed during the proposal phase, as well as the interior structure here, with one caveat. And the caveat being, clipping plane, need to move the clipping plane. The caveat being right here, we have the inner retaining wall, right, with a bunch of logs. All of those will need to be kept in place. So in terms of modeling the building, it's mostly just wrapping everything, like the point cloud, with geometry and just following the logic, being true to how crooked things are. That's very important. If you don't do renovation and you're just simply doing a new building, then it doesn't really matter. You can just model a clean version of it. So we can kind of, I assume you know how to do it, and we can kind of skip ahead. One thing that I will note before we move on to the next chapter, which is going to be actually proposal phase, is going to be under the existing layer. I have made all of these sub-layers that I want to just guide you through and explain the logic behind them. Let me delete the clipping plane and show. So later, once I design, I will want to be able to jump between these layers, and they should help me, right? So the way of how you do this is everything that is structural, you should keep at 2 or at 1 layer. In this case, it's 2 layers. I'll explain why in just a second. But everything that's structural in 2 layers, foundation is a separate beast that lives in its own layer. Logs facade lives in its own layer, right? So in total, we have these 4 layers that are purely structural. Then we have our roof layer, which if I expand, I can see there's tiles, there's boards, and there's also structure. But already I know that the roof layer, oh yeah, and the boards, so these guys as well. I already know that the roof structure, this layer, is going to be removed so that I don't have it associated with the initial structure 2 structure layers, right? So that's why. So the roof is a complete reconstruction. We'll have complete reconstruction. Then the whole neighbor block I don't care about, so I just have it as a separate layer and I can hide it very easily. Then I have my little bathroom toilet, which we can turn off. Chimney, I know that that's gonna, so every layer is you planning out what's going to be removed and what's going to be kept, and just kind of separating things that way, right? If you're working on a brand new project, then every layer should be, or brand new design, then every layer should be associated with the design or element intent. Floor slabs, columns, and if you have wooden columns and concrete columns, they should be like in 2 different layers and so on. Windows, but I'll talk much more about that in the next chapter, so you can skip ahead if you're doing a new building. Then we have our floors. These are just slabs, right? We have our ceilings. These are just slabs. We have our walls for the interior. I think I made a mistake because these should also be walls for the interior. Change object layer. There we go. Walls for the interior. These are literally just a single extrusion, right? With some holes punched into it. And then the basement ground. Actually, this is something that I want to show, right? Let me turn off the landscape layer. My bad. Let me turn off the proposal layer in which the landscape layer is and show you. This is the ground floor. Isolate. This is currently the ground floor of the basement of the building, right? You can see a lot of dirt, a lot of accumulated earth and so on, and it's not evened out. So if we will want to work with this, we then will be able to kind of calculate how much earth will we need to remove, what's the volume that we will need to remove, by the way, through this door to have it all level, right? Through only this door to have it all level. Well, technically maybe with a crane, I don't know. So that's also an important thing to have. And that's kind of it, honestly. Like, this structure that you see right now is going to be the structure that will be carried over to the proposal phase. Everything else, well, I guess the roof structure, this, these guys are also going to be carried over simply because we need to incorporate them, right? But we will need to thicken them up and have the rhythm of them at every 60 centimeters. So it's going to be more of them. But the slope of the roof we want to keep the same, so that's going to be incorporated. Including this weird column situation here. I don't know what's going on with that, but we'll definitely need to take a look. All right, so that is kind of it with this chapter. In chapter 5, we move on to the proposal, design proposal, and I'll talk more about it there. I'll see you in the chapter 5. All right, chapter 5. In this chapter, I'm going to show you how I create a system in which basically my 3D model lives. And by system, I mean a selection of layers with their properties and whatnot, together with C-planes and blocks and whatever have you. Whatever helps me in future steps to extract the drawings from, to get the proper scheduling from, and so on. That is the system, right? So I guess we can immediately begin by looking at the workflow. The ideal workflow, in my opinion, is that you first create the layers, at least the base layers, the base C-planes, and then you model within the system rather than creating the model and then trying to fit the layers in. So at this point, you might already have a sketch model done, which is great. You will use that as a base, but basically once you have all of the layers kind of prepared, then it's much better to just model a clean version of the building inside of those layers, if that makes sense. Or, if you already have a clean version, then of course you just migrate. But I'm talking about layers, but before we kind of move on to layers, we actually need to talk about C-planes, construction planes. Those of you who are not familiar with what a C-plane is, it's basically your frame of reference for modeling, right? So by default, the C-plane is set to world XY, or world XYZ, which is flat, right? So everything that I create, let's say a box, will be always create flat to that C-plane and also will begin from that C-plane. What happens, and of course you can change them. I already have created one C-plane in the previous chapter. You can adjust them and so on. You can use them for your advantage. So step 1, make sure that you have your named C-planes tab available to you. If you don't see it, you can always right click on the sidebar. Is it called the sidebar? You just right click on it, and here, come on. There we go. And here you basically just navigate to named C-planes and tick mark that. Right? Once you have it tick marked, you will see your different C-planes available. Top, front, and right are the two most, or three default ones, right? So as you double click on them, they change. That's great. But then you can make your own. So for instance, if you want to make something on this roof, just a quick example, right? I would type in C-plane, enter, and then I would choose a type or a way of how I create a C-plane. And more often than not, I just use a 3-point C-plane, because at that point you're just kind of drawing a rectangle and it's very useful. So 3-point, C-plane origin, let's say hello, there we go, the corner right here, bam, then aligned with this edge, that's the alignment for the x-axis. The alignment for the y-axis is with this edge. I'm just trying to get a snap in there. Okay, fine. I'm just gonna snap to the top of the roof. And voila, I have myself a C-plane. If you don't see the C-plane, right, you can type in grid command, and here you can change the spacing of it. So minor line spacing, if I change this to 0.1, then since I'm working in meters, and by the way, you should probably work in millimeters, it doesn't really matter, but I'm choosing to work in meters for this example. The spacing now is adjusted to be at every 10 centimeters, right? Before it was at every meter. So I can adjust my C-plane accordingly, like so. Okay, enter. So this is quite useful. And let's say now when I have the C-plane, if I just want to create a box on the surface of the roof, I can, like so, right? Super useful, super neat. There are, if I remember correctly, auto C-plane, auto C-plane per object basis. If I have this tick marked or enabled auto C-plane and I select my objects, they don't seem to be changing. Oh, there we go. I need to select sub-objects. So Control-Shift, and if I select a surface, as long as the surface is flat, the C-plane is going to be changed to that surface, and then I can model on there. So this is a new tool in Rhino 8. You know, this kind of an auto C-plane tool. Of course, if the surface is this kind of a subsurface, the auto C-plane will be weird. Let me move this away from the building. Control-Shift, click. We can't even see the C-plane. Hello? World top. I'm just resetting the C-plane to world top. And then, yeah, if I click here, you can see that it kind of tries to fit, but it fails, right? Or it doesn't fail, it's just there's infinite amount of C-planes that can be fit. So auto C-plane, if you get used to it, I believe this is going to be a much faster way than just saving C-planes, but I'm old school, so I'm just gonna kind of save my C-planes and jump between them as I need to. So what do we use them for? Well, in modeling, already I'm kind of showing you. When you need to change your frame of reference, you just create a new C-plane. So for instance, this one, I'll just name it roof slope. Okay, and then every time when I need to do something with the roof, you know, make a box, push it inside, select these two, Boolean difference with the box, delete the box, I made a window, right? Every time I need to operate, I'm just changing to roof slope. Besides that, we go back to world top. That's usually the better way to do it. Not better way to do it, but usually you want to stay working in world top C-plane, because that's the default one, and you only go off script, so to say, if you need to model out something particular, right? So in this case, I'm just going to delete both of those. Don't really need them. That's in modeling, right? In this kind of a building preparation for making a design. Well, in this case, you already are looking at an existing building, and the design is going to be a remodeling of it. But even with this, the C-planes are used for two things. Floor slabs, so basically where the floors are going to be, you mark those out with the C-plane. And the second thing is you mark out where the sections are going to be, right? And you don't need to do it immediately, right? You can do it later. But for now, for example, here, this is the top of the foundation, right? Running through the whole building, right? This is flat, and it's truly flat. So I can just simply use this as my ground floor altitude, right? And then the top of the floor is going to be associated, you know, with it. So here I just simply type in C-plane. I'm just going to do it the old-fashioned way. C-plane, 3-point C-plane from here to here. Come on, to here. There we go. I'm sure, yep, and there's the grid. Why is it not showing up upside down? Also, is it... Bear with me for a second. I'm just gonna check. One. Yeah, Z is correct. That, I don't know. It's a weird visual glitch that it doesn't show the seaplane properly, but either way, now the seaplane is indeed in the correct altitude, which is here. So I can just save it as my ground floor GF reference. And that's it. We have ourselves a ground floor reference seaplane. Every time when I need to model out something at that altitude, I can use it. Then for something that is going to be on the second floor, for that I would need to actually hide that, and I would need to investigate what kind of structure do we have, and basically at what height. Most likely I would work downwards, right, from that seaplane. At what height will I have a floor slab that will cover these long beams, right? Because I don't want these beams to be sticking out from the floor, right? So they will need to be covered. So I can just do a bounding box on them. And the top surface right here is going to be basically the altitude of the seaplane, the minimum altitude of the floor to eat up the curvature of these beams, the irregularities. So I can just, first I need to make it into a seaplane. Yeah, auto seaplane was turned on, so it already made it. You can see here, right? There's the plane. So I can just select or save and then call this first floor or a second floor. Is this, if that's ground floor, this is first floor top reference. Okay, and that's it. So now I have my first floor top, where as long as I have the call it. 1 second. As long as I have that seaplane turned on, I can model out stuff on top of this properly, right? And it's going to not intersect. Which one was the highest altitude? Probably there. Not intersect with the curvy areas or curvy beams. And also then I can change to ground floor reference and then model out here, right? A box that slides in and that sits perfectly on the foundation, right? So that's that. And last seaplane is going to be for the basement floor, and for that I'm going to do something a little bit different, because here I can already see that this step right here is not going to be enough for the ceiling height, right? We will need to dig a little bit deeper. So the question is, by how much? The way I'm going to do it is simply I'm just going to create a box on this particular seaplane and just move it down by minus 2.5 meters, something like this. And you don't, I mean, seaplanes are infinite, so you don't need to have them inside of the building, right? So I'm just going to use the bottom, or was it the top? No, it was the bottom of the reference box to create a third seaplane. So seaplane, 3 point from here to here to here. There we go. And then just name it basement floor top ref or reference. There we go. So now I know exactly at what altitude I'll want my basement floor top to be, right? So we have successfully made 3 levels. Of course, then for sections you will have 2 more seaplanes here, but that's if you're having 2 sections, but that's later. Okay. So that's seaplanes, and that's kind of it, honestly. It's very straightforward. It's once you get used to using them, they are quite useful. If you're not used to using them, you should. I mean, it is annoying for the first few days, but eventually it just becomes quite nice. All right, and now on to, I guess, one of the more important parts of this course. It's the layer management, and specifically talking about section styles. That is also a new thing in Rhino 8 that we have. That does bring us closer, a little bit closer to BIM. Still far, but gonna be a little bit easier once we are extracting the drawings. So, section styles, let's talk about it. First of all, I'm just going to create a new layer and just show you, I guess. So I'm gonna make a new layer and call it test, right? And just teach you about it. So, and for the test layer, I'm just gonna make a box. We don't care. Oh, wait. The hell? Basement floor. There we go. That's why you, by the way, always reset to the world top. With that done, we have ourselves a box, and actually I'm going to give the box a proper width. So let's go for 20 centimeters, which is like a little bit of a thin wall. A thin wall if we're talking about structural walls, and thick wall if we're talking about separator walls. Somewhere in between will get the job done. Anyway, if I now do clipping plane and I cut through it, all we see, and I can change to Arctic view if I want to, right? All we see is just this bold outline, right? And I guess it's being filled. You can check if the clipping is, yeah, it is being filled, but you can turn on or off the fill by going to the display settings here and scrolling down until you see the show fills tick mark, and just disabling that. That's going to open it up if you want. But for this particular example, I'm going to keep it filled. Okay, so we had that for a long time, right? Typical. But now what we have is under layers, let's make this bigger, boom. We have our section styles, which we can just click on the none, and we can create our custom section style for this particular layer called test. And I'm not sure if this lives in the test layer, so I'm just going to change object layer and then section styles. And then, for example, I can just give it a pattern of hatch1. Oh, by the way, patterns import from the DWG files that you have imported. So this pattern is from the municipality's drawing, right? It's in Lithuanian, it's called a meadow or grass. Okay, so hatch1, right? Hit OK. And we have ourselves hatch. Okay, so now I can adjust it. I can give it a rotation, 45 degrees. And I can say that, well, the scale is a little bit, it should be a little bit denser, 0.5. Hit OK. We have ourselves a pretty decent 0.5 hatch. That always gets generated, right? More things that you can do is, oh, also I should show shaded. It's also displayed in shaded, but notice that in shaded, the fill is not visible, right? And even if I go to shaded, section styles, and under background, I change this to magenta, let's say, this is still not going to be visible, while in the Arctic, it is. Because Arctic has the show fills option, while shaded view doesn't. So I can just go to shaded, I can go to display options, tick mark show fills, and now magenta is shown. So basically you have front hatch and back hatch is also always a solid, right? So here I'm just going to choose white, and no matter then what kind of nonsense is happening, the background of this section is always going to be white. Which brings me to a very important note. All of your geometry needs to be closed geometry. If your geometry is open, let's say if I delete this part right here, never mind, it does it. Okay, that's cool. Oh yeah, it's gonna do it, but gotcha. So I can actually showcase this. 1 second, please hold. Open up like that. Boolean difference out like that. And have a hole there. So I have deleted this. Did I? Okay, that's being weird. I'm gonna delete this one. Okay, so I have deleted these two surfaces, right? So now this is not a closed shape. And if I make a section through it, you can see that it still hatches. That's because it just calculates the outer polygon, the boundary. And as long as the boundary is closed, it can hatch. But the moment when it hits this area, right, it can hatch this one because this is still closed, but it is unable to hatch this one, right? So you do want to have like a proper closed shapes for your hatches to work properly, right? So that, undo that, okay. And then, for example, I could do another 0.05, 5 centimeter block right here. Let's say this is some sort of a window frame or whatever that extends a little bit further out. It looks like that, just a metal plate. And let's say I do want this metal plate to be metal. Of course, for that, I need a separate layer, test2, and that would need to have, oops, its own style. But if I'm lazy, I can just right click on the section style, on the none. I can right click on this and choose match properties and select the original test layer. Or I can just click on the object if I remember correctly. Yes. No. Yes. I'm confused why this is not hatching properly. I'm just going to make sure that it is. Yeah, it wasn't part, goddammit. It wasn't part of the test2 layer. It wasn't moved to test2 layer. Let me do this again. So Control Z, Control Z. There we go. Now I'm going to make sure that this is, and I'm going to, test2 is gold layer, right? So yeah, now clearly we can see that this is not part of the test2 layer. So I'm going to change object layer. And then I'm going to right click on the section styles. And I'm going to choose match properties. And then instead of clicking on the, I mean, I could just click on the test layer, or I can click on an object. It's up to me. So in this case, test layer, hit OK. And now you can see it matches. One thing that changes, it doesn't only change the section style, it also changes the like all of the settings, right? So you kind of want to do section styles first because that's kind of common, I guess, or that there's the most amount of settings that you can change is in section styles, right? With that done, now I can go in here and I can actually adjust things. So my hatch should be a double hatch pattern. Oh, that's a triple one, sorry. A double hatch pattern, and the scale should be a little bit smaller. There we go. That's metal now, right? And then you will also see 3 more options here. Line type. So I can have a custom line type where I can do pattern 1 to 1. I think it's with a comma. Yeah. 1, 1 means dash that is 1 unit long and gap that is 1 unit long, and then so on. It continues. And I can call this dashed, of course. Or dashed 01. So that is fine. And you can clearly see there's much more that you can change, but let's not get too much into this. And this is in millimeters, right? It's not in meters. So it's every 1 millimeter. Hit OK. I believe if we zoom in, that's annoying. It's not actually showing up. Of course it's not. That's typical. Okay, it is red. And there was a gap there. Isolate that one. Okay, we make adjustments. So if that's 1, 1, what if we do 0.01, 0.01? Yeah, okay. So it's not in millimeters, it's actually in meters, right? So with this, you can have a dashed cross section. I don't know why you would do that, why you would adjust a line type, but you can. I mean, it's an option. Let's go back and let's not do that. By layer, right? So if line type is continuous, it's going to be continuous here. And the only difference is going to be that we will increase the width of whatever line thickness we have here under line type, or sorry, print width is going to be 3 times thicker, right? So I can have it 10 times thicker, and already showed you the color, so we don't need to mess around with that. Okay. Right, so now it's a really thick boy. Show. There it is. Right, and this is just visual, right? Once you make 2D, I believe it's not going to make 2D. I don't think it's going to work. I'm just checking tangents, hidden lines in silhouette. From input object properties should be from input objects, I believe. Yep. And this is just a perspective make 2D. Let's just take a look if that actually is working. No, in this case it's not, right? So, but I do know how to make it work, so don't worry about that. One actually. Yeah, okay, we stopped playing. So those don't work in Make 2D, but they will work in what we will be using in later chapters. Right, so that's the section styles, right? And that's all the settings that you have, that you will get. So now it's time to actually create proper layer structure. And for that, I have a template. So those of you who are supporting the channel do get access to the template, and you don't need to do this, but if you don't, then just follow along, and we will make ourselves the template right here. So step one is to actually have your proposal layer, and all of the layers, other layers, will live in this as sublayers inside of this proposal layer. Then in here, I'll just make a new sublayer and call it glazing. Glazing. All of the windows, doors, like anything that has glass and framing will live here, right? Then, oops, sublayers layer. Then the next one is going to be roof. So all of the roof structure and objects are going to be located here. Then we want a layer for walls. We want a layer for any... Do we do it? We want a layer for slabs first. So walls are basically vertical slabs, right? And slabs are horizontal slabs, surfaces. Then we will want a separate layer for interior. So this is going to be interior finishing. If we have any metal work, if we have staircases and so on, that's going to be inside of the interior, placed as like sub-objects inside of the interior layer or sub-layers inside of it. Then we will have structure. And then usually I just do other. But in this case, I know that other will not be necessary. So I'm going to say car park, because I know that there's going to be a parking lot and it's going to be covered. There's going to be stuff happening there. So I'm going to use car park or parking. Let's go for parking, right? So all of these are the main layers, right? Then inside of the glazing, what we want to do is to have 3 different sublayers. Glass. I'm just thinking about hatches, right? What kind of hatches will I have? I'm going to have a separate hatch for glass, or that the hatch will not exist, will be non-existent. I'm going to have a separate hatch for frames, and I'm going to have a separate hatch for any kind of a windowsill and so on. So I'm going to call it metalwork. Metalwork. It's not necessarily metalwork, but in my head I have windowsills. If you have like ventilation shafts and so on, all of that is metalwork, right? That is connected to glazing. And glazing is kind of done. Then for roof, roof is kind of tricky because there's so many different types, but you always have exterior finish for the roof. You always have decking, unless it's a concrete roof, I guess. In this case, we have rafters. If this is a concrete roof that you're designing, then you won't need, this is going to be an empty layer, right? And depends on where you're designing, but usually you have heat insulation. Heat insulation, right? That. Then walls. Okay, what do walls have? It's going to be a little bit trickier, but in my case, now I'm thinking about the project. So it's going to be logs, the perimeter, right? There's going to be logs that will need to exist inside of the walls layer. Then we will have heat insulation, right, on the inside. Then we will have interior finish. We will have interior walls. So separator walls. Well, I could call this separator walls as well. We will have also metal work and others, right? Other stuff that we're not thinking about right now. Okay, almost there. Slabs. For slabs, we will have, 1 second, sublayer. For slabs, there's going to be the basement, or just floor finish? No, basement floor finish. I'm thinking from the bottom floor. So basement floor finish is going to have, going to be different from the rest of the building, so that needs to be incorporated. Maybe we'll have a different hatch. Concrete for sure. That's for basement as well. Then heat insulation. We will, okay, and then the rest of the floors are going to be wooden. So I'm doing subfloor. I'm doing structure. So beams and whatnot. And I'm doing top finish. What else? That's kind of it, right? Oh, and side finish. So for if I have a balcony, the edge of the floor should, edge of the slab should also have a finish for it. Side finish. Okay, so something like that, and so on, right? I don't want to go over all of these, but as long as you understand the logic, you can make your own template quite quickly, right? So I'll stop here because it's getting boring, and we will just continue on with the section styles and whatnot, and changing up the section style. So the way of how I do it is usually I try to find, and I need to move this down 1 second. I try to find layers that would share the same hatch as to what that would share the same hatch, right? And then I just create one section style that I, for example, already have here in the test layer. And then I just select, okay, this kind of hatch I want in my logs, in my rafters, and I'm holding the control key, I'm just selecting them. In my decking, sure, interior walls, concrete. Concrete should have, of course, a different hatch, but now I'm just showing it as an example. Structure, subfloor, side finishes should not have a hatch. They are going to be too thin, right? So all of these, I just right click, choose match properties, scroll to my test, bam. All of these are now changed to hatch exactly as this. Then this is my metalwork style, which I should adjust back to 3 in terms of thickness, you go, right? And all of my metalwork frames, metalwork here, and so on, that I think that's it, going to have that hatch style, right? So I match properties, test 2, bam, that's now matched up, right? That's the logic. And once you have all of that done, and once you have all of your models inside of these layers, proper layers, then the sectioning of them is going to be really, really easy. And I'm going to now pause the video, and I'm going to actually create the whole layer structure before I begin modeling, and I'll talk a little bit more about the layer structure, right? All right, there we go. This is done. So the structure is complete, and I'm just going to showcase it to you in a very simple fashion before I move on to actually designing or modeling out the building, right? So basically most of the stuff that I'm expecting to be thin is not going to receive a section style. It's going to just be no style for the section, so that there's no hatch. But all of the stuff that I anticipate to have a thickness, that's gonna have a proper section style, right? So here, if I just run a clipping plane, the only existing, actually, let me hide the existing layer. There we go, so that it's not in the way. Existing layer is not going to receive any hatching styles whatsoever. But here you can see that now the retaining wall as well as the slabs get their own solid hatches. And actually now when I'm thinking about it, they shouldn't be solid, should they? Concrete slab should have a proper hatch 1. And stairs should have also hatch 1. Please recalculate. What the hell? Why is this doing the thing that it's doing? All right. So now the layer, the whole layer structure is done, and there is one thing that I want to do, and that is to change the unit scale from meters to millimeters, because at this point we really want to work in millimeters so that we can detail out more or work in details more. And also, generally speaking, it's nice with the hatches and so on if your units of measurement aligns with the units of measurement of the paper once you start printing things out, right? So with that being said, I'm just going to type in units. I'm going to choose millimeters here. I'm going to hit OK. And when it asks me, should I scale? Yes, it should. So 1 meter becomes 1,000 millimeters, right? And now with that being said, I can kind of show you with a clipping plane how the hatching looks. Right now I only have the surrounding environment, right? So it only hatches the surrounding environment. But in this case, the concrete slabs receive angled hatch right here. And all of the, the retaining walls receive a solid hatch. I was experimenting with a double line hatch for metal, but that was a little bit too iffy. Okay, and basically my landscape layer is exactly the same. Layer ring is exactly the same as what we had before. Then we have ourselves a glazing layer, glass frames, metalwork with all custom settings. The glass receives a custom setting, but as you can see, it only receives a background that is white, and everything else is just set to be none, you know. So I'm basically just saying, if you're cutting through glass, just give me a white background for it. Frames. Okay, frames. They are going to be, window frames are going to be way too small to receive a hatch. So this could actually be a solid. That works as well, but in this case, I'm just going to say none and give me a white background for them as well. And metal work, that is going to be a solid black color, right? Just like metal work for here. And it kind of continues, right? It kind of gets repeated throughout. I will not dwell on this too much because I feel like there's more important things to note, because these kind of templates, they change or they get adjusted from project to project, but the baseline is this, right? At least the core layers are these. Heat insulation is a more interesting one. I'm using this kind of hatch for it. I know that usually you have a line type, you know, the squiggly line for the heat insulation. In this case, I don't, because for a few reasons. One of the reasons being the heat insulation thickness will change over time when we kind of need to adjust it, or we'll decide to adjust it if we decide to adjust it, and I don't want to go through creating a new line type just for it. So I'm just using a hatch, right? Should work just fine. And now I think it's time to actually do some designing, some modeling, right? And the way of how I'm going to do it is quite simple. It's just a modeling exercise, right? So all of you who are watching this video already know how to do 3D models, like architectural 3D models, and it's nothing special, right? You just keep, it's the same process. One thing that I will note, which might be interesting to some, is if I were to turn on existing, and from the existing, I only care about the foundation. So I'm going to select everything, turn everything off, probably missed something. Yeah, missed the neighbor, and turn on the foundation layer, right? And then also turn on the logs layer. Creating an interior for something that is crooked. You can see here, you know, how close, for example, how close this area is to the foundation and how far away this area is from the foundation. So the outer walls are crooked. Creating an interior here and then locking down the interior here is going to be painful. So the way of how we're going to fix it up is going to be by creating a shell of heat insulation that is cut to be level, right? With an air gap between. And the air gap is going to be the variable, right? The variable between these. And the way I'm going to do this is just selecting these, what's the word? Logs, right? Creating a bounding box around these logs. Going to the perspective tab right here. So this is like touching the log right here, which is absolutely fine, and giving this 150 millimeter thickness, right? Oops, my bad. Holding Alt key. 150, right? And I'm just going to change this to proposal walls. Don't I have heat insulation here? 1 second, please. Oh yeah, I do. There it is. Change object layer, right? And now by doing this, I'm basically creating a barrier here. And that barrier is going to be a straight line, and from it I can start offsetting axes and so on, and I can start designing the inside, right? So it's quite important to level out things when you're working in a crooked environment. For those of you who are just modeling straight up, it's not necessary. So as I'm going to be creating the design for this, again, it's going to be very straightforward. So I am going to be skipping ahead, right? And then we will talk about the design that has been made, and I'll just guide you through it. I think that's much more, it's much better than just 20 hours of me, slowly building up the design. One thing that I will note though, is that some of the elements, or all of the elements that are going to stay, actually this part I'm going to show before I skip ahead. So the elements that I want to save are the logs for sure, going to be the foundation for sure, and some of the structure. So at this stage, I select which parts do I keep. And the landscape is getting in the way, so I'm going to hide it. So let's go for this. Like that. And for now, I'm just going to copy everything into the other layer and then change the layers of those things appropriately. Actually, in the walls, I might already have, I have logs selected here, or the layer for logs created here, so I can just select all of these, and I will not be moving them to the logs layer, I will be copying them. You always want to keep the copy of the original building, right, on the back burner, so to say, if you need to go back and reference it. So logs has been copied, and then under structure there should be existing structure, and then we have our foundation, right? So in that, I'm going to grab the perimeter foundation right here, and I will not be grabbing these blocks here. Those are trash, and I'm just going to be copying those in as well. There we go. That's nice. And then I'm just going to look at the structure. For sure, this structure will need to be copied over, right? It's valuable. I'm just going to take a double look. Okay, this is very... I must have made some mistakes in modeling because there are some duplicates. I'm just going to cell duplicate. Oh yeah, all of this. Delete. And let's just change all of that to the structure layer, change objects. There we go. So all of these elements, I want them in the new building. I don't want to get rid of them. So I'm just simply going to select them. Make sure that I don't select anything unnecessary. And I'll just find where to copy these guys to. And I guess under roof, I can do... No, it should be under... Yeah, it should be under beams and columns, structure, existing beams and columns. I'm just going to get it there. Change object layer. There we go. Then what else do we save? I would say most likely all of these are going to be saved. Those also go. Did I copy or did I change the layer? God damn it, I'm being stupid. If you accidentally do something and you unselect an object or set of objects, you can always sell previous, sell prev, and then cry because now, goddamn. Okay, sure. So I made a mistake, sorry. It only selects the previous ones, right? So I accidentally selected these already, so I actually need to reselect the beams here. I will need to have a break after this. Okay, this, and that. That's a funky one. We'll need to talk about that. And everything else will need to go away. So beams and columns, copy objects to layer. They're copied now. Great. And I can hide them here. Besides that, chimney is gone, floors are gone, ceilings are gone, interior walls, all of them are gone. Basement ground is gone. Neighbor, sure. I'll be using the neighbor, but later, right? So this is going to be the only parts of the building that will be kept original. And by the only, I mean, it's not that small. I mean, it's most of the main structure is going to be kept original, and a lot of it is going to be remade, right? And if I then notice how these are already have custom clipping styles or clipping plane styles, if I even clip through them now, you will see them being hatched properly. And by properly, I mean, what the hell is this? Foundation, what kind of hatch did I give you? Oh, that hatch is annoying. If you want to get rid of a hatch style, you can go to options. I believe it's hatch, select the one that is annoying to you, and then delete it. And there's two solids, I don't care. I delete that one as well. I can't delete that one, so I delete this one. There we go. It's okay. And it's still there. Can't believe it. Anyway, I'm just gonna change this to hatch 1, and that's gonna be over with it, right? So all of my hatches are messed up because of that single import. That's fine. I'll manage. It's just a little bit inconvenient, a little bit annoying. Right. So now, with that being said, I think it's time for me to start modeling, start designing, and then once the design is finished, I'm going to talk about all of the different things that you need to take care of and you need to think as you are designing your own building in Rhino. Upper level course, not lower technical skill level course, more of the way of thinking course. Get it? Okay. So let's skip ahead. All right, here we are, 3 days later. 3 days later, the design is finished. The proposal phase design is mostly finished with an asterisk. I'll explain that in just a second. And I want to guide you through it. I didn't record the process of actually modeling this whole thing out simply because the process is kind of, well, boring. It's very much basic, and I don't want this, whatever, I guess 8-hour long video at this point, to become 12 or 14-hour long video. So I'm chopping that one off. But the basic principle is you model in the correct layers. You first create a layer system, and then you model inside of the correct layers so that once you have finished modeling and you turn on your trusted clipping plane or whatever, bam, let's rotate it into a section, and then you cut a section through your building and you zoom in. Well, don't try to cut along the wall, bam, and you zoom in and you look at the nice little hatches. Everything aligns mostly nicely. Did I make a boo-boo there? No, everything's here is fine. Yeah, that's fine. That's okay. So things are aligning. You can see the old crooked beams and whatnot, how they are integrating into the existing structure, how much work the builders will need to do to even them out on the second floor with the straight beams, right? Chisel in here, add some stuff in here, the filler in between here to straighten it out, add a little bit of padding, right? And then surface finish. So I have these kind of different layers here. Here completely redone, or no, sorry, the beams in this direction are still crooked, as you can see. But this long boy right here, clearly it's not going to be one single beam running through here. It's going to be a few. But this is new, completely new, which is also being held by completely new columns. And basically the bottom floor or the basement floor, these beams right here and these columns right here are completely fresh. So everything, like the floor here, is completely redone as I expected to do. Okay, so that's basically kind of it. I wonder why the hell is this so thick, this hatch so thick. Is it the only thick hatch? I think I made a little bit of a boo-boo, but that's fine. I'll fix it later. Or I could kind of fix it now. Let's go to the slabs. Let's find ourselves our heat insulation hatch. Right there. Click on the custom and look at the width, scale, and line type. Line type, section, line type 01. I don't really care for it too much. So I'm going to change from custom to be by layer. Width scale 3. There we go. That cleans it up. Nicely. There are still some mistakes here and there, but that's fine. We will address them when we generate 2D drawings from this. With that being said, just general design things. Metal has been added, metal cladding has been added on top of the foundation. All of the windows, or basically big cut through the building right here. Structurally, not that, doesn't mess things up. Big opening through the building right here with a beam running along this edge as well as below here, right, to let some light in. And everywhere, actually this maybe will be easier to see in shaded view. The brown stuff is metal. So wherever I have opening, there is metal kind of framing added around the opening to just increase the framing, right? So to make it a little bit stronger and also to make it look like it's inserted into an old structure. So an interplay between an old and new, I think that will look quite nice once it's actually built, actually done. Besides that, the rhythm, the step size of the beams has been reduced to 60 centimeters. So now they go every 60 centimeters. I'll need to address this heat insulation here. Every 60 centimeters, so that heat insulation blocks fit quite well, with an exception of where the glazing is. The glazing thickness is anchored to the thickness of the door, the main entrance, right? And the door is made out of 2 slabs. One is going to be glass, the other one is going to be, I don't know, door material. We'll see. Speaking of glass, I have it hidden here, the glass layer. Once it's turned on, I mean, it's harder to see inside, so I usually have it turned off. Besides that, you can see this working quite well, quite nicely. And at this point, you might be thinking, well, there's no blocks, there's nothing. This is, just a regular 3D model, and you would be correct. Absolutely. But it's a 3D model that once we start generating 2D drawings from, the drawings will be, first of all, dynamic and will be hatched to a certain extent properly. And I say to a certain extent is because the detailing is still not there. I still haven't modeled out this properly. This is intersecting and so on. So you do need to have a cleaner 3D model for this to work perfectly. But even with this, it works quite nice, right? So I'm kind of excited about it. Generally, in terms of the plan, usually we draw. Once we have a working model already, we draw out the plan just in 2D, not make 2D, no nothing, just regular plans in 2D, just to see how it all pans out, And in this case, for example, the staircase, it goes up here, but in reality, we had to switch directions, so the staircase goes opposite way. And that's just because of the flow. It's a better flow for people, and also you don't bump your head in the ceiling if you do it this way, right? Besides that, one second, let's go to the top view, just to kind of explain it to you quickly. You enter here, you are able to go up. If you go up, there is the work area, and then there is the bedroom with shared bathroom, entrance, right? The bedrooms are only fed light through newly made skylights. Then you have bookshelf. Interesting bit is that you have a bridge. You have a bridge that brings you to a work area, workroom. 2.2 is home office, right? Which looks directly at the river. Back to first floor. As you are kind of arriving here, you have a huge kitchen, a dining area, living room. Same opening. Above, you can see with the dashed line, that's the bridge. Then once you enter here, you have the second, like this is like a entrance hall. So basically, when you park the car, you usually use this one to put down your coat and so on. And it's widened up, as you can see here. And also 1.9 is the kitchen pantry. So if you just have groceries, you can just put them here, right? Then inside of here, all of the utilities are placed here. You have a bedroom, you have bathroom, a bedroom with a kind of walk-in closet, kind of. And then a bigger guest bedroom. Or is it master? Sorry, it's master bedroom. What's on the second floor? Second floor are guest bedrooms, first floor master bedroom. Sorry, I already managed to forget. Anyway, so you draw that in quickly in 2D, then you model out the building as it is and call it a day, right? Well, not so fast. Usually, if everything is unique in the building, you don't really need to use blocks because you would just use an insane amount of blocks, and then you deal with just stuff in different layers instead. But in this case, I kind of want to showcase to you the block management and the way of how you operate with blocks. So I'm going to force the use of at least a few. And for that, I'm going to adjust, or I'm going to replace the interior doors with blocks because most of them are kind of the same size. And I'm going to replace the exterior windows so that later we can use these for scheduling purposes. So first of all, how do you create a block? And I guess this is like chapter 5.5, 5.2, 5. I don't know, but this is like still chapter 5, but a new part of within the chapter, blocks. So how do you create blocks? How do you make blocks, and how do you operate with them? For that, I will need to go into my shaded view. I don't really care about this. I can just delete that. I go into my shaded view, and here I will just make a quick little block. So let's do a box. Size doesn't matter. Layer, actually layer kind of matters. Let's make just here 2 more layers. One is going to be called red. The other one is going to be called blue. And red layer is, or actually 3 layers, red, blue, and green. Okay, red, blue, and green layer. Then there's a box, and it's going to be placed in the red layer. Oh yeah, actually let's give color to those layers so that we can see what's going on. Green. Oh, sorry, that's blue. My bad. Blue, green. Right, box in red, sphere in blue. Change. And then I will select, I will not put anything in green. I select both of these and I say block. Block. It asks me what's the base point of the block, and I need to say whenever I insert this object into anything, then I need to basically specify the insert point. So for example, I can say, well, let's go for this corner point, right? Click and name my block, my first block ever. This is a sphere and a box. And then if you're doing links through web, you can do descriptions and URLs. We don't dig that deep, don't care about that, but we do, usually writing descriptions helps if you have a lot of blocks. Anyway, once that is done, hit OK. And now this is a block. If I select it, it says one block instance selected, which means that now if I have 1,000,000 of these copied, the file will not increase in size because it just keeps referencing the same thing. So what can you do with a block? Well, you can, first of all, you can optimize your scene, as I said before. Second of all, you can count how many you have and yada yada. Also, the block itself, if I right click and change object layer, so if I change the block layer into the green layer, you can see that the layers of these two objects didn't change. Only the block changed. So I can hide the blue layer separately. I can hide the red layer. And my block lives in the green layer, so I can hide that as well. And now it hides both of them, right? So that kind of messes with you a little bit, but once you get the hang of it, it's fine. Example of block being very useful for me. Blocks being very useful for me. When I imported all of the scans in a rough way into just imported into the Rhino model, my Rhino model was 1.5 gigabytes. That's too much. That's too heavy. Autosaving is hell. So instead, now if I select these guys, you can see it says one block instance added to selection. Yeah. So the way I do this is, and this block instance, sorry, that's not enough. That's not enough. This block instance is not saved inside of the Rhino file. My Rhino file currently is 90 megabytes with all of this data instead of 1.5 gigabytes. It's not saved. So I can show you what is happening with it. Oh, actually, I shouldn't delete this. So if I type in block manager, and let me just grab it in here. Ooh, shouldn't have done that. 1 second. Please hold. 1 second. Bam. Block definitions. There we go. So these are all of the block definitions that are currently being used. And the reason why there's so many is because of the imported DWG files. If you want to get rid of the block definitions that are not currently being used, you can always use the command purge, enter. And here you can tick mark block definitions. I'm gonna purge everything, honestly. Hit OK. And now you can see that there's only 2 that are left. All scans reference and my block, my first block ever. And it says how many there are in top level and how many objects there are inside of these blocks. So let's first look at my first block ever because that's an easy one. And let's make 1, 2, yeah, sure, 3 copies of it. So here, top level says there are 3 copies of this top level block, right? Or at top level, there are 3 copies. So that's this number. Then in total, how many blocks do you have? In total, you have 3. Why are these 2 numbers different? Is because you can have a block inside of the block. So for example, if I have another one, let me just model out this box and grab these 2 blocks, make copies of them and place them here, whatever. And then make this into a block. Base point doesn't matter. And I'm just gonna call it block with 2 blocks inside of it. That's a rough name for a block, but it is what it is. And here you can see that block with 2 blocks inside of it. It says that at top level it's only 1 entity, right? And in total there's only 1 of them, and object count is 3. And if I look at this, then inside I have my box, and I have my first block ever instance, and another instance of my first block ever, and inside of it I have my boxes and my spheres. Same thing here, boxes, spheres, right? It's getting a little bit tricky, I know, to follow, but it is what it is. So with that done, I'm basically here, top level and total blocks for my first block ever becomes different, because top level means that I can select 1, 2, 3 blocks, but in total there are 5 of these blocks being used. Hopefully that makes sense, right? And then again, if I expand this, I can see all of the spheres, and all of the settings for those spheres are located here, and all of the boxes, or opposite, all of the boxes, all of the spheres, right? And you can, of course, change the line types of them, give them names, and so on, right? So it goes pretty deep. The problem is there's no dynamic blocks in Rhino. The reason for not having dynamic blocks is because the creators of Rhino cannot wrap their heads around why would anyone need them, even though the community tells them that the dynamic blocks are needed. So if you come from AutoCAD and you expect to have dynamic blocks in Rhino, forget about it. The plugin called ArcGIS, wait. Visual Arc, sorry, not ArcGIS, Visual Arc. The plugin called Visual Arc has dynamic blocks, possibility for dynamic blocks, but again, it costs money, and they charge per year or per month, which sucks, right? I don't think they have perpetual license, but anyway, so we're stuck with static blocks. Okay, so that's how blocks work, right? And what you want is you want a block for your doors, a block for your windows, and anything that you have a lot of, you want to have as a block, because then you can extract statistics of that very easily for scheduling purposes, right? That's the only reason why you would use blocks. Well, a few more, but optimization. You change one block, everything else changes, right? So for example, if I select this block right here and I edit, or is it block edit? I can add an object to it, I can remove an object from it, and so on. So for example, if I just make another box, right, and I add an object to the block, I think it did it. What is it? Hello? That was weird. Let's try again. Add object. I can't select it. One second, I'm very confused. I was being very stupid. I just needed to hit OK. So let's do this again. Control Z, select the block, block edit. That's the correct name of the block. And I can take, I detail it. So I'm adding in more stuff to my nice looking sculpture thing that I will be replicating multiple times. Select the thing, add object. It has been added already. It's gray because it has been added already. Hit OK, or sorry, hit enter, and then hit OK. And it updates, all of the blocks update. My bad, I forgot that you just need to hit OK and it updates. Anyway, so that's how you can edit the blocks, and how you can amend, adjust, and so on the blocks. You can also override blocks, of course, and the benefit of it is also if you just delete all of the block instances, they still exist here, which means that as long as you have block manager turned on, like this window turned on, you can always take the block, drag and drop it in, click, there it is, back again. So as a company, you can slowly build up blocks for different manufactured windows, doors, and so on, and build up your library of these objects that don't change in size, right? That's blocks. Another thing that, and once I finish the spiel, I'm gonna show you how I create two of them. Also, another huge benefit is referencing in the blocks. Actually, let me get rid of these two. Delete that and delete that. There we go. This all scans reference. I'm gonna show you how I add it in. So let me delete this, right? And let me actually purge so that this is not in the way. There we go. I don't have my scan data anymore. Oh no. So I make sure that I'm in my scans layer, that this is active. And I'm going to navigate to, actually I'm going to navigate to my Rhino file. This Rhino file is 1.2 gigabytes in size, and it contains all scan data that I just exported as a separate Rhino file. And I'm just going to drag and drop this in. It asks me open, insert, import, or attach. And here I actually will use insert rather than import. I hit OK. Asks me for what do I want to do. And here there's the block definition type. Is it embedded or is it linked? If it's embedded, it's inside of the file. It's going to be saved together with the file. The geometry is inside of the file. If it's linked, if you delete the original file, in this case, the Rhino file that I'm currently importing or inserting, the link will be broken and it's going to be bad. So if you're reusing the same file for multiple projects, linked is the way to go. Right? Makes it much lighter, right? And then you can give it a description again and so on, right? So let me hit OK. Asks me for the insertion point and so on, and should it be a block instance, or should these only be like individual objects or something? No, I want it to be just a block instance. Hit OK. Give it some time, and it's going to import. Yeah, it's important to also know that as you are importing the block, you need to make sure that that's a weird visual bug, but you need to make sure that you're importing it into the correct position, right? And as I was exporting it, the block was exported with its origin set to 0, 0, 0. So I'm just gonna, insertion point is going to be 0, 0, 0, 0. I hit 0, I hit enter. Voila. We're back to normal with all of the layers here. The top level is here, like everything is back to normal. I'm just gonna make a new layer 1. I'm gonna close or gonna lock down these points. I'm gonna make my layer active and hide the scans. Okay. So now let's make ourselves a quick little block of a door, right? That's going to be the first one, and we're going to come back to the blocks later once we actually work with the drawings. But for now, just the door, right? I'm going to hide a bunch of stuff that's in the. Actually, let's just use a clipping plane. It's just faster. There we go. So I'm just gonna yoink one of the doors here with the handle, right? And I'm just gonna get it. Actually, I'm gonna grab the. Should I? No, that's fine. Door with the handle. Make a copy of it like that. Select both. Actually, the handle and the door intersects weird, so I'm gonna Boolean difference out an opening. And these already live in the layers in which I want them to live. The door has its own layer, the handle has its own layer, everything's fine. So I'm just going to select these two, and I'm going to type in block, or actually, sorry. I will also chamfer edge. Yeah, chamfer edge for the door. Next chamfer distance, we're in millimeters. I'm gonna give it like a 1 centimeter, no, 5 millimeter chamfer. And then face edges for this face, like that. So that's a is it a 5 millimeter chamfer? Damn, that's too much. I'm gonna give it less, 2 millimeter chamfer. Face edges, this and this, that's great. 2 millimeters, so I get a little bit of detailing here, and also just generally here. Just so that it catches light nicely. Actually, 2 millimeters for all of this is bad. Sorry for starting to design here, but I'm just gonna chamfer edge and just give it like 1 millimeter hit on all of these. Okay, that seems good. Show. And both of these become the door, the block for the door. So I'm going to block it. And for block base point, actually after chamfering, no, that's still fine. This is my anchoring point, the midpoint of the door, the bottom midpoint of the door. I'm just gonna call it door interior type 1. That's gonna be useful later. Hit OK. I have my door interior type 1. And now all I need to do is just replace these doors with my door interior type 1. The only problem is that this block, I have no idea where I have it. Yeah, it's now placed in layer 01. So I'm just going to double click on that layer and call it door blocks, right? Just to make sure that that layer is actually created and then properly used. With that said, I'm gonna delete that door. And here, I kind of want to insert, yeah, and then I have my door interior type 1. So I'm typing in insert door interior type 1, hit OK, and I just select this midpoint here, right? And I repeat, hit OK, midpoint here. I wonder if there's like insert multiple. I wish there was. And there's no more doors here. So there are three now, 3 doors that are just the same from the same block. Great. Let's move the clipping plane down and just pray that these doors in the first floor are all the same thickness, and I'm sure they will not be. Actually, let's first try inserting, I guess. And also the positioning of them is a little bit awkward, which is fine. Let's just hit OK, see if that, yeah, the thickness here is different, and that starts becoming very, very tedious since we don't have dynamic blocks, right? That's the, I'm just checking, yeah, that's the problem with not having that. Technically, I could make a second type of a door, you know, type 2, and then use that. But for this particular course, I don't think that is needed. Because it's already pretty clear how you use it. Then let's do one more for the windows, because these, at least I know, are part of the same, whatchamacallit, same block, or they are very much the same. So 8 windows are exactly the same. So I'm just going to make a copy of one of them like that, and I will make sure that it's horizontal, right? So rotate 3D. This is going to be much more, much easier to work with later, like that. And then make this into a block. So there's glass, you can't see it because it's all grouped up, ungroup. There's glass, another layer of glass, there's the window frame, and there's the metal framing on the, for the exterior, right? So the question is, how do we anchor this? Where do we anchor this from? And I'm just going to, okay, select this. I think midpoints are the way to go, so I'm gonna block it. Base point is gonna be, it's actually interesting. Let's look at the anchoring of this. Like that. How did I anchor this? Yes. Oh, there's also like one more. Oops, my bad. Can make a copy of this. There's a little metal frame that also needs to fit on the bottom side. Rotate 3D so that it fits, so that it aligns. Sorry. Get that corner in here. Okay, now we're good to go. And from this, I can see that the anchoring, most useful anchoring is along this edge of the heat insulation. I think that anchoring is kind of good, or the corner of the heat insulation and the beam. That can also work. I'm gonna go for the midpoint. I kind of like midpoints of things. So this, I'm just gonna say this point right here, right? Block that, and then call it skylight. Yeah, just skylight. Hit OK. Great. And now the first one is going to be tricky because I need to rotate it properly so that it sits on the roof. And the best way to do it, in my opinion, is to just kind of, instead of using copy, use orient, right? So I'm going to use orient, orient 3 pt, and the reference point 1 will be bottom left. So, sorry, if you look at it from this perspective, this is the first reference point, this is the second reference point, this is the third reference point, like that. And then the same thing for here. Matching reference points, right? 1, 2, and 3. So now this is perfectly aligned. For now, I'm going to lock the block so that I can delete the unnecessary bits in here. It's a little bit cramped. Wait, where's my trusted clipping plane? Yoink in here. There we go. And I can just get all of these in here. ZS. Make sure that everything is selected. Seems like it. Delete. Just go through it. Yeah, this is not. This needs to go as well. Everything else seems to be fine. Yeah, that's a board. And same thing here, right? Delete, delete. The windows were pre-grouped, so deleting them is kind of easy. Like that. Okay. Now we just unlock. We get a single block here, and we just make copies corner to corner. I mean, this is pretty straightforward, pretty easy, right? Once that is done, I just select the blocks from here, and I just mirror them to the opposite side. The roof is newly modeled, so it's perfectly symmetrical, right? Because it is going to be a full reconstruction. And that's it. Okay, now we have 8 skylight blocks in here and 3 doors. That's going to be very useful for the next step, which is going to be, step afterwards. First we make the drawings and then we make the scheduling, right? And then we work with scheduling. So that's kind of it in terms of just raw modeling and how you operate with it. You use the layers with their section styles quite a bit. You use the block definitions both to optimize the performance and also to quantify things that are very much repeating quite a bit. You save the block definitions so that you next time when you need to use some pre-made stuff, you can already have them in your library. Very useful for furniture and whatnot. I'm just thinking if there's anything else that I'm missing, but no. At this stage, that's where you should be, and the clipping plane should still hatch perfectly fine, even though it's a block. Yep. Well, it's an awkward angle, right? But it does hatch exactly as I want, even though this is a block definition. All right. Now, I guess that's it for chapter 5. We move on to chapter 6, which is drawing generation. Let's go. Alright, so let's begin with the 2D drawings. In this chapter I'm going to cover all of the different techniques that I know that you can use in Rhino to generate, extract 2D information, manipulate it, add additional information and so on to produce architectural drawings in Rhino without needing it to export into other software. So that being said, the first step is actually to prepare the layers as per usual. And the way of how you operate in Rhino with 2D drawings, at least Rhino 8 and so on, is through the Sections tab, through the tools that are available here in the Sections tab. The dynamic portion of the drawings is controlled through here. And most of these, I will just use commands, but you can explore it on your own pace later after the course is finished. So all of the tools are going to be here, right? So first step is to create a new layer. Call it clipping planes. Dynamic drawings are extracted from clipping planes. So for every floor, for every section, we will have a separate clipping plane. Make the layer green or whatever that you will see. Make it active and just type in clipping plane and start drawing it. Before you actually start drawing the clipping plane, make sure that your C plane is set to, for instance, ground floor. Let's say that's the first drawing that I want to make. And you just then inside of your ground floor, that is definitely not a ground floor C plane. I'm just gonna double click on ground floor, make sure that it's there, draw a clipping plane again. There we go. So now this clipping plane is drawn on the ground floor. I will move it up by 900 millimeters because usually you do cut your plan at higher altitude than your floor slab. Investigate a little bit. Seems to be fine. Seems to be okay to me. Why is this cell layer? Select this bad boy. Okay. What is this layer? Heat insulation 150 mil. Okay. So the heat insulation layer seems to be a little bit weird with the section styles. I will just fix it up just real quickly. Apologies. Proposal. It's gonna be under walls, under heat insulation. There we go. Click on the custom, and yeah, line type is set to custom. Nah, we do by layer, right? So line type is now set by layer. Should be okay. The thickness seems to be okay. All right. So sorry about that. So back in here, the clipping plane that I have just made is going to be used to create ground floor plan drawings or generate ground floor plan drawings. So I'm going to rename it. I'm going to go to its properties and give it ground floor GFCP clipping plane, right? GFCP, and for the label I'll use text label. Text label makes it so that I can actually see here what kind of clipping plane is being used. With that done, now it's time to actually generate the drawing, and for that I will use a command. Is it clipping drawings, section drawings, clipping drawings? Yes, it's called clipping drawings. I will select my clipping plane, enter, and I will just place it right here, right next to my building. For now, we don't care about the settings. I'll show you how to adjust the settings later. So this is what I get, right? I don't get the contour lines, that's fine. We will get the contour lines later on. If the limitation, I guess we can talk about limitations, right? So limitation number one is, for example, if I here draw a box, let me just move it down. This is not reflected in the drawing. I believe there should be, there's this button, update clipping drawings, and all of them should be updated. If I click that and wait, now the box has appeared here. Great. But if I draw a point, get that one up in here. Oops, that's too high. Let's just get it close to the box. And also next to it, I'm gonna make a line segment. So there's a point here, there's a line segment here. I can also write text and whatnot. Neither one of those will transfer, unfortunately. Yep, you can see that neither the point nor the line has transferred, which means that I cannot do block substitution for example, for the doors, right? This is horrible. This is like, I don't understand how they missed it, but they managed to miss it, right? So now we just don't have a possibility to do substitute doors with 2D representations of them for the 2D drawings. So it is what it is. We will need to do a little bit more shenanigans. That's the main limitation, in my opinion, that we currently have with this dynamic approach. Other than that, as you saw, any adjustments that you make here will be transferred or will be properly. Sorry, any adjustments that you make here will be properly transferred into here, right? Dynamically, as long as it's done in 3D. Okay, so that's the first thing. Second thing, actually, let me reset not reset, recalculate the clipping plane drawings. There we go. And now the second thing, not second thing, but further on, editing. Editing the clipping plane or the drawing, this drawing and the style of it can be done by typing in clipping or section drawing. Sorry, I forget. Edit clipping drawings. Edit clipping drawings, select clipping sections. I select, for now, this one. That's the only one that I have. Enter. And here I have all of the different options that I can change. So angle is how, the rotation angle of the drawing. I don't care about that. Placement point, I can place it, somewhere else, or choose to place it somewhere else. Let's wait for it to, print width and display color should always be by layer because that's how you want to control it through the layers, right? Hatches, showing them should be turned on so that you can actually see the hatches. Solids should not be shown because, why should they? Keep the solids for the actual 3D model. Add background turned yes means that there is going to be stuff shown at the back of the projection. If I have this set to no, then only the area which is being clipped will be shown. Like only the section plane will be shown. And the last one is show label. Usually I have it turned off. The label is the name of the drawing. So if you want, actually, why is it not popping up? That's weird. Oh yeah, it needed some time to update. So if you want, you can have this label here. Sure, we can keep it. We can keep it for now. So that's the drawing, right? That's the drawing that we get, and the editing that we can do with this. Pretty straightforward. I mean, it's pretty simple. Now getting it into, or actually let's look at what's created, right? Here a new layer is created, GFCP layer, and this GFCP layer has everything is locked here. They don't want you messing with it, but it has all of these, the background, as well as the initial kind of drawing, right? Or sorry, the section line, as well as the background lines. So there's not a lot of control. If you want more control, you could use print width not by layer, but by object, and then adjust it. But in this case, we keep it as simple as possible, right? So right now, I'll hide the background, and here, I'll just take a look at the line thicknesses. Or actually, sorry, before we do that, let's create a layout. Let's actually push this into a layout so that we can investigate a little bit further. So to make a layout, if you don't know how to, I'll explain. I already have like 3 of them done here, so let me just delete them so that we can do this together. Okay, new layout. Click the little plus sign, new layout. Name it GF ground floor. Initial detail count. We will only have 1 drawing in here, so it can be 1. You can do none. I can show you how to add the window into the the drawing. So that we can do 0. Printers should be done with. I guess for this one, I'm just going to use Rhino PDF. A3 sized seems like a vertical format to me. And then just hit OK. There we go. That's a layout. That's a layout that is called GF that we can mess around with. First thing that I do immediately in 2D layer, I expand and I create a new, what's the word? I'll get there. Layer, sublayer. I create a new sublayer and call it layout data. Layout data, and inside of that sublayer, I create no print. Anything that I don't want to be printed, and I drag it, of course, into 2D. Anything that I don't want to be printed will live in this no print layer. For example, I don't want my detail outline to be printed. I only want to have for the stuff that's inside of the detail to be printed, right? Hopefully it makes sense. So I'm going to choose line print width, the print width for this. Instead of default, I'm going to go for no print right here. Hit OK. And maybe just give it a nice little brown color. There we go. So now with this layer active, I'm going to type in detail properly and add the detail. And then it just draws like a rectangle from corner to corner. And basically I'm just creating a window, right? I'm just creating a window that I can adjust and I can, you know, do whatever I want with it, with the, you know, drawing shown. To actually see the drawing inside, I can double click, position, zoom in, double click outside of the window, and I am now successfully zoomed in. What's the scale? Who knows? Select the detail, go to properties, and here you'll see millimeters on page 1, millimeters in model 136. That's not good. We want 1 to 100 scale for this, so 1 to 100. Now we know for a fact that the scale is correct. I can expand this a little bit. I mean, if you want to be precise, you could do -10. So that's 1 centimeter. 10, that's 1 centimeter. I'm snapping to the edges and then I'm just moving it back 1 centimeter. And this, if you're if you're printing it, it's going to be stapled on this edge, right? So that is going to be 20. And then with that information, I can double click. Don't scroll the scroll wheel because you're going to mess up the scale. Just move this until it kind of fits better. Double click, that's it. You're good to go. So that's our detail, right? That's well, it's not a deal, that's our drawing. So now to further mess with this or detail this further, I will go back to my perspective tab here, and I will, honestly, I don't care about seeing this drawing in the perspective view. I only care about seeing it in the layout, right? So I can already go to the layers here, and then for GFCP, I can just choose this light bulb right here. That turns it off in the model view, and then only shows it in the layout. With that being said, I kind of don't, for now, let's keep it, or else things will start getting confusing. So let's keep it turned on right here for now. Later we can mess around with this. If you just turn it off like that, then it turns off in both, just so that you know. Okay. Next up, sorry. Okay, so next up we look at the dynamic plan and we see what do we need to fix here. Again, the limitations were the biggest one being the doors, right? And me not being able to easily change up the doors or automatically change up the doors. So this layer will need to be closed or hidden. These doors will need to be hidden during the make 2D or dynamic make 2D phase, which is fine. Second one is the staircase. That's not how you represent a staircase. Third thing is the ceiling, right? The projected ceiling downwards. There is a way of how you can do projected ceiling if you just are in the, let's say, this perspective view. If you are in the perspective view and you go to the settings here, and for the projection, you can do parallel reflected projection, right? And then it shows you the backside, right? Parallel. So if you're in the top view, you can get a projected ceiling, but unfortunately there is no way to dynamically add it to the drawing, and there is no way to properly make 2D it, which is ew. really, really ew. It is what it is though, so we carry on. Let's, in the first floor, let's change our C-plane to the first floor, make a new C-plane, or we can just copy this one, honestly. Copy this one, make this C-plane not cut in the perspective view. So we don't care about the C-planes cutting because the drawings are still going to update. At least I think so. Let's actually investigate. I never bothered to check if turning off the clipping of the C-plane will change. No, it doesn't. Okay, so the C-planes don't, clipping planes don't need to cut. So now I just, let's go back to world top. I will just select this clipping plane and copy it up, high up, make it clip the perspective, move it down, M, enter, V, enter, oh, sorry, M, enter, V, enter, from this point down to the, it's snapping like crazy, but down to this level, and then just lift it up again by 900 mil. There we go. That's a new clipping plane that we can use. And this one, of course, the name of it needs to change. So it's 1FCP. I'll do one more. So this one, perspective, turn that one off. This one goes down. Enable the clipping. I'm not using the C-planes for this, simply because I'm kind of doing it opposite from what I usually do, so it's a little bit awkward. Come on, M, enter, V, enter from here. There we go. Okay, there it is. So it's since I'm doing it opposite, it's a little bit awkward to now use C-planes for the clipping planes. 900 up. I get a few of these going. That's great. That's all I need. Okay, so now let's generate the necessary drawings. I'll turn off. Oh yeah, and rename this. We can do -1F CP instead of basement. I think that's maybe a little bit more consistent. And then it's just clipping drawings. Select this one and this one, the basement and the first floor, because I already have the ground floor. -1, I can just place it here or here. And then regular first floor is placed here. There we go. So now I have my drawings in here. Then I just take my layout, the ground floor layout, right click on it, move or copy, create a copy, move to end. Now I have my layout, a copy of the ground floor layout, and I can just rename it to -1F, and then new layout, or sorry, not new layout, my bad. Make a copy, move to end, rename 1F. Okay, and now these are a little bit shuffled because I want the basement, ground floor, and first floor rather than ground floor, basement, first floor. So I need to move them around. So I'm just gonna right click on the basement, move, and then I'm gonna choose it to be before the ground floor. So I select ground floor, hit OK, and now it's basement, ground floor, first floor. Now all I need to do is double click, navigate to my basement, something like that. Double click, we're good to go. First floor, navigate to the first floor. Mostly fits. Double click, we're good to go. Okay, so that's kind of done. From here on out, everything else is mostly us drawing in 2D, us writing in 2D, and us manipulating stuff in 2D. Before I forget, of course, we need to hide the stairs, right? The stairs are these are not the stairs. We need to hide the doors. The doors are going to be replaced with a 2D representation of them, but that's kind of easy to do. And also, I just want to check the display thickness, print thickness, so I can use print display command. And state, I turn it on. And here, after I turned it on, I can see that that border that I had, the null print, is gone, and now all of the thicknesses are actually correct. So the thickness here for the section is too thin, right? It's literally a default thickness. So I need to go into the layers and I need to adjust the thicknesses for those particular objects. I can just simply go to drawing, curves, and then here under print width, instead of default, I choose 0.6. 0.6 is a little bit much. Let's do 0.5. That is a little bit too heavy. 0.4 should do the trick. There we go, 0.4. Then same thing for other two drawings. Oops, that's my bad. Wrong button. 0.4. So you just adjust the thickness. And ground floor 0.4. Okay. So all of those drawings are now currently have proper. They are properly adjusted. I want to check one thing, so I'm going to add these main three layers into the clipping planes layer to just see if it breaks anything when I go back to here and I just refresh all clipping sections, if this is going to mess things up for me. No, seems to be all okay. So these layers can live wherever you want them to live. Okay, back to cleaning this up. So the doors, right? I'll go to my walls tab, and here I'll find my doors sublayer or walls layer, doors sublayer, and I'll just turn them all off. And in doing so, after I refresh, this should be now clean. Well, clean meaning more work for me. Okay, so now in here I'll need to add in the doors. One thing that I also would like to note while we are kind of looking at the 2D drawings, the thicknesses here, the gaps between the wall and the heat insulation, like it looks really messed up, but that's actually how I want it to be, and that's because the outer boundary is so crooked. The building's outer boundary is so crooked. For the interior to be neat and precise, I used the heat insulation layer with the air gap as a means to even it out, right? To make it even. All right. So with that done, now all of the door openings are kind of waiting for me to actually draw inside of them, and we will do just that. So back in the top layer, so why do these not have any labels? Don't care. Doesn't matter. We could edit sections and apply this, but we really don't care about the layers. So back in here, if I go to the block manager, I'm going to create a block for the doors, and I'm just going to apply it to every opening here, and it won't be automatic, but it's not going to be that slow. At least I don't think it's going to be that slow. So under 2D, I'm going to go fast because the blocks, we already talked about blocks, so I'm going to try at least to be as fast as possible. My blocks live under proposal, right? I should create a new one under 2D blocks, like so. And inside of it, I'll create a sublayer called doors. And inside of it, I'm going to create two layers. One is going to be called board, and the other one is going to be swing. So one for the line, one for the arc. It's kind of nice to do it this way because then you have full control over, you know, the color, the thickness, and so on of these things. So you only need to set it up once and then you can just use it. Board thickness will be 0.5. Swing thickness will be 0.13. There we go. And then I just simply, wherever, I don't care where it's created, but I do need to create a board that is 1 meter thick or 1 meter long. So just a regular line, and then an arc. Swing. Wait, that's my bad. That goes 90 degrees. So it's just an arc in the door. And then the trick is that this is like 1 meter, right? This gap is 1 meter. I want to have a little bit of an offset between these. So I'm going to take this point and I'm just going to copy it by, let's go for 50 centimeters, right? 50 centimeters here, or 5 centimeters, sorry. Here, and that's minus 5 centimeters here, so 50 millimeters. And then as I move this, it will make sense. As I move over the door here and scale from this point to this point down to here and delete these points. Now I have my door as well as the anchoring points that I can actually, sorry, I shouldn't have deleted the last one. So these are the anchoring positions for the door, and this is the actual door itself that can become a block. And for that, I will make a new layer and call it points. These two. Change object layer. There we go. Now select the whole thing. Block. Base point is here. Name. Door 2D. 1 meter. Hit OK. Right? And make sure that it lives in the doors layer, that particular block. And from there on out, you can just take it. The way you operate with this, actually, let me delete it. The way you operate with this from the block definitions rollout is you take it, you drag and drop it in, click, or sorry, my bad. Drag and drop it in. Oh my God, drag and drop it in. There we go. And you click on the middle of any area, any opening, enter, select it, scale. From point to point, you scale it down like that, right? Then if you look at it in the, this is ground floor. Yes. When you look at here, there in the ground floor, we have the point, we have the door, we have the arc. The colors are changed here, right? So we change the colors for the print separately of the colors for the layer. Here, we just make them black and black. And the points should never be plotted out. So we choose this, what's the word, sorry, light bulb. We choose this light bulb to be turned on, or to be turned off. I'm gonna scream, why is this still showing up? What the hell? Hello? That's crazy. That's crazy that this is also not working. Who cares? Okay, anyway. I'm going to turn off the points later once all of the doors are properly placed. Let's go back in here, and from here on out, I just really quickly copy paste, right? Like that. Then get one in here, in here, in here. This feels like it should be a double swing, so we're gonna make it a double swing, and everything else is rotated. So I'm just gonna rotate this like that. That, and then missed one. So this one goes in here. Okay, now in terms of scaling, this is correct. This should be scaled into position. Scaled into position. Later we'll be able to read the the size of these blocks if we need to. I'll show you how to extract information from all of the blocks in the drawings, so that for scheduling purposes it's kind of nice. But for now we're just using the boring scale method, right? Seems fine. Of course, it's weird that some of these doors are going inwards into the rooms. They should be going outwards. So I'm just going to select all of those that are inside of this. This is going to be a problem, isn't it? Actually, this can go in and this goes there. Yeah, that one's fine. Prioritize the corridor, I guess. Whatever. I'm going to keep it the way it is. Oh yeah, and I wanted to have this half, right? So let's do that. Mirror it like that. Scale from here to here, down here. Okay. And then if I look at, I can at this point hide the points. If I look at it in the ground floor, that was weird. But if I look at it in the ground floor, everything is in order. Everything seems to be a-okay. Right? We have ourselves some double swing doors, some doors, and whatnot. All right, so that's adding in blocks. Of course, not the most elegant of the solutions, but it is what it is. If you want to add in, and let's minimize that, if you want to add in any additional information onto your drawings, then you do use, you usually add it in the layout. So text or measurements or whatever, you do that in the layer, and I will show you how to do that right now. So under 2D, I'm going to create a new layer, call it dimensions or measurements. You can use whatever you want. We'll change the color of it to be wonderful dark blue color. Print width thin 0.13, and that's kind of it. That's all we care about for now. And then having this dimensions layer set up, I can just use dimension or dim, and then if I measure from this point to this point, you can see that actually we're in layout, right? So this should be 297 by 420 millimeters because it's A3, but this is not. That's because the dimension understands the scale in which it's dimensioning, which is great. Unfortunately, the style, the vibe of it is a little bit rough, so we need to make some adjustments. If I type in dim, enter, or sorry, dim styles, is it styles? Edit. Oh my god, the way of how I do this is I select the dimension, I go to the properties, and here I see edit style, which I can then click. That's usually how I do it, or I can create a new style through here. If I click on edit style, this pops up, and that's exactly what I want. And here under annotation styles, I can actually make a new one. There seems to be also like 2 more styles that are added. That's usually not the case, but it's fine. The way I'm going to do this is I'm going to just create a new one. And let's go for millimeter architectural template. Hit OK. And let's just see how that looks like, right? We get ourselves a dash. We get ourselves a certain height in terms of the text height, right? And we don't get any numbers after the comma. That's exactly what we want, but I still want to show you how to adjust things. So for this template millimeter architectural style, I'll just go to edit style and I'll show you the main things, right? Model space scale, that's the scale in which you are working, 1 to 100. That's great. That's what we want. Font, Arial, that's fine. You could, if you want a thinner font, you can go for Calibri. Arial is okay. Height, this is in millimeters once the drawing is printed out. 3 millimeter height is fine. 2 millimeter height is still readable. Anything below 2 millimeters, you need a special font to be able to read it. 1 millimeter gap, that's absolutely fine. Besides that, we don't really care about anything here. Then, sorry, 1 second. You could also do a round off for the numbers. So let me show you. If you do a round off of 10, apply, then the 3 that we had here is gone because it basically rounds it off. So if you're, especially if you're working with old structures and you have like sub-centimeter errors here, so just so that they are not confusing, you can round it off to tenths, so down to a centimeter. But in my opinion, you should not. So let's keep it at round off of 0.0, sure, whatever. Like we don't round it off. But either way, that's our dimension styles. Thankfully, we have that as an option, just a template. So you can add in any kind of dimensions you want. Then in terms of dimensions and types of them, you have under drafting, you have either linear dimensions, which is only horizontal or vertical, where you can snap to it. Snapping to this is annoying, so we go to print display, state off, and now you can actually select what you snap to. And then linear dimensions, let's say from here to here, bam, we get ourselves a dimension. And then you don't really want to keep adding them. So I believe there's if you right click on this rather than left click, you get the option to have it continuous. So you can keep on slapping down the dimensions in a chain, right? You might be thinking, could I automate this? And the answer is kinda. You kinda can. I messed up that one. I care about this. There we go. You kinda can, but it's better to do it manually because then you have more control. And also notice how this is starting to get a little bit yucky. So we will need to adjust a few things here. Just give me a second. And the last one is going to be here. There we go. So everything here is kind of okay, except some of the more tricky dimensions. Also, always grab the full. Oops, was it my? Yeah, that was my bad. 1 second. New one, please. Always grab the full length dimension as well. From here to here. That is horizontal. There we go. So these areas where it's getting a little bit too messy, you have the possibility to just extract the, click on the number that is messed up. So for example, 570, right? You select the dimension, you somehow select the dimension, and you drag that dot in the middle of the dimension, and then you have yourself a number moved away from the dimension line so that it fits better. I think that's a better way to do it than the alternative of a leader. Leader is usually a little bit more messy when you need to do extracted leaders. So something like this should work. I still want to kind of distance. I just want to measure the distance between this and this. Is this really 3 millimeters? Yeah, that is 3 millimeters. Okay. Just to double check. Anyway, so we get ourselves all of the necessary dimensions. Then if you want to write text, usually I write that also in the dimensions layer. But if you want to be clean about it, you can make a text layer, right? Make it also blue so that you can see what was going on. Why is this? Oh yeah, that's because it's not print display. My bad. Yeah. So one more thing, one last thing, promise. Here, all of the doors changed to be red and green. That's because we're not in the print display anymore. Print display state was off. If I turn it on, they're back to normal. If I turn it off, they're red and green as in the model space. If you don't want that to happen, you can always change per layout settings here. So you can change this to black and change that to black. and then just be confused because this does not respond to it whatsoever. And it just doesn't turn off. I think, you know what's happening? I think I know what's happening. The thing that is happening is we're dealing with blocks, and because we're dealing with blocks, this was just not coded in, or I'm stupid. Hey, both are possible. Actually, both are possible to be simultaneous. So it can be a bug that, or a thing that is not coded in, and I'm stupid. Either way, moving on. Text-wise, double click on that. I can just write text, right? I can just call this hallway, whatever. Place it here. Easy as that, right? So working with this is becoming more and more straightforward and more of an AutoCAD type of a thing. Before I forget, the staircase is always going to be yucky, but the way of how you can make it a little bit less yucky is in the top view. If you at least draw the little arrow, oh sorry, not in the top view, what am I saying? In here, draw a little arrow, and for that I will just say helpers, or additional lines, arrows, whatever you want. I like to call them helpers. Also, I like to make them blue. Any kind of additional info that I add to the drawing, I make it blue, so that I can visually see better. And just make an arrow. Contemplating what kind of arrow I should do. I'll just do this one. Explode that. Mirror that. Like this. Join that. Circle in there. Trim that. There we go. Group the whole damn thing. Realize that we're in the text layer. Change object layer. Group. There we go. Control C, go to the next layout. Control V. Copy paste. The arrow is crooked. Or, yeah, the arrow is crooked. Ew. Why is the arrow crooked? Because the staircase is crooked, or what? Or is it me? No, it's just the way of how I draw. Awesome. Okay, we do this again. Gediminas, why are your tutorials so long? I don't know. Oh, that's because the midpoint here is, oh yeah, it's intersecting with the railing inwards, so that's why it was freaking out. Intersection snap, that will solve it. That does not solve it. It doesn't catch the intersection snap. Of course it won't. Why would it? That would be too easy. 45-degree snap here. Mirror. There we go. Okay. Whew. Oh yeah, and clean that one up as well. Group. Control C. Control V. Move to the midpoint, or from center point of the circle to the midpoint of the stair, like that. And then instead of scaling it, I do need to ungroup. That's the reason why I didn't make this into a block, by the way. It's because it's not just non-uniform scale, but it's a scale that I don't want the arrowhead to change. Group again. Okay, we have ourselves an arrow. Guess what we do here? There we go. And so on. So there's going to be quite a lot of this kind of information that is just added in group. And of course, I will not be showing every single thing that I do to you, because it's going to be a long video and it's going to be a boring video if I do. Of course, if I do so, instead I'm just showing you the one of each, right? At the end of this chapter, I will show the finished drawings, how they look like, and explain what I've added in. But for now, you know, this is all we do. Okay. Give me a second, just thinking. I mean, okay, one of the more interesting, I guess, or more important things in this case is the landscape and the fact that it's dipping down, and that all of this is terraced. And I kind of want to incorporate it, and it should be incorporated in the site plan rather than the floor plans. But in this particular instance, I'm just going to add it to the floor plans so that we can basically call it a day. So I select the landscape here, and then in 2D, I'm just going to, under 2D, one second, please hold, please hold. I am just going to create a new layer, call it contours. Contours, there we go. Double click on that, and then with this layer selected, I'm just going to contour the whole landscape vertically. So from, let's say, it doesn't matter, from this point. Actually, it kind of does. You want to contour it from the original contours, but in this case, it doesn't matter. I'm going to contour it up, and then it asks me what's the step size, and I can either choose 250 mil or 500 mil. I'll choose 250, so that it's a little bit denser. There we go. We get all of our contours in here, and I'm just going to also make a point here in the corner so that I know where to place it, right? On every drawing. I move it up, select all of these, scale them down to 0, unselect the point, group all of the contours, and then just simply move M, enter from point to, let's go for ground floor. Bam, right here. We have ourselves the contours, and realize that the bridge should be intersecting them, which is fine. I will just be able to trim them away later. So that's one, then copy from here to here, and then to here. Cleaning them up is not going to be a big deal. As I said, I simply can just do this quick little zigzag here. Should do this in the top view. Should definitely do this in the top view. There we go. So that's cleaned on this side, and there's a lot of crap going on here. I can actually ungroup this and delete some of them, because these are getting in the way. This is all fine. And then here, if I mean, technically I could unlock the drawings and then use them to trim away, but I don't really want to do that. So I'm just going to, because then you need to dig around in the layers tab. So I'm just quickly going to draw lines with which I trim in any place where I want to trim. There we go. That seems clean to me. Let's check. Yeah, I can see one area, two areas. Okay, area number 1 is here, clearly. Bam. Also, we can just make the contours like pink or whatever so that we can see better. There we go. And then another one is here, the border right there. That's clean. There we go. Contours. Ew. I should just borrow the contours that I just cleaned up. I shouldn't I? Whatever. Let's do that. Let's do that. Go here, do that. Okay. For those of you who thought, oh no, he didn't show us how he 3D modeled, imagine this, but for 12 hours. Well, more, 20, 28, something like that, hours. No fun. No fun at all. Is that what you want? Okay. That's kind of good enough. I think if I look at it in the ground floor, the contours are pink. I don't want them to be pink, so I change them to be actually dark gray. Change that to be dark gray. Now I'm properly confused. I think just print display, that's just needed for this to show up properly, right? And then the print width is 0.13. Contour should be thin. Just give you more information about the slope, about the slope. All right, don't need the hallway. I'll add stuff later manually. So with that shown, I guess this is it in terms of drawing creation, drawing extraction. Last bit is the section. Let's just do one section and then I'm going to actually create the drawings. So again, I'm not really doing anything that fancy. I'm just going into adding one more clipping plane, enabling it or changing its name to section AA. Cut in perspective. There it goes. And then just finding a cut that would make sense to do. Kind of don't really want to cut through the staircase. So something like this probably will be fine. So that's going to be our section AA, and then clearly this should be moved away. Let's go to the front and then clipping drawings selected. Let's place it. Actually, I can already see that it should be rotated, but before we do so, let's just place it, wait for it to generate. There it is, clearly, not rotated properly. So edit, clipping drawings, select the correct section, edit it, angle 90 degrees. Okay, minus 90. There it is. We have ourselves a section. If I zoom in, everything seems to be kind of okay. There are issues here and there, and the issues are mostly from the cylindrical shape that we're slightly touching here. So I will be pushing back the clipping plane just a tiny bit so that it's not in the way. Everything else seems to be okay-ish. I have questions on that. Let's take a look at what the hell is going on here. Seems to be just a mistake. Okay, it is what it is. So the only real issue, yeah, we agree. The only real issue that I see is the beam that is running through here, the old beam. We're starting to cut into it through here. I want to cut through it the whole way. So I'm just going to position the clipping plane as it is here. And I'm just going to move it by, let's go for 20 centimeters, so 200 millimeters. Yeah, that seems to be much better. And that seems to be clipping through most of the stuff that I want to clip in this with this section. Move it back in. Okay, top view. There we go. That's the stuff that I want to see in the section, right? I don't know what's up with these drawings though. It used to be much cleaner. They must have updated something. Either way, now we can create a new layer. A new layout, and I'm creating a completely new layout because this one is going to be horizontal. and I'm gonna call it section AA. And for this, yeah, sure, no details, that's fine. Go to layers. Where is it? Yeah, section AA has been created. I'm just gonna bring it to the clipping planes as a sublayer in the clipping planes layer. Then here, in the under 2D layer, I'm gonna find my no print. Wait, shouldn't it be in the, shouldn't no print be there? Oh yeah, that's under layout data, my bad. No print, I make that active. Detail, add rectangle. Select rectangle, 20 centimeters here, or 20 millimeters, minus 10, minus 10, 10. Double click, zoom in, double click, select the edge even though it's invisible because of the print display being turned on, and use 1 to 100 scale. There we go. Okay, so this is a little bit annoying because of the bridge, for example. We don't really care about the bridge, we only care about the drawing here, and there's too much stuff going on there in the background. So what I'm going to do is actually, in the perspective, I'm going to select this section, and I'm going to say that it should have a custom depth associated with it, and the custom depth should go, let's say 3000 millimeters. Let's investigate. That did not update at all. Yikes. Okay, let's see. Under sections, if I update the clipping drawing, I'm looking if this is going to, yep, that updates. Okay, that's good. So 3000 millimeters is clearly too little, but if I do 10,000 millimeters, then it grabs the whole building, right? Well, almost. It's still trimming into it. So let's do 11, 1 more meter to it. There we go. It grabs the whole building, but it doesn't grab stuff in the back, which I think is, in this case, is going to be a little bit better for the cleanliness of the drawing. We'll see. If it's not, then it's just... Huh? Sorry, what? I'm gonna cry if this keeps going. Okay, 10 centimeters, force a recalculation. Or 10 millimeters. Okay. After forcing a recalculation, just moving the clipping plane by 1 centimeter seems like everything's fine. We still get a mysterious edge here, which it is what it is. But other than that, seems to be okay. Okay, so we have ourselves a little bit of a clipping plane situation going on. I mean, clearly you can see that this is not the most stable of the methods of how to work, but it is much better than just having a static model from which you always need to make 2D out the drawings every time you make an adjustment. It's better when it makes 2D it for you automatically. Yeah, that's just my thought process on it. Right, so now let me turn this one off. There we go. And now the task for me is going to be to clean everything up and to document all of the different things of what I have done to show you, because I'm sure that I have forgot one thing or two or 50. So give me a few hours and for you it's going to be just like that. All right, there we go. A few hours later, the drawings are complete to pre-proposal phase or proposal phase standards. So clearly what I'm going to show you is not going to be for the development phase. This is very important to note. The design development phase requires you, at least in my opinion, requires you to draw on top of the dynamic drawings so that you have full control over every single line and full precision over every single line. But for proposal phase drawings, this should be sufficient. With that being said, let's dig into what has been done. So first thing is that I forgot to note is the sections or the clipping planes and the different types of clipping planes. Here we have a regular clipping plane that I used for the floor plans, right, to extract the floor plans from. And basically this is infinite, and the only way of how you can control what is being cut with this particular clipping plane is if you go to its settings or properties. Then here you have objects that are clipped option, and you can choose to include or exclude selected, right? So you can choose to only include the building, right, to be clipped. If you don't want to deal with that, if you don't want to keep it kind of automatic, then you can use, instead of clipping plane, you can use section drawing. Let's go to sections. I keep forgetting. Clipping section. Clipping, not clipping plane, but clipping section. Too many very similar words that I get constantly confused. And then when you choose clipping sections, clipping section creation, it asks you to select objects that you actually want to clip through. So you can actually include, exclude, and so on, things that you don't want to be incorporated in the section making. And once you've done that, then you can place the section by choosing direction, X, Y, custom, or according to the current C-plane. I'll just go for Y direction. And then all of these different settings that I already covered when talking about the clipping planes. There's nothing fancy about these. Once I place the section, you can see that it only clips the objects that I have selected, right? So that's quite beneficial, I think. So those the two sections, that's how I managed to make the sections a little bit cleaner, because I'm not clipping through unimportant stuff. Besides that, if we look at the plans, this is still us not in the view, in the layout. This is us in the model view. Let me select all of this and make a copy. This is everything that was added on top of the existing 2D dynamic drawing, right? So already talked about the ISO curves. That's very static, very much, you know, same stuff. But here I have added in some bookshelves. So all the furniture that you add it in the model view rather than the layout view, as well as the doors and so on. And most of the furniture here is blocked. And this brings me to operating with blocks in 2D. I think this is quite a... those of you who work in AutoCAD will relate. As long as you have a library, it's very easy to drag and drop in different blocks. And I'll show you how. So let me just quickly create a new Rhino file. And as this is loading, I'm just going to show you. Here I have my blocks.3dm file. This is like a short, small library of blocks that I mostly use in the projects. And those, again, Patreon supporters, YouTube members, you get that file together with everything else that I'm doing for this course, as long as you support the channel. But these are nothing special, right? And if I were to show you this particular Rhino file, let me just open it up. For now, I'm just going to open it up. You will see that in the Control A, no objects added to selection. This is a completely empty file. The only reason why it has layers, and if I try to, well, if I purge, actually it's going to delete the blocks. The reason why it has layers is because blocks exist here, right? And these blocks are actually they basically are baked into the file. So if I drag and drop in the dining table with 6 plus 2 pieces, then this block automatically gets placed in the thin lines, or all of these lines get placed in the thin lines layer, like that, right? So initially this file is completely empty, which brings us to, if I create a new file, no template, it doesn't matter, I can just take this blocks file here, drag and drop it in, insert file, or is it import? No, it should be import, my bad, sorry. Import file, hit OK. And now all of those blocks have been read. And now if I'm working with toilets, VC, I can add in a bathtub, for example, very, very easily. Unfortunately, as I said before, the blocks, you cannot really manipulate them, right? You can scale them, but they're non-dynamic, meaning that you can't change the proportion of this. You can only scale them in one or two directions, right? So you can change the proportion of the toilet like so, but you can't really easily just increase the length of it in a nice way. But I think for what we're doing here, that is absolutely fine, because all we need to do is just place the indications of different furniture in different places. So that's exactly what I've done here in this file. I placed in my blocks, right? I merged in my blocks, and now I have my shower, my bathroom, my bed blocks, and so on. Again, all of those are available. If you have the course files, those are available to you. Besides that, besides the blocks, nothing else has been added in. Nothing else has been added in the model view. But if we look at let's go for this. If we look at the layout view, if I select all of this, make a copy of it, then you'll see how much stuff has been added on the layout. And most of the stuff that I add in the layout is additional graphics, like helper lines, numbering of the floors, or not the floors, sorry, the spaces, axis lines, dimensions, and so on. Speaking of dimensions, just to make sure that I get this point across, dimensions lock and inherit the scale of the objects onto which they are anchored. What I mean by that is, if I type in dim, if I try to create a dimension in the layout, and I try to create a dimension between two objects that were made in the layout, axis A, axis B, it tells me it's 29 millimeters. Not great. If I then anchor it to the corner of this heat insulation block, and I anchor it to the midpoint of this column and drag it down, it tells me 2.9 meters, or 2,911 millimeters. So both of these dimensions are basically, showing the same thing, but this one is showing the gap between the two layout lines, and this shows the gap between the two model lines. So it really matters where you anchor it, right? Hopefully that makes sense. If I do print display, state off, turn it to on, this becomes a little bit more clean. It's still a little bit hard to read in certain cases. If I were to spend more time on this, I would probably start hatching in the ground and so on, which brings me to, I'll just show you here. If I were to just make a circle, this is just going to be as an example, and hatch it, okay, select the hatch and send to back. Doesn't matter how much I'm trying to send this to back, this hatch is never going to be below the contour lines, because the contour lines are in the model space, right? And the circle is in the layout space, so it's always slapped on top. The only way of how I can get a hatch that is below the line work is to actually work with it in the model space, right? And here, if I make a hatch, right, and send to back, now it's in the back, and then if I check it in the ground floor, you can see the line work going on here. Important distinction, important thing to note. So any kind of hatching, additional hatching that I would do, I would be doing it in my 3D, in my model space. Right. Besides that, axis lines as well as dashed lines, for example here, maybe better to do print display state off, like that. These lines right here, these are dashed. The red layer is dashed lines. Well, not the doors, of course. For these to be dashed, I actually need to mess around with the line type, and that's what I want to show you. So if I go to the layers and I find my dashed layer, here the line type is set to continuous. That's fine. I click on it, and here I can see that there's a bunch of line types that have been inherited from the different imports that I've done throughout this course. I don't really care about these as much. I want to create my own line type, right? So what I can do is I can type in line types in my command line, and I click on the new one, create new one, call it dashed, and then basically here I need to specify the segments. Before I do, I kind of want to see my dashed line type, so it's right here, and the segments are written down in millimeters. So when it's printed out, you know, how wide will the segments be? So for example, if I do 2,2, you can see that this is 2 millimeters, 2 millimeter gap, 2 millimeters, 2 millimeter gap. If I do 3,1, it's a much more kind of generous line length. So 3 times longer line than the gap. I think if we do 2,1 or 2,2 actually, that 2,1.5. You can mess around with this for a long time, but it's better to first do whatever, you know, and then once you like how it looks like, then you once you apply it to the lines, then you can really lock in to look the way of how you want it. So for now, this just seems okay, and then I will just simply apply it to the layer. Dashed, I click on the line type continuous, I scroll down, I just choose dashed, hit OK, and this is how it's going to look like. Notice this model space scale, this object right here. So if I change this to 50, strange that these don't adjust. They should adjust. That's crazy that they don't. 1 second, please hold. 100. Okay, let's try this. Units, type in units, go to line types here. This, no, here it's fine. Hatch, enable hatch scaling, that's fine. Honestly, enable model space scaling, enable layout scaling. It's strange that, oh wait, apologies, sorry. Model space scale, it only applies to the model space. I don't know where my mind went. So here it's always going to be 2 millimeters, 1.5 millimeter gap. But here in the top, if I start drawing this line, now it looks normal, right? It basically is the same between the layout version and the model space version. But if I go to line types and I adjust the dashed line, or not the dashed line, but the model space scale to be 50, you'll see that this is going to be 2 times more dense, right? So you need to know at what scale will you be plotting out your documents, your drawings, to really kind of nail down the same line type between the model space and layout space. Hopefully that made at least some sense. Then for the axis, I also want to change it up so that it's not a straight line. And for the axis, I'm just going to layout. No, not layout. Line type. Line types. Create a new one. Axis. Oops. It should be here. Axis. And here I can just write. I would guess like 3, 1, 0, 1. Notice the 0 in there? The 0 is a dot, right? It just places a dot. If I now apply this to my axis lines, this is how it looks like, right? Dash, dot, 3mm dash, 1mm gap, dot, 1mm gap, 3mm dash. So dash dotted. I think this should be longer. So 4, 1, 0, 1. And that's all we need. There's, of course, a bunch of other crap that you can do, but this is completely unnecessary. I don't want to even get into it. This is like stylized crap that I think like 1% of the people actually use, and a lot of development energy goes into it, but I'm not here to complain. So with that being done, we have ourselves the correct line types. We have the correct line thicknesses. I already applied. Oh, I lied. Now it's correct line thicknesses. Those are already applied. The text line thickness doesn't matter as long as you're using like a specific font. For instance, Arial. If you're using TXT font, I believe it matters. But whatever. Print display, state, on. That's how they look like, right? And at this stage, I would say that the drawings are good enough to be shown to clients to get an approval for, to start going towards the next development stage, which would be the design development, right? The more detailed development. And as I said before, I really want to emphasize this. For the next development stage, you would be drawing by hand on top of the dynamic plans, making sure that none of this crap is happening, right? That everything is super clean, super nice, no overlaps between hatches, especially in sections, right? Let me find something that is messy. Let's try in here. No crap like this. No crap like this, right? So all of this should be solved. But for proposal phase, this is sufficient, I think. I would be adding in probably a hatch here. I will be adding a hatch here for the next step, actually. But that's, as I said before, that's going to be done in model layer. For now, this is complete. I'll add in some altitude measurements here as well. But besides that, this is complete. And then we can move on to the next step. The next step is going to be scheduling. So I'm not going to do full scheduling here because there's just too much Grasshopper crap going on. If I won't do full automation of the scheduling here, there would be too much Grasshopper crap going on, and I don't expect you to use Grasshopper too much for this course, but we will do a little bit of it. Also, I'll show you the roof slope calculation, like different ways of how you can calculate the roof slopes, especially if you're doing like weird stuff, and how you can actually get graphics out of it. I already have a tutorial on it. I'm going to show you the link of it. And besides that, it's going to be mostly just optimization. Afterwards is going to be a really interesting chapter where we're going to talk about how do you share your drawings, your models, and so on with contractors, clients, to get a quote from the contractors and whatnot, right? So that is going to be chapter afterwards. Keep an eye out for that. And with that being said, let's I guess move on to the next chapter, scheduling. Chapter 7, scheduling. So anything that you do in Rhino that you want to be automated, such as scheduling, is going to be done in Grasshopper, because that's the platform to do so. In this chapter, I'm going to show you two different types of scheduling at a very basic level. One is going to be getting your blocks of a certain type listed. For that, I'm going to use the skylights, properly listed in the layout. And the second type is going to be automatically getting a list of all of the different spaces in your building. So grabbing that kind of information and then just having it automatically update as you update your project, semi-automatically. Third thing that I'm going to show you is a set of tutorials that I have already recorded that were recorded previously on this channel. I'm going to just kind of reference you to them of different things that you might find useful when creating architectural diagrams and architectural information. So, such as, for example, the roof slope analysis. I'm going to show you that. So I guess we can begin with the getting the scheduling of our skylights, in the building right here. These guys right here. In total, I have 8 of the skylights, and they all share the same block. And in this case, the block is not scaled. It does have the same size in all 8 instances, but in this case, the rotations are different, right? They're rotated off of the XY axis. If I look at the skylight block as it is right now, and I just place it, you can see that it's being created horizontal, right? With all of the information that, that contains. For us, for a 2D drawing that we want to extract from here, this is not sufficient because this is a 3-dimensional model. What I want from this is just to get 2D outlines of the frame, which also will include the glazing, and also to get a dashed line that shows the swing angle, right? So basically where the hinges are. And to do so, all I need to do is just find the correct layer in which I'm going to draw. For this, I'm going to use blocks thin line layer, blocks furniture thin line layer. And here I'm just gonna, let's move to shaded view. I'm going to find the anchoring point. So this is the 0, 0, 0 coordinate of this block. And all I need to do is just on this block, draw out a rectangle at its, so that the rectangle basically sits on the 0, 0, 0 altitude, right? So right here. That's going to be the outer frame. Then I just take that rectangle, I offset it inwards by 50 millimeters. Let me hide the block just for a little bit so that you can see better. Like that. And I have myself, a 2D representation of the block. And last thing is I'm going to choose a dashed line as my active layer. And I'm just going to say that this block actually is capable of opening on this hinge upwards, right? So it's basically, the hinge is where these 2 points are, and the motion or edge of motion is where the pointy bit of this triangle is, if that makes sense, right? So it flips open while this edge is static and this one opens up. All right, so that's our skylight. And now if I just show selected, show my block, I want to add in those curves into the block. And if I remember correctly, it's like block add, 1 second. Add objects to block. Yes, that's the one. Add objects to block. So select the block instance. It's going to be this one. Object to add to block. That's going to be all of my curves. I select those. Hit enter. That's it. Now if I look at my skylights here and I select any one of them, just from the dashed line you can already see that the curves have been added in, meaning that now in Grasshopper I can quite easily extract only the 2D representation of this block. Okay, that's step 1 complete. I don't need it anymore. I deleted the original block here. Step 2 is to install a plugin for Grasshopper. The plugin that we're going to use is called Elephant, and the reason why we're using Elephant is Elephant. The reason why we're going to use that plugin is because the natively Rhino's management of blocks in Grasshopper is garbage, right? So we're gonna use Elephant for that. If I type in package manager, enter, and I just search for front, one word. It's like elephant and front. Here I can choose the not the legacy one, but the regular one, 5.1.9. It's a little bit unstable in certain cases, but that's fine. We'll make do. And you just choose to install it. Then it's going to ask you to restart Rhino. Please do so. If you don't restart Rhino, after you install Elephant, it will not be loaded in and you won't be able to follow along. Speaking of which, The script is already done, already made. Of course, we're going to make it right now, but those of you who are supporting the channel on Patreon or YouTube through YouTube memberships already have the Grasshopper file that is called scheduling.gh. So you can just simply have this opened. Okay. Let's do that. Grasshopper. And those of you who are supporting, just drag and drop in your scheduling.gh file, so that you can follow along a little bit easier. Those of you who are not, then just follow along. We're going to create that particular script right now. So, step one. Step one is to actually reference in that particular block, the skylight block, because that's the block that I want to schedule. I double click on the any empty space in my Grasshopper file, and I type in // and then I need to specify the name of the block. Apologies, 1 second, just double checking. Yep, you can see here the name of the block is called skylight, one word. So double click / skylight, capital S. Alternatively, you can just type in panel, hit enter, and then double click on it, type in skylight, and click outside. That works as well. Okay, so with that done, we have the name of the block. It's time to reference it. Different ways of how you can do it. Let's use Elephant for that. So in Elephant, under blocks, I believe, or sorry, under reference, isn't it? Under reference, there's the first item, reference block by name. We use that, and we just connect our skylight to the block name input. Click on update, it updates. We now have referenced all of the existing blocks that have the name skylight in our scene. If I hover my mouse over here, I can see that there's 8 of them that are being referenced. If I just take my skylight and place it here, update, now it's 9, right? So it's updating at any time I click this update button. Great. Now I want to explode the block, or rather get the info of the block. Get block info. Bam. Do that. Actually, 1 second, because the bifocals. You don't need to do this, but this is just so that you see better. And for that, I can also draw full names. I will turn that. Should I turn it off? No, I should keep it, shouldn't I? It's a little bit more informative if I keep it, so I'm going to keep it. Okay, we have our block info, and basically what I want right now is I want all of these guys to be called Skylight 1, Skylight 2, Skylight 3, Skylight 4, and so on, right? To basically have that information displayed on top of my blocks right here. Also, these guys are a little bit in the way, so just 1 second, please hold. Under clipping planes, I'm just going to hide, or that's a little bit annoying. Just select those and hide them, okay, so that they're not so much in the way. All right, back to here. So here I want text tags, basically saying which block is which. To do so, I basically just need to count them, 1, 2, 3, 4, 5, and so on, or 0, 1, 2, 3, 4, 5. And the fastest way to do it is to use item index, basically getting the index of the item for their names. So now what I'm getting is I'm getting two. So type in item index and just connect name to both list as well as item. So now I have two lists, one saying skylight for every one of them, and the other one giving me 0, 1, 2, 3, 4, 5, like counting them. Then I can merge them, use merge. So I can first merge the name skylight and then merge in the number 0, 1, 2, 3, right? So to get skylight 0, skylight 1, skylight 2, skylight 3, and yada yada, right? I can do that. And to merge them independently, because right now the way of how this is going to work, I can already tell. It's going to be just first it takes skylights and then it takes the numbers. No, I want first skylight to be with the first number, second skylight with the second number. The way you do it is you right click on the D1 input, you choose graphed. You right click on the D2 input, you choose graphed. Don't worry about grafting. If you want to learn more about data tree management, full Grasshopper tutorial course, basic course, video description below, check it out. 12 hours of fun. So with that done, now I can actually join up those two text together. So I'll use join text or text join, sorry, connect that. And the joining symbol should be underscore, I think. So // underscore to be used as a joining symbol. And you can see that now basically those two lines are joined into one with skylight underscore 0. Great. Let's display it. I want to display it. So what I'm gonna do, what's the best way? Let's take a look here. Annotations, Elefront again, annotations. Let's do text dot. Text dot. Text to display is going to be our joined up text. Don't forget that this is still not a single list. We want it to be a list. So I'm going to right click the result output, choose flatten, like that. So now it's made into a list, and then I'll just connect plain to the location input like so. And voila, we have ourselves skylights being shown on the root of every skylight, right? There we go, and their names. So I know that this is skylight 0, this is skylight 3, for example. Great. Now since we have that information, we can use it wherever we want. Wonderful. Next up, I want to actually lay them, take out of these blocks, I want to take out only the curves, right? Remember, we drew the curves. So I want to take that and I want to lay them flat on a grid somewhere. And we'll figure out where in just a second. So first of all, taking out the curves. The way you do it is quite simple. The block instances that we have extracted, we explode block. I don't remember. I think it's this one. The one with a flaming box and a cone, explode block. Bam. Connect block instances to the block input, and we get our geometries out this way. The problem is that if I look at the geometries that we're getting, there we go. It's closed brep. Okay, so it's a bunch of polysurfaces and 3 curves. I only care about curves. If I just do curve component like so, it freaks out, right? It breaks. So I can't do that. Instead, I will filter by type. Filter by type. Geometry connects to geometry, object type, / curve with capital C. Connect that as my object type, and now I can see excluded geometry and included geometry. The data tree is a little bit dirty, so let's right click and choose simplify on the included geometry so that this symbol is applied, active, visible, you name it. Okay, so let me somehow show it to you. Let's just do a curve component and select that. And as I select it, it's very, very yucky. Let's go for wireframe, I guess. Wireframe is a little bit better, but still hard to see. Let's hide as many as possible of the objects. Yeah, now we can see the curves that are being referenced. Great, we will move these. Still hard to see, I know, but yeah, there we go. These guys. We will move these. Rotate them and place them flat. How to do that? Well, first of all, we need to tell Rhino where we're going to be placing them. I want to create a grid. I want to create a grid in the top view, grid of planes. On each of the planes, each individual skylight will be placed. And to do so, I need to define an origin point. Easiest way, create a point, place it. Make sure that your layer in which you have created the point is like not a weird layer. So let's let's go for scheduling, text scheduling, right click, change object layer, there we go, it's right here. Now I'm going to reference in that point, right click, set one point, boop, there we go, enter this component, and I'm going to define a plane around it, xy plane, like that. If I zoom in, you can see there's our little plane. Great. I can make the plane bigger so that you can see better. Let's go for display, preview plane size. That's 20 millimeters. Let's do 200 millimeters so that you can actually see it. Voila. Okay, that plane needs to be arrayed. We will array that plane by using array rectangular array. Geometry that we array is plane. Cell needs to be a rectangle, so we're gonna make one rectangle, the one with the orange icon with the rectangle around it. So we connect the rectangle as our cell. Then for the x size and y size, it's basically our step size between the different skylights as they will be laid out in a grid. So I'm gonna say in between them, I'm gonna have like 1050 millimeters in the X direction, and I will have 1500 millimeters in the Y direction. Something like that. I don't know. I'll be able to adjust this later. Then X count, Y count. I will say 4 elements in a row. And then let's go for like 5 rows, right? So 20 elements in total. Clearly, amount of elements here, 20 planes like that, is more than amount of skylights that I have. So I need to do like a quick check to and trim away this list down to what I actually need, which is going to be 8 skylights, but it might be 9, might be 10, So keep it parametric. I'm going to list length. I'm going to measure the length of the list with this. Right, so I get 8, and I'm going to use split list. Split list, so the geometry output is being split at index 8, and the list output is then these 8 planes here. I can show you plane. Boop. These first 8 planes are split off. So that means that we currently will always have the exact amount of planes as we have the block instances of that particular type. Okay, that works. Let's hide a bunch of things, like everything here, and just keep the plane. Then it's time to actually move these curves that we extracted from each block. We need to move them onto the plane. How do we do that? Well, we will use orient tool, orient. Geometry to orient are the curves. That's easy. Source plane is going to be the planes that we have here for each block. Not so easy because these need to be grafted. Again, grafting means I just place every individual plane into its own data branch. If you want to learn more about data branches, link in the video description below, the Grasshopper 12-hour course. Have fun. Okay, that's the source. Like that, and the target is going to be our 8 planes that we have made here. I need to graft them, so I'm going to use graft for this as well. Bam, that's our target. Voila, all of our elements are placed. Let me just make a little bit more room between them so we can see better. There they are, right? They are here. I don't want them to be horizontal. I want them to be vertical. Horizontal is weird. So I'm going to just simply rotate the plane right here, right? I'm going to take the plane and I'm going to rotate plane. Rotate plane. Plane connects here, angle, right click on the angle input and choose degrees and then just / I think it's -90. Let's do a slider, -90 ... 90. Like that. Connect a slider, and now the new plane gets replaced by the old plane gets replaced by the new plane. So I'm just connect that to the geometry. Now, as I mess around with the slider, I can see, yeah, it should have been -90. Great. Adjust the spacing so that it's a little bit better. There we go. And we are kind of done-ish. right? So at the most basic level, you now are able to schedule your skylights. Example, if I add one more skylight wherever I want in the document, like that, and I press update, it pops up here. If I then mess around with that skylight, make it wide or whatever, shouldn't have made it that wide, that's weird, abort mission, whatever. Update that, one of the skylights is adjusted and it's wide now. So that works. Okay, it's all dynamic. We need to give it names and we need to give it proper dimensions. I need to do it this, and then I'm gonna say that foundationally, we're ready to go. So step one is understanding the dimensions of these guys, and the best way to do it is for the geometry that we get a bounding box or bounding rectangle. Now let's do bounding box, whatever, like that. It's not per object, it's actually we right click on the bounding box little icon here and we choose union box, so that it just draws around each skylight. Then we take the box, they're perfectly flat, means it's a surface actually, it's not a box, and we do surface dimensions. Yeah, it's just dimensions. We use dimensions, connect the box into the surface input, we get our U and V dimensions, which are, by the way, in millimeters. So 600 by like a weird number, whatever, don't care. And I'm going to just integer them. Integer, that and that. Bam, that's great. And then I'm just going to use text join to join them up. Text join. First comes X, then comes Y, like that. And the join is going to be //X. What this makes is // if I look at the panel, 600x1590. So let me explain. In U direction, 600 comes in V direction or Y direction, 1590 point comes in. That gets removed by us running this through an integer, so it removes any digits after the comma, like that. And both of these, like 600 gets paired with 1590 and gets joined with X being the joining symbol. That's all we do. Okay, so after text join, we get ourselves like a dimension that I will want to add in. Great, we have our first thing. The full format that I want is going to be, let me write it down for you. How are we doing this with the skylights? 1 second. Skylight underscore, okay. So skylight underscore 0. Should it be a space bar? No, it should be like spacebar dash spacebar dim 600x 1590. Yeah, I think that's the good format. So skylight underscore 0 dash dimension 600 by 1590. That's the format that I want. I have my skylight 0 right here. That's the text join from here. I do want them to be separated into separate branches for ease of management. So I'm going to graft the tree like that and just drag it over somewhere closer to my text join of the dimension so that, we want to keep it tidy. And let's just join them up while using text join. Let's merge. Use merge for cleaner approach to just check if like these merge properly. // do they please join? No, okay, they don't. You can see that the addresses don't match up. To force addresses to match up, you sometimes, as long as you don't have wacky data trees, you can right click on D1, simplify, right click on D2, simplify, bam, they match up now. Then we use text join. Let's see the output. We're very close, right? Skylight underscore 0, and then it's just our joining symbol, right? We want spacebar dash spacebar dim spacebar. Click join. Look at it. Don't need the last spacebar, so we can just delete that one. Yeah, that the format looks good. Maybe dim like that. Yeah, I think, yeah, this kind of formatting looks fine. We're gonna be using this. And now I just want this to be displayed underneath each of the skylights. Also, let's hide some things. They're a little bit in the way. There we go. So to display these, I will first should get the planes, right? 1 second, thinking. So those planes that I have, where are they? After the array, or sorry, after the split, these guys. These planes that I have, if I display them, those are the new origin points for each skylight. So I will just move them down a little bit for the text, and I'm going to use them as the location for the text to be displayed. So I'm going to deconstruct plane, bam, like that. I get my origin. I'm going to, on the origin, I'm going to place a new XY plane, like that. That is going to be moved downwards, and downwards in 2D world is Y negative. So double click Y, unit Y, like that. Then negative. And then a slider, or do we do a slider? We can just do a regular 50 millimeters. That should be enough. 50 mil, that's our value. And basically now I just have a plane that is moved down. Let me hide unnecessary bits. A bunch of planes that are moved down by 50 millimeters from the skylights, right? I think this will work. This should work, if I remember correctly. Then we will use, instead of using text dot, because it's an annoying format visually, we will use a text object, define text object. It's under Elefront annotations. Define text object. Text to define is going to be, these bad boys that we have just made in the top. So I just connect that to the text. And the plane on which it should rest will be here. These ones right here. Bam. Ugh. Okay, and we definitely need a proper dimension style. So dimension style is annotation style. So let's go for, let's just type in options and find it. Options, annotation styles. Oh, I already have one called scheduling. Do we use it or do I make my own? Let me just check what's different in it. Oops, 1 second. Edit. No, nothing's fancy. The only difference is the model space scale is set to 20. Okay, so I can kind of show you, I guess, how to do it. Template millimeter architectural, we already have it, so I'm just going to create a new one. And I'm just going to call it, 1 second. Template millimeter architectural, that's going to be our base. And I'm just going to name it scheduling tutorial. Okay, scheduling tutorial. Select it, edit, and here instead of model space scale 100, I'm going to use 20 for this one. I think that's going to be it. Let's take a look. Dimension style / scheduling _ tutorial. So we reference that annotation style that we have made. Voila, it's there. Okay, now I remember I also need this to be centered. So let's go back to options. And for scheduling tutorial here under text alignment, centered, apply, take a look at it, looks good. You can change here if you want the font and then so on, but I'm keeping it as default as possible. This seems good. We're happy. Hide the planes. We have ourselves the fonts. Okay, time to learn how to auto bake these, how to bake these out, and generally speaking, how to reference them. You can see that I already have a layout called schedule kind of created. It was created by just copying section BB layout, nothing special about it. So what I do is I just zoom in to these text lines, whatever layouts to these windows. I select the edge here, and I'll just make sure that it's set to a scale of 1 to 20 because that's the scale at which I defined my annotation, so that if I do that, basically my text size here and my text size in the model space, they align, right? Okay, with that done, for the text, let me flatten it so that it's one big happy list. And I'm going to make sure that when I bake it, it bakes into a specific layer. So first step is tool under bake. It's called bake objects, this one. Geometry to bake. That's going to be our text. Attributes to bake. Attributes are a little bit harder, but if I go to attributes tab here, there's elephant attributes. Bam, this massive thing here. Don't worry, we only care about one of them. It's called layer. / we describe which layer it should be baked in. The formatting is quite simple. Step 1 is to find the layer. I'm going to be baking this into the scheduling layer right here. So it's under 2D text scheduling. Formatting is this 2D. Wait, I keep forgetting. How is this symbol called? Okay, there we go. That and that's okay. It's gonna be colon, right? Because this is a semicolon, so that's gonna be a colon. Okay, so double colon 2D double colon text double colon scheduling. Enter. No, not enter. Sorry, just backwards like that. And that connects to, make sure that's a single line. Just click outside of the panel, right? Once you're done, don't hit enter. And that connects to the layer. This is too big for us. We don't need it that big. So we right click and we choose hide unconnected parameters. You right click on the icon here, hide unconnected parameters. Bam, it's just layer. I'm being stupid. Show all parameters. Don't forget to connect attributes to the attributes input here. Why are you the geometry and the attributes tree? Oh, okay. My mistake. A bunch of geometries, 8 geometries come in, 8 text objects come in, and only 1 attribute comes in. So it's freaking out. It does not like that. We need 8 attributes, same, to come in. So we need to repeat data. Data to repeat are the attributes. The length of repetition is going to be exactly the same length as how many text objects we have. So it's list length. That connects to the list input, length connects to the length right here. And data connects to the attributes like that. Now it's not angry at us anymore. And you will see, oh yeah, don't forget right click, hide unconnected parameters. Now this is much cleaner, much smaller, like that. And now if I click bake, bam, all of these were baked into the scheduling layer. Great. So now we're baking to a precise layer. I just deleted all of the bake, so because I need to continue before we finalize this. Okay. Now with the curves, the curves themselves, right? The curves are, where are they? The orient geometry, those are the curves that I want to bake out. And basically they already have their attributes, right? So that's going to be easy. So let's use another bake objects layer, or not layer, node. The geometry that should be baked are going to be the curves. So those are the oriented, you can see here, all of the oriented curves, bam. And all we need to do is just ask what kind of attributes are those curves using, right? So attributes. Keep forgetting attributes, elephant, attributes. There we go. So geometry connects to the attributes, and it's red. Could not find attributes on this object. Oh, because after orientation, the attributes get flushed. So we actually will grab attributes from before. That's interesting. We grab attributes only from here, from the included geometry. Bam. Okay, that's good. Basically, we are reinstating attributes to geometry after we rotate it. So we get our elephant attributes. We hide unconnected parameters right here to make it clean, or cleaner, I guess. And that's our bake for the curves. If I click bake, you can see that, you know, they bake to the correct layers. That's exactly what we want. Now, these two bakes, that's 2 button presses. We don't want 2 button presses. We want 1 button press. And that button press is going to be under. No, it should be under bake group. You can also use bake all elephant objects from this button. So every time when you press it, everything gets baked. But I would just suggest using bake group and grouping these both into the same group. Then as I press this, both of these trigger, right? This is quite useful. Okay, and that's basically scheduling. Congratulations. Print display state on. Yay. Successful. So let's see if this works properly or not. Let's go top here, lock the point. The point should never be deleted. Delete all of these. And let's just mess around with some of these. So I'm gonna add in more skylights. Boop. Okay, and I'm gonna rotate it weird. So this one is here, this one is gonna be here, this one is gonna be a long boy, this is gonna be a wide boy, like that. And all I need to do is now, let's go to the schedule to see, update, and bake. I'm gonna cry. Really? Top view doesn't bake. Question. Do I need to be in the model view to be able to bake? The answer, yes. Yes, I do. And now they are here and you can see the wide boy, the long boy, they don't fit and so on. You know, it's not ideal. I can try to make them fit, but they won't, right? So if some of them are way too big, you will need to readjust the rows and you will probably need to have multiple layouts, or you can mess around with the scales here. So I can do 6 by 5 and then let's visually actually see them like that. So that's 6 by 5 and the gap is closer. Bake those out, and this is a little bit better. This will fit a little bit better, right? So that's the scheduling of the a certain block, any block that you put in here, right? And that's the Grasshopper script. You probably at this point understand that, you know, this is not the final version of it, if that makes sense. This is only the baseline, and then you can build on more functionality on the baseline. You can build on variation and so on this, on the scheduling and script, and it's gonna work just fine. And of course, for every different block, I do suggest at the start at least using copies of this. right? So if I change this to whatever, I don't really have any additional examples here, but let's say door interior type 1, door interior type 1, then I'll be able to, you know, update and then create a schedule for that as well, like scheduling for that as well, right? And I would have two separate ones that update every time when I change things in the Rhino file, right? So that's one. Let's do one more, and then we'll look at the other useful scripts. So the second one that I promised you that I'm going to show you is automatic, how do you call it? Automatic area calculation and creation of a text list, right, for different spaces. There is an issue, and I'll explain the issue in just a second, but first the construction. What we want is we want to be able to draw outlines for our different spaces, and the outlines need to understand what number is inside of them, right? Unfortunately, for this, we cannot do it in the layouts, because this is quite interesting. In the layouts overlap in Rhino's calculation. So if I draw, example would be simple. If I draw this circle right here, shouldn't be dashed, like whatever, thin line, change. If I draw the circle right here, right? And I ask what number is inside of the circle, you might say 1.10. And that is correct, but also it's gonna say 2.2. Because you can see even here, I have selected the circle and it's still showing me the center point of the circle. In Rhino, layouts overlap, meaning I can't do inclusion checks on the layout, which means you need to do them in the model space. Sucks, but it is what it is. Under 2D layout data, there's area curves layer now. If I enable it, I have already drawn up these kind of outline curves for my spaces, and I only drew up 3 because we don't want to do too much and then to spend too much time kind of digging through it. And these 3 curves, if I were to show you in the ground floor plan, they don't, you know, they're not visible. And the reason why they're not visible is because they have a no print on them, but also just to make sure I have them hidden away when I'm not using them. Okay, let's do some grasshopper shenanigans with them. So first step is getting all of this data in. In this case, I'm going to use a different tool that's called get layer something. Sorry, reference by layer. There we go. Reference by layer. And the layer name is going to be //2D : layout data : area, I think I use underscore, area curves. Enter. Double check. 2D layout data area curves. Yep, that connects to the layer name. Bam. And as I update, I can see that it gets 6 pieces of geometry in here. That's easy. That's all of like these curves, 1, 2, 3. These 3 pieces of text, 1, 2, 3. Okay, we have that. Now I'm going to ask is which pieces of these are curves and which pieces of these are text. So I'm going to separate them. We already did that here. Filter by type. I'm going to do it again. Filter by type. Geometry connects to geometry. Object type / curve. Connect that to the object type. Now we have excluded geometry and included geometry. Included geometry are the curves. Excluded geometry are these numbers. Let's deal with the curves first. So I'm going I should probably right click and choose graph so that we work with each individual curve separately. They're in their own little list. And I'm going to measure the area of those curves like that in square millimeters. So the numbers are big. +6 means there's 6 digits, right? You multiply it by 6 zeros, right? A million. So this is in square millimeters. So what is square millimeters? How do you convert square millimeters to square meters? A millimeter or a meter is 1,000 millimeters. Square meter is a million square millimeters. 1,000 by 1,000. So all we need to do is get the area and divide it by by a million. / 1 0 0 0 0 0 0 1 million. Bam. If I check it with a panel, I can see now we're in square meters, 7.76, 6. But the numbers are ugly. There's a lot of digits after the comma. I only want 2 digits after the comma. The way you do it is actually pretty simple, but once you know how to do it, it's kind of simple. You just need to multiply. You multiply these values by 100 because 2 digits after the comma, so 2 zeros, 1 0 0. You multiply, you get instead of 7.76, you get 776. You make it into an integer. So you're basically removing everything after the comma, like that. And then you divide it by the same amount, by 100. 7.76. There you go. And then we can also use the formatting. I probably kind of want to have square meters afterwards. So let's do, or m squared afterwards. So let's do / m who alt code. If I remember square meters, alt, holding down the alt key, 253. Yeah, that's square. Like that. For each of these, this needs to be repeated. So I'm going to do, how do we do this? What's the best way? Let's actually take all of this, move it up a bit, like that. For the area, I'm just going to measure list length. I know that it's going to give me a bunch of ones, but that's fine. And I'm just going to use repeat data to repeat meter squared, length is length, like that. And basically here I get square meters, square meters, square meters. Here I get the actual number, and I'll use, first of all, merge, like that. Double check. Okay, the data trees don't match up, so right click simplify on D1 and D2. Now they match up, and then I just simply use text join. That's simple, that's easy. Bam. Okay, so now we have proper formatting, proper text formatting for the square meters. I still don't know which number they correlate to. I just have the square meters for each of these curves, right? So to get the number, all I need to do is ask basically the excluded geometry, right, are the text objects. So I need to ask if those text objects, which one of them are inside of which curve. And I can do that by, first of all, going into the text object, deconstructing it, deconstruct text, there we go. So excluded geometry connects to the text object input. I get the planes. Planes are basically points with orientation. So I get my planes, and then I can ask point in curve. Ask if that particular plane connects to point, is inside of that particular, of any particular curve, just like that. I think that's how we do it. That's how I would do it. Okay. So point in curve, we get relationship, and with that relationship, we can cull. 1 second, thinking. We get 3. Yeah, that's fine. we can cull with a pattern. So the relationship is the pattern, and the list that we cull is going to be the text. So now what this does is basically gives us information that 1.1, room 1.1 is 7.76 square meters, room 109 is 6.45 square meters, and 1.110 is 80. That matches up. That means it's working. That's great. Let's do formatting of number. One second, thinking. Yeah, let's just do a simple formatting. I guess you're getting tired. I am getting tired. 1.1 colon 7.76 M alt 253. Let's do that formatting for every row. Merge. First comes the letters. First comes the room numbers. Second comes the square meters. Like that. Make sure that it's simplified. At this point, I'm not even checking. I'm just simplifying it all the same. What do we get? Yeah, that's good. Text join. It's a lot of text joining, isn't it? And we join the text with a colon, like that. Check. Should have space at the front, space at the end. Okay, that's better. Okay, and then we want these to be in one list. Right click, flatten. And I'm going to do a little bit of a tricky, not tricky, but like a weird thing. Bear with me. I'm going to text join this list. If I just do it this way, all of them are joined into one, but I want them to be in the multi-line data list. And I can do that by // in the panel. I hit enter. So it makes a new line and use that to join. So this is the panel, right? It makes, I just hit enter so that it makes another line, and that's why it's kind of now one single entity that has multiple lines. I know it's weird. Hey, it works. We use it. Then to this text, I also want a total floor area at the end to be shown. So I'm going to use, let's do mass addition. Mass addition from all of the areas. Here we have all of the areas. Connect those there, right? So the area input connects to the input for mass addition. Grab that on here. Right click on the input, make sure that it's flattened so that the areas can actually be added up into one big result. Actually, sorry, it's not the areas because we're doing all of this nice stuff with the square meters so that the number is nice. It's the division, the final division output, where, you know, the areas are actually cleaned up. Let's connect that to the input here. You can double click on the wire to create a relay so that the wiring is a little bit nicer. And the result is 95.1. You already can see it, but let's make it nicer. Let's do / floor area or total floor area. Total floor area. Like that. Text join. First connect total floor area, then holding shift key connect the result to the text input. Check the result just to make sure that it's fine. Yep, that's a line that works. And then we basically want to add it as the last line to here. So I'm going to use another text join. First comes the first 3 lines for each room. Then the last one will come this total floor area with a number line. And then the joining thing is also going to be a break. So enter. And I guess, okay, let's just do one enter, connect. Let's see how it looks like. Whatever. Another one. So two enters. Hello, 2 enters. There we go. So there's a little bit of a gap. And that is, formatting wise, that's done. We're done. Now all we need to do is just create another point. I'm gonna reuse the same schedule place. Another point which we reference, set one point, there we go. And then for it I use same text, how is it called, like make text, construct text, attach, get, sorry, 1 second, I'm getting tired, I guess. Annotations, define text. That's the text that we define. The plane is our point. Voila. Can be placed anywhere. Dimension style, of course, we do scheduling tutorial, or is it tutorial? Wait. Scheduling tutorial. Yeah, that's the one. That's the name. Bam, dimension style. Now it's nice. Weird alignment. I would probably do a different style for this so that the alignment is nice. Let's do it. Options, annotation styles, new. I'll use scheduling tutorial as the base. Should have renamed it, doesn't matter. Edit, rename it here. Scheduling tutorial areas, like that. And then alignment, I just choose to the left. Apply, okay. Scheduling tutorial areas, okay. There we go. Now the alignment is nice. We have 3 floors that are always going to be automatically updated, and the total floor area with 1 extra space here. That shows you the square meters, you know, in total. So you can always automatically calculate things. Baking this out is also, you just use bake objects with specific attributes. No need to do that right now, because all we care about is just getting that text out there. And I believe in the schedule, yeah, it still shows up, so might as well just have it there. All right, so those are the 2 Grasshopper scripts that I wanted to show you clearly. You know, as I said, automation requires the use of Grasshopper. There's no way to do this without using it. Once you have the scripts done, you don't need to do them again. You just kind of reuse them, so that's kind of nice. You can build up nicer, more functional scripts on top of these, but hey, everyone needs a beginning somewhere. So that's that. Now let me take a quick break, and afterwards I'm going to show you the roof slope analysis and other useful things that you might need. All right, so the final thing that I want to show you is, or rather to urge you to do, is to dig around the YouTube channel, the same channel in which you're watching this current video. I have a bunch of Grasshopper, like these automation scripts that will help you design, that will help you schedule things, and so on. Will help you with your architectural design progress. One of these examples is the roof slope calculator, where I have a full Grasshopper tutorial here. I will not be showing you the tutorial, or we will not be doing it step by step, but instead I will show you what I think is a little bit more interesting. I will show you that script being actually applied to an existing project that we're currently working on. This is a completely different project. This is a completely different set of models. We're currently at this pre-proposal phase where we're doing volumetric studies for it, and basically as we're researching, as we're moving through, oh, this is a mess. Too many layers are currently opened up, have been opened up, but basically we're just kind of going through different iterations as well as different plans for the proposal. One of these iterations is this guy right here, this more jagged sloped roof type of a volume. I kind of like it. I think this in-between space, imagine this being glass. I think that would be quite a beautiful interior space to be in. And this one does require us to know the roof slopes that we are dealing with, so that there are no flat areas, right? So for that, I basically reference my original video for roof slope analysis, and I get that Grasshopper script. I already have it here. This, you will see, those of you who support the channel, you do get access to those scripts as well. And you will notice that this is slightly different from the Grasshopper script that is done for this. If I actually go through it a little bit back and slightly back more. There we go. As you see here, there's much more nodes that are being used, and the nodes are slightly different. The main things that I have changed is here I only reference these surfaces, these roof surfaces. I don't reference joint BREP roof, and then I don't extract them individually. I don't care about that, so I do that. As well as I also check for the slope, not just from the center point of every triangle to any lowest point of the triangle. I also check from the center point down to every midpoint on the edge of the triangle to see if maybe the midpoint is going to be the lowest point, right? So for example, if this point and this point are in the same position, that means that the slope should be calculated towards the middle between them. Hopefully that makes sense. So this hole is a new addition. Those of you who are interested, here it is. And it's connected to the B input of the draw arrow cluster or group, right? So if you just want to kind of follow along, you can do the tutorial, roof slope analysis with Rhino and Grasshopper, and then you just add in this portion right here and you'll be right where we are. If you support the channel, then this is going to be one of the files, roof slope analysis file, Grasshopper file in the big folder that you receive. Let's draw the arrow. Okay, my bad. This point is higher than this point, thus the arrow is drawn towards there. That makes sense. We basically are drawing arrows towards all of the, to see where the water will flow, right? We're doing that. And then let's draw the tags. This is degrees of the slope, 17, 46. Basically, I don't want to see any roof slope below 5 degrees. And okay, and then let's turn on the coloring as well. For the coloring, I will need to actually hide the geometry so that it's not in the way. Also, why do I see the points? Oh yeah, that's the middle points. Apologies. Hide those. And the coloring is going to be our mesh that is constructed out of triangles. Voila! We got ourselves the roof slope analysis that we can use to check, if the slope is sufficient. If we need to have it more aggressive in places, then we would kind of just move some control points around. In this case, this is already, I know that this is sufficient, so we're happy with this. Oh yeah, some of the areas become actually the wall on the roof, so that's 90 degrees, that's turning red, that's fine with us. And that is where, we get the information on our proposal, on our design, that this is going to be a-okay, right? As a proposal. We know that this will work. I can actually show you in the Arctic view, it's nicer. Bam. Or maybe rendered view. Let's go for that. There we go. With the rendered view, you can see better. So what do you think about the design? I kind of like it. There's the boxy version. There's a different kind of boxy version. There's the butterfly weird version. And then there's the messy overlapping, too many overlapping things version. I think too many layers are turned on currently. Actually, I think I can kind of show you. If I do something like, nope, never mind, too many things. Besides the point. The point is the roof slope analysis and other tutorials that we already have on the channel. So with that being said, this also goes into the collection. This can be used. I can't really show it properly with the house on which I was displaying this before. So thus I'm showing it to you on a completely different project, and it's also in its early stages. Right, and that kind of concludes our chapter. Now we will move on to the next, quite an exciting chapter of how do you share your model with the contractors, with the clients, and so on. So ways of how you can share your design. Really stay tuned for that one. It's going to be quite fun. So on to the next chapter. And there we are. Here's our final chapter. Actually publishing the damn thing and presenting it to the clients, to the builders, to whomever, right? Different ways of how to do it. The best ways, in my opinion, of how to do it. There are a few things that I have changed between chapter 7 and chapter 8 in terms of the 3D model, and I'll guide you through them. The most important one being that the clipping planes that I have for each plan, before I had, let's go to the layers, I had hidden the doors layer here so that it does not show up, it doesn't clip, and it doesn't show up in my plans, right, in my layouts. But now what I've done is I have selected all of these clipping planes for each floor, and I have went to their properties. Here I have chosen objects clipped, exclude selected, and I said, I clicked on layers and I chose that all of the doors layers should be excluded. Once I have done that, now I can have in my 3D model, I can have it actually, I can actually have 3D geometry doors, and in my 2D drawings that are generated, the doors will not show up, right? And then thus I can just place a block instead. Right, so that's one thing. Another thing is quite simple. I just turned off any kind of clipping from the section planes, right? You want the building to be full as you are kind of preparing exports of it. And then the last bit is I deleted the scheduling layout, because that was for a pre-proposal phase or proposal phase, scheduling is not that important. Thus, it was kind of half-assed. Don't need to have it in the final document. Deleted that, but still kind of did a chapter to show you how to do it, right? Right. With that being said, now it's time to actually publish the drawings. So publishing of the drawings is, as long as you're operating with layouts, it's very simple, right? Control P or type in print, and that will get you to the print menu, right? And then here, instead of Adobe PDF, not all of you might have Adobe, we'll just use Rhino PDF for that. Then all of the layouts are already actually, apologies for this. Let's close this and let's go to any of the layouts. Let's go to ground floor layout here. And then print. It will inherit more information from the layout, right? So all of the settings will be adjusted accordingly. That just is easier for us. So again, Rhino PDF layouts are A3 sized, that's already there. It's portrait format, that's already there. Vector output, not raster, so either lines or pixels. You always want lines. And then it should be, the output color should be according to the print color, because that's the thing that we control. View and output scale, we will go for, it should be 1:1, right? Yeah, it is 1:1, right? And now you could print out every individual layout separately, but I would suggest print multiple layouts option, where you can tick mark which ones you actually want to print, with one caveat. The caveat being, at least in Rhino 7, I'm not sure about Rhino 8, the horizontal layouts of the sections will look weird, like will be clipped off, because this portrait orientation is global rather than local, meaning that it can't be changed per layout. So because of that, I need to untick sections. And I only have I basically separately print out all of the layouts that are vertical, and all of the layouts that are horizontal are also printed out separately. With that done, 1:1, the scale is 1:1 because we're just printing a layout. Hit print. And this is going to be Rhino for Architects vertical. Save. And that's done. Successfully printed out. Let's look at it. Fit to page. Yeah, there we go. And basement floor, nothing special. I should have hatched the ground, now I realize, but still works, that's fine. Then we have the ground floor. Readable, you can see where you enter, you can see like the proper size of the measurements and whatnot. The measurements are only added here because to get a quote, for this pre-proposal phase, it's enough to just have measurements in terms of proportion rather than accurate, every nook and cranny is measured. So we have that. And last bit is the first floor. We have that. Graphically, looks okay. I mean, I would adjust, I would draw on top a few more things to accentuate the roof of the shed, the car parking roof, and just the outline of the building. I would have one more outline, a little bit thicker line, so that it's clear, so that it's accurate. But with that being said, this is still fine. Maybe a little bit of a hatch for the terracing. Okay. And then for sections, same thing, print, but this time it's landscape format. For some reason, untick the ground floor, the floor plans, and tick the sections. They fit perfectly. Hit print, Rhino for Architects, horizontal. Hit save. Voila, we have ourselves our sections. And you can see the line thickness eats up quite a bit of the information. So probably these sections should have been printed on A2 pages in 1:50 format. With that being said, pre-proposal phase, still okay with these sections the way they are. Okay, so that's basically it with the plotting. There's nothing fancy about it. Then combining the plots. Let's navigate to Rhino for Architects. Combining the plots into one PDF. If you have Adobe Reader, Adobe Acrobat Reader, then you can just right-click, combine files in Acrobat. Choose the plans to go first, and you just combine them. Also, there's a bunch of free online tools that enable you to combine the PDFs without giving you any watermark. So just Google combine PDFs online free, and you'll get a bunch of suggestions of how to do it, or tools that do it. Okay, that's the boring bit. The interesting bit is how do you share the 3D model? That's the cool bit. And for that we will use Speckle. Speckle is an app. Actually, give me a second. Okay, this is better. This is going to be better. So Speckle is an app that I primarily use to share the 3D models with the clients, the contractors, with anyone, right? And it's a collaborative, imagine this kind of a server in the cloud where you insert your 3D model and the HVAC guys insert their 3D model onto your 3D model, then the structural engineer inserts their 3D structure onto your 3D model, and it's basically a collection of models that it's kind of BIM-esque, right? It's a collection of models where everyone can place notes for everyone and so on. That's the ideal use case. In reality, for smaller scale stuff, it's really convenient to just have it on the web, to have your model on the web, your Rhino model on the web, and be able to send it to the client with a few notes. And I'll show you how to do it. One note is that the pricing that you will see if you go to, I'll put a link in the video description below for you to check out check out Speckle and to be able to download it and so on. But the pricing that you see here is going to change in a few months. They're basically moving everything into this workspaces type of a environment where everything is cloud-based, and you're basically just connecting your projects to the cloud-based service. There's still going to be a free tier, and I'll talk about that after I showcase you the system, the product, right? So first things first is you register, you create an account with them, you create a free account with them, clearly, and then you will have this you will have this dashboard, right? And in the dashboard, you basically want to download a connector for your software, and in this case, Rhino. That's what we use it for. So Rhino, you download, you install it to Windows, and you're good to go. After you restart Rhino, this this speckle tab will pop up. Actually, I should now be here. There we go. This speckle tab will pop up. In addition to that, if you right click on the bar, you can also turn on speckle mapper, which basically enables you to map your blocks and so on to Revit, to ArchiCAD. No, ArchiCAD is coming soon, sorry, to Revit. Mapping your blocks and so on to Revit. So how to apply slabs and so on in Revit. Anyway, that's besides the point, not part of the course. Part of the course is actually sharing the model. So we're back to speckle. At this point, I do like to switch to advanced mode, right? And here you won't have any projects, but we want to create a new project. So I'll click on the create, right? Here, basically, this is your account. Assuming that you have already logged in, you will see your account, and here you need to write, or optionally write, your project name. I believe if you don't write the project name, your file name will be used as the project title, so it's better to just give it a name. And I'll name this, let's give it a date, I guess. No, I'll name this usually an address, but I don't want to write an address here of the project. So I'm just going to say Rhino for architects. There we go. That's going to be fine. And is it private or not? So I suggest that you just have it set to public. So it's not private, it's turned off, right? It should be link shareable. There we go. Once you've done that, create. And it's not there. So if it's not there, you can always... Oh wait, is it creating? Yeah, it's creating. Give it a second. There it is. Okay. So after this has been created, now we have the project ready in the cloud. And if I go to speckle, if I go to projects and refresh, now I can see a project here called Rhino for Architects. And unfortunately, there's no models inside. So when I say that there's a project and you send in your architecture bit and HVAC guys send in their piping and so on, and then the engineers send in the beams and whatnot, all of those are called models inside of a project. So here in Rhino, what you want to do is you want to create a model, and for some reason I can't... Oh, that's receive. My bad. Send. I want to send a model, right? And I want to add a new model and give it a model name called architecture. Description optional, so I won't give it any description, right? That's going to be my architecture model. And selection, everything. I don't want to send everything. I don't want to send in the drawings. I only want to send in the 3D model. So instead of everything, I will choose which layers should be sent, or I could choose selection that should be sent, but I'll choose the layers. And here, nah, we will not be doing layers. That's too many layers. We'll use selection. And I will just select the objects here. Actually, let's sell clipping plane lock, so that I don't accidentally select the clipping planes. Just the model. There we go. Set current selection. There we go. So it's selected. And then we... what's the advanced? We're fine. We're fine with the settings. So set current selection, and then we send. And then we wait. It will not take too long. Okay, now once it's done, send to Rhino for Architects, view it online. I click on that. And it opens the wrong browser for me. That's fine. So I guess we watch it in the Firefox browser. It is what it is. But here it is. Here's our house. And this link I will also place in the video description below, so that every single one of you can click on it and you can explore this model by yourselves. So now let's take a look at, and imagine that you're the client, right? You're the client and you have just received this on your iPad or whatever. Different things that you can do with it. Well, first of all, of course, rotate, pan and zoom, all of these work, right? You can investigate, different characteristics, find cool angles, and just explore the design proposal. I think that works very, very nicely. But more importantly, the left-hand side, right? The menu that what you can do with this. Let's make me this big so that you can see better. And let's get rid of my bookmarks. There we go. So that there's more space. So now here, Scene Explorer basically gives me, right now there's only one model, which is called architecture. But if we would have engineering and so on, like all of these different models, you could go through them and you could look at them separately, right? You could explore those 3D models separately, and they can come in from different softwares as well. That works. And you can also filter according to, I only want to see blocks, only want to see polysurfaces and so on. You can do that kind of a object-based filtering as well. You can add tags to the objects, but I'm going a little bit too deep in this case. Okay, so that's the Explorer. If I expand architecture, I can see that it contains a Rhino model. If I expand that, it contains a proposal layer. And now I'm I'm basically going through the layer system, right? Through individual layers, and I can hide them. That's the benefit of having this kind of a system, because then I can go into glazing. I can say, well, glass is in the way, and I can just hide the glass and see what's going on inside, right? Inside of the model. So that's nice, I think, right? So that's layer based. Let's collapse everything, right? And then let's go into, well, models you already see, different models that can be added in, removed, and so on. Now let's go into discussions. Discussions are quite interesting because you can write notes. So for example, if I say, oh, I know, here, right? Here, if I literally struggled for like a minute until I realized that to actually write a note, you need to sign in. And remember when I said, oh no, it opened in a different browser, not Chrome but Firefox. I'm not signed in to this. So this was just me being stupid. If I click on sign in, there it is. Don't spam me. Let's go back to projects. Click on the architecture model in here. Okay, now if I zoom in here, I go to discussions, right? And I click on any model or anywhere, I can add a new comment and I can say, are these logs load bearing? ? And I send, right? Are these logs load bearing? And then another user can come in and they can answer me, yes, they are, and sends that, right? So now there is a discussion going on about this particular area, right? And you can consult whatever, builders or engineers and so on this way. Also clients, right? As long as they create a Speckle account, can do that. So that's nice. And then I can say it's okay, it's resolved, we're happy, no more comments. There's going to be one more thing about the comments that I'll want to show you in the near future. But before we do that, that's discussions, right? Then we have measurements. Measuring, you can do either point to point, or you can force perpendicular measuring, right? So for example, from this point to this point, that's 20.56 meters, or I can force perpendicular, which is going to be wait, that's snapping. That's weird. 1 second. Seems like the measurements bugged out a little bit. I refreshed the model. Let's see if those work now. Yeah, it seems like we're back to measuring it properly, but it's, this is just to make sure that the proportions are correct and that, that the gaps, to quickly measure the distances between points, or if you choose perpendicular measuring, Let's take a look if now that works. Okay, great, good. Now we can force the measurement to be horizontal, right? There we go. So that's what I wanted to show you, right? It figures out the horizontal plane of any measurement. Besides that, you can either snap the vertices or you can just measure whatever point in space that you want, and you can choose either measuring in meters or millimeters. Really, it's self-explanatory. Every time when you refresh the page, all of the measurements will be gone. So these are only reference-based, right? I just want to make that as clear as possible. Moving on, now we have our view modes. So here we're in the rendered view. We can switch to edges, rendered plus edges, so that you can see, the geometry a little bit better. You can go for solid. Solid doesn't rendered inherits the material as well, right? So if I were to go in here and say that the roof actually, I don't want to mess around with it too much, but we can. Let's do the concrete slabs, right? These concrete slabs, if I go to the layers tab and 1 second, slabs. No, that's going to be under landscaping. So landscape, concrete slab. If I switch their render material from default to, let's create a new one, custom, call it slabs, and actually give it a color picker. Let's go for something a little bit simple, like just darker gray, nothing fancy. Hit OK. One of them is darker gray now. I can select the whole object. I can click on send again, and then it updates. It will update the version to the newest one. Give it some time. If I look at it here, I believe I will need to, no, it refreshes automatically. That's great. Wait for it. There we go. Okay. And now you can see that all of the slabs are colored gray, right? So that's kind of nice because you can color your model as you present it to the client. It's never going to be photorealistic, but diagrammatically speaking, it's great. It's a great view, like great bridge to have. And then we have these Arctic, shaded, and pen styles, right? For different presentation modes. I usually do just rendered. Then whenever you're lost, you're kind of zooming in and so on, and you're lost, you can hit the space bar, and it will just focus in on the model if nothing is selected. If you select an object, you click space bar, it focuses in on that particular object, right? Which is really great in terms of navigation, navigating to different things and focusing on them. I believe if I space bar, no, it pans around wherever you're holding the mouse. Okay, doesn't matter. So that's this fit option right here. We just use spacebar. Light controls, this is just controlling the light source angle, right? So you can make it into nighttime, daytime, and so on. Something like this. And then you can either choose it to be axonometric, isometric, or perspective. For clients, I always do perspective, right? And I assume that they will explore the design in a perspective setting. Section tool is great. It's basically a section box here that you have that you can move around and you can adjust, right? So with the section tool, I can just move it in like so. Move that back in like so. Something like this. And explore the design this way. Very important note and very useful thing is when you have all of these, when you're making a section, like with the section tool, you can add a comment. So for example, here, I can say, for this, new comment, and I can just specify this is gonna be completely new, right? So that's my comment. And then here, this one will be cut. Or not will be cut, but this one will be kept. Right? So basically the beams in the top are kept, the beams in the bottom are completely new. And then as I kind of wiggle around and so on, or a client looks at this, they see two comments and they click on this one. And immediately the section box reappears, right? Because the comment was made with the section present, while this comment was made with the section box turned off. So because of that, it's harder for them to see. Hopefully that makes sense. Let me get rid of the discussions here. So the comments is a great function that also carries the position of the section box with them, right? Great way to do plans and so on as well, or to showcase plans. And then free orbit, I'm not sure what that does. Apologies, I haven't used that tool before, so I can't really speak about it. And now I have noticed that, let's just reset the section box. There's the AI render, a new thing. Okay, so we can actually, let's try, let's play with this. So, minimalist Scandinavian villa with large glazed facade in a dense pine forest, soft light, foggy environment, dawn, something like that. I'm purposely not giving it any style suggestions. I just want to see what kind of a render it will make. This is kind of fun thing to add. While this is doing its thing, I'm against AI, AI rendering and so on. But hey, that's fun. That's fun. Okay, so you can also play around with AI generated stuff. It's bad. It's bad. Like the whole design has been completely destroyed by this. What the hell is that? There's nothing here. It's just garbage. Anyway, but it's a fun toy. I think. So we ignore this. And we just play with this for. You can play for it 20 times until you need to pay for it. Don't pay for it. I wouldn't. Anyway, moving on. So with this whole thing showcased, that's the way of how you present things. There's more things to Speckle than that. You can collaborate on the same Rhino model together with another person. I'll show you that, like collaborative modeling. I think they call it multiplayer modeling, something like that. And then you can also parse, you can push through data such as floor plan, area, and so on into the preview as well. I'll showcase those two things. But before I do that, I kind of want to talk about pricing, because since that is going to change, I don't want you to... I want it to be as transparent, as clear as possible. So let's go on to see some pricing changes. All right, so there it is. This is the current situation of things. These pricings, or this pricing will change to a new one in next 2 months or so. And basically, if I were to, I guess this breakdown makes it better. They are moving, Speckle are moving towards workspace mode, where everything is going to be done in the cloud. So all of the sharing and so on is going to be done in the cloud, in these workspaces. And because of that, the free tier will be adjusted. Right now, the major things are that the projects as well as the models are all unlimited. But if I look at the new pricing, the projects, you will be only able to store one project at a time in the for the free tier in the workspaces. right? But inside of that one project, you will be able to have 5 models, right? So architecture, HVAC systems, plumbing, and so on. Like you will be able to have 5 of those inside of the project. And then any comment or any discussion that you have will be held for 7 days, and then it's going to be archived, right? So that's the limitations. Basically, they're throttling down of how much resources can you take for free from the cloud service. Still, unlimited amount of members and guests that can view, that can interact with your model, and unlimited amount of unregistered, like completely out of nowhere guests that are just kind of taking a look, the clients that are taking a look at the model. So I don't see this as a problem at all, considering that this is free, completely free. And then you can see that the starter pack, where you get like 5 projects, so this is like a small team of people or a very productive individual, 5 projects at a time with 25 models, with comment history of 30 days. That is now much cheaper than what it used to be, right? So 15 pounds per month. I don't know why it's in pounds, but whatever. So 17 euros per month becomes $9 or so, like 8 euros, something like that. More than twice cheaper. Yeah, make it up by yourself. So if this is worth it or not, there's no argument to be made that free is not worth it since it's free, right? So I would suggest kind of testing it out with the free version, and then if you want to grow your presence with Speckle, then moving on to the more the paid ones, right? Once you actually know how you will be using it and which points, which pain points will you have during the free version, in the free version. So that's kind of that in terms of the most basic, like regular way of how I use Speckle. And now I'm just going to show you just 2 more extra things that I find to be quite intriguing, quite interesting about this software, and then we just move on. We move on to actually finishing the course, right? This is the last thing about the course. So, all right, let me show you a few things. Okay, let's do multiplayer modeling. Actually, before we do that, there is one thing that I will note that I will not be showing you in practice, simply because I don't have the expertise to show it in practice. There are tutorials on Speckle's YouTube page on how to use this, but Speckle for Business Intelligence, basically reading Excel spreadsheets, reading any kind of data and feeding that into the Speckle viewport to see, amount of rooms, room floor area, and so whatever you want to be parsed as information, and thus the geometry to be colored accordingly, blah, blah, blah. You can do that with Speckle, right? So it's not just about the immediately present visual data, but it's also about the numbers, right? That can be showcased. I think that's cool. If you're interested in that kind of stuff, definitely check that one out as well. But what I'm interested in is collaborative modeling. If I go to my projects and I go for Rhino for Architects, I go to collaborators and I invite to project one of the collaborators. Who can edit this model, right? There we go. Then once she accepts the invite, we will be able to model the same model from different computers, and give her a second to accept. All right, and then if I remember correctly, we go to workspaces and create a new workspace, like so. I'm giving it a name. Yeah, let's do Rhino for Architects VS workspace. Right? I continue and I invite her to be part of this workspace. Okay, continue. This is where, it basically will, at this point, it asks us to choose the 30-day free trial, but with a new pricing scheme, you're just going to use the the free version, right? So start 30-day free trial. We're good to go. The workspace has been created. Then I can move my existing project, Rhino for Architects, into this workspace. Bam, that's moved in, right? And now basically once Aya accepts the invite to the workspace, she's going to be able to receive this file into your Rhino model. All right, I switched to the dark mode. So now you will notice that since I migrated the model, the project, into the workspaces, it will not be available here in the regular ones. That's because now it exists in the workspaces and it's shared with Aya, right? So we can operate on that individual individual basis. And here I just opened up a completely new Rhino file, right? I can see that my project is still located here, and if I click on it, I can actually receive it, right? And this is what she has done as well. She clicked on this receive button, and then model, she chose architecture. For receive options, she updated and tick marked auto receive, right? Once that is done, we just click on receive, both of us. And from now on, we basically, any changes that we make will be synchronized with the original Speckle file. So let me give you a quick example, or yeah, the Speckle workspace. Let me just auto cplane here. Let me just make a box, weird ass box sticking out from here, right? And then if I believe I don't even need to send it. Do I? I will just in case send it. And now I'm gonna go and check if it has been updated on her side. 1 second. Right, I can confirm that has been updated on her side. She just got a pop-up saying update available, and she got that. And now I'm just going to wait for her to do something with the model. All right, so she modeled something out, and if I click on this little light bulb here, you can see that now this grayed out preview pops up, like these new, okay, beautiful table with some seating pops in, right? And if I agree to get this into my 3D model, I can then click on receive. If I just want it to be there as a reference, you know, to see what she's working on, then I don't even need to click on the receive. I will just see, you know, this model being constantly updated every time when she presses send, if she didn't automatically make it so that it automatically sends, and every time I click on this little balloon icon to make sure that it synchronizes. I believe the updating is automatic, meaning that as long as the light bulb icon is lit up blue, it is going to constantly be updating, and every time there's new stuff added, they will just kind of pop in. But I honestly prefer to have this turned off, would prefer to have this turned off, and then only kind of enable it when I want to check, because I assume loading and unloading of data will have a little bit of lag in terms of the modeling performance. With that being said, if I want these, I just click on receive, wait for it a little bit, bam. They're now here, beautiful. Well, actually meshes have been received. So, hey, it is what it is, but we have the model, right? We have the model in here. And that is kinda it. That's like the shared modeling, sending it back and forth with semi-automatic synchronization. I think for teamwork, this is great. One side note, it works much better and if everyone has Rhino 8 rather than, you know, some team members having Rhino 7. But at this point in time, I believe most of you who are watching this video will have Rhino 8. All right. With that being said, I believe we're at the end of this course. Let me make myself a little bit bigger. So, whoopsie. I hope you enjoyed this course. I hope you found it valuable, the information given valuable. Of course, the information, like the course length is what, 8 hours or so. So we didn't even manage to reach the design development phase with the things that I explained, but, and it's an important one, the design development phase compared to the proposal phase of the project in architectural setting is much more streamlined, much more of a repetitive thing, that if you already have the layer system, if you have the layout system, if you have the clipping plane system, line types, dimensions, and everything set up, if you have the correct blocks and you know how to operate with the blocks, the design development phase is going to be pretty easy, is going to be pretty kind of straightforward. Compared to Revit, compared to Archicad, compared to AutoCAD, Rhino is going to be slower than these mammoths of a software, right? Because it's not optimized just to do architecture, it's optimized to do many different things, right? And architecture just happens to be one of them. Sorry, I had to switch to a nicer view. Couldn't stand the shaded view. There we go. Where was I? Slower. Rhino is slower, right? It makes boats. Boats can be made with it. Ships, airplanes, cars, buildings, urban plans, anything. I made a robot once, a robot character once in Rhino. So you can make anything with it, and since it's so generalized, it will be slower at a specific type of geometry, or specific tasks rather, not type of geometry, sorry about that. But the benefits of having a generalized software is that it does not limit the way of how you think. Object-oriented modeling has certain limits that it imposes on you, on your head, on the way of how you construct and think about architecture, and Rhino doesn't. So, in my opinion, for small-scale architecture, that is a very good price to pay, to not have those limits. And for large-scale architecture, that becomes a little bit harder of a sell. At that point, I would encourage, larger companies to actually use Revit and Archicad, BIM software for later stages of the development, so the design documentation phase. While for smaller scale stuff such as this, for proposal phase, for this design development, for the documentation phase, Rhino is plenty enough. Hopefully my blabbing makes sense. At least to me it does. If it doesn't, write in the comments what's unclear, the use cases, the niche cases, and so on. We can have a discussion in the comments about it. I do read them. Yet again, to sell out, all of these files that I have made here are available to Patreon supporters as well as YouTube members. So if you just want this whole package, you can get them if you just support the channel. If not, then hopefully following along, step by step into what I was doing with your own files, that shouldn't. I constructed the course so that it wouldn't be a problem and it would be as seamless as having the file on which I'm working on, right? And I guess that's it. That's kind of it with this course. The next courses are going to be more about this project. They're going to be about rendering of this project. Later down the line, I do want to make a Rhino course specifically for interior design and interior design documentation. That's going to be coming ahead. So, if you're interested in that kind of stuff, subscribe. Also, virtual reality. There's going to be a lot of virtual reality stuff in the most likely either late spring or early autumn. We'll see. I'll see you in the next one. Later.